Hi guys, a very good morning everyone. Welcome everybody to the next marathon session. The GATE 2024 revision sessions are there for you, and yes, today we are going to have another important subject, that is the EMFT, electromagnetic field theory, and the contents that we are going to cover today is going to be common for EC and EE. So that is the whole sole reason. Otherwise, every subjects we are covering in one shot completely, but this we are going to take because the syllabus for EC and EE is partially common, and then the rest of the topics are only EC. So yeah, today we cover those areas which are only for the EC plus EE combined branch. That is, of course, the areas of electrostatics, magnetostatics, time varying fields, okay, boundary conditions, all that will plan to cover. And other than that, then tomorrow, very good morning everyone. Okay, then tomorrow we will have the separate discussion, okay, for the extra exclusively EC syllabus. Okay, that means the transmission lines, wave propagation, antennas, wave guides, that we'll be focusing today. So quickly update all your friends that the session is live. Okay, let everybody join quickly. Come on everybody, guys, let all of your friends also join quickly. Share the session. Okay, share this session to different telegrams as well. Right. Very good morning everyone. Good morning Ashish, Akansha, Sonali. Good morning Dreamer. Okay ji. Okay, so yeah, very good morning everyone. Just a second. All right. Quickly keep joining, guys. Quickly keep on joining. Okay, let's start then. Okay, chalo. So people will keep joining. Let us get started by the time. All right. Okay, so there's a regular introduction you must be aware about. Now let's move ahead. Okay, and the important updates that, yes, guys, the coming Sunday, 21st of January, you get a chance to appear in the National Scholarship Test. Yes. Okay, appear in the National Scholarship Test, get as much as up to 90% scholarships based on your performance in the test, and hence take a next step towards the success in the GATE examination. You can appear on the Sunday at any time from 9 a.m. to the 9 p.m. And yes, guys, what are the 7 golden rules to ace the GATE in the first attempt? Okay, the fundamental rules of the game to make you sure that you are successful in the first attempt. A free live interactive workshop just today. Okay, Wednesday at 7:30 p.m. on the BYJU'S exam prep app to be taken by me. So you can also connect on the app at 7:30 p.m. in case you're targeting GATE 25 and looking to really rock into the examination. Okay. So guys, this is the marathon schedule, that is there in front of you. Today we are discussing the EMFT EC plus EE part. Tomorrow we'll have the exclusive EC part. Okay, tomorrow we'll have the exclusive EC part, but provided you have to ensure the attendance. Okay, right. So yeah, you have to ensure the attendance. Chalo. So with engineering mathematics part 1 and part 2. So the now big event is Saturday, Sunday engineering mathematics. Okay. Yeah, questions will also be there, Basha. Okay, so engineering mathematics part 1 and part 2 coming up 20 and 21st of January. Okay, in 2 different parts are Saturday and Sunday, and then the following by it signal and system on 23rd Jan. Okay, this is the updates, and yeah, this is what it is, guys. The complete engineering mathematics marathon on the YouTube. The complete engineering mathematics on the YouTube, the revision marathon, okay, to be held on 20 and 21st of January. Okay, Saturday and Sunday. Stay updated for it. Okay, stay tuned, and it's going to happen on the same channel, so you can subscribe it. You can subscribe it. And also, guys, before we come live on Saturday, Sunday, Friday, a small discussion. Friday, 5 p.m. How to score 13 out of 13 in maths. What can be the strategy? First of all, because around just 15 days will be left. Okay, around just 15 days will be left. Okay, so what will be your target? What should be your target? How to ensure 13 out of 13 in the maths? Okay, so we'll have a strategy, and based on the strategy, we'll work out the complete marathon also. Timing for the maths marathon, same, it will be 10 a.m. We'll keep it at the 10 a.m. Okay, guys? Okay. So let's get moving ahead now. Let us get moving ahead and let us get started with the fundamental thing that you need to target is Coulomb's law. A quick revision of concepts and formula, and basic question practice also will involve. Okay, of course. Okay, derivations not required in the revision phase. Okay, so Coulomb's law, which fundamentally says that force between any 2-point charges. Okay, force between any 2-point charges, say Q1 and Q2. Okay, now any charge in the space will also have some coordinates, will also have some location. Okay, will also have some location. So let us say this is the charge Q1 and this is the charge Q2. Okay, it is located at some point in the space, okay, which may be A. Another will be located at some point in the space B. Okay, both of them can be mentioned as both of them can be mentioned by their respective coordinates x1, y1, z1. Okay, this can be mentioned by x2, y2, z2. Right. Now, force between 2-point charges as per Coulomb's law is proportional to both of the charges, okay, and is inversely proportional to the square of the distance between them. Okay, the magnitude of force as per the Coulomb's law is proportional to Q1, also proportional to Q2, I mean individually proportional to both the charges and proportional to 1 by r square, inversely proportional to the square of the distance. So eventually the force is proportional to Q1, Q2 by r square, and hence, okay, we introduce the constant of proportionality here, K. Okay, Q1, Q2 by r square, where K is the constant of proportionality. Okay, where K is the constant of proportionality given by 1 upon 4 pi epsilon naught. Given by the value 1 upon 4 pi epsilon naught. Right. Now, whenever you need the value of epsilon naught, okay, always remember in both the formats, based on the data you can use. Okay, the epsilon naught can be written as 1 upon 36 pi into 10 raised to the power minus 9, and it is equivalent to 8.854 is multiplied by 10 raised to the power minus 12, and then as I told you, K is 1 upon 4 pi epsilon naught. Okay, if I talk about free space, okay, putting the value of epsilon naught 1 upon 36 by 10 power minus 9, K will be 9 into 10 power 9. I suggest you to remember these values because very commonly they are used. Okay, not only in the Coulomb's law but in throughout our discussions. Very good morning all, keep joining. Okay, good morning Bhanu, good morning Hari, Meghna, Gate 24, Ashok, very good morning all. Okay, now this is the magnitude of the force. Now the force is always a vector quantity. Okay, now this, when I say this force, I have written the magnitude of the force. Okay, now when I want to write down the force, the vector quantity, we can write it as magnitude and the unit vector along the line joining the point A and B. Yes, the direction of the force is along the line joining the point A and B. Okay, so we are just gonna connect these two. Okay, we'll be connecting these two. Okay. Okay, we connect these two, and let us say there is a vector r, okay, which is the vector r joining the points A and B. So what is the vector r joining the points A and B? I can write it as AB. So what is AR here? Okay, AR is the unit vector along the line joining the points A and B. So how do you write down the unit vector? So dekho, K Q1 Q2 by r square. This is the magnitude part. Okay, this is the magnitude part into the unit vector r. Unit vector r further can be written as vector r divided by its magnitude. Okay, so eventually it can be written as in the vector form K Q1 Q2. K is 1 upon 4 pi epsilon naught. K Q1 Q2 by r cube into the vector r. Like I have mentioned R12. R12 means a vector from 1 to 2. Okay, so F12, force on 2 due to 1. When I say F12, it is the force on the Q2 due to the Q1. Okay, so this is the representation of Coulomb's law. Acha, now you want to calculate R, okay, which is AB. How do you calculate R, which is the vector AB? It is the vector B minus vector A. Okay, second minus first. OB minus OA. Acha, what is OB minus OA further? What is OB minus OA? Hope you know it. Okay, let's apply this to the problem, and I hope you know it. Okay, corresponding x to x, y to y, z to z components will be subtracted. Okay, and we'll apply this to the problem. Okay, now let us also talk about a very simple idea here. Let us also talk about a very simple idea here. Okay, we know that whenever two charges are close to each other, they will be having a force of attraction or repulsion. Acha, now that is very clear. As I have told you, the force is along this direction. That is the direction from A to B. R is from A to B. Okay. But the charges, the sign of the charges may also be considered. Na? Let us say both the charges are of same sign. Let us say both the charges are of same sign. Okay, so this product will be positive, either both positive or both negative. Both are of same sign. The product will be positive, and the force is indeed in this direction. Okay, indeed in this direction. That means the Q2 is being repelled. In this direction means Q2 is actually being repelled by Q1. Okay, because they are of same sign. Like charges repel each other. But suppose they are of opposite sign. Okay, if they are of opposite sign, 1 plus 1 minus, the overall force, the product will become a minus sign and overall force will be in the negative direction. What is minus R? Okay, anti-parallel it becomes. So force will now be acting actually in this direction. That means Q2 is being attracted towards Q1. Q2 is being attracted towards Q1. So that is very clear fundamental points. Okay, so if it is, we know this theory already, nothing new. Like charges and unlike charges. Okay, so like charges will have a force of repulsion, unlike charges will have a force of attraction. Okay, that is clear to everybody. That is clear to everybody. Okay. Acha. Now that means whenever two charges are close to each other, they are going to have a force of attraction or repulsion, something like that. Okay, so what I can do is now, let us say that there is only one particular charge. Okay, and then there is another charge, and then there is another charge, that is the QT. Okay, then there is another charge, that is the QT, but that is actually initially far away. That is initially far away. That means the distance that I'm considering is large. The distance that I'm considering here is basically large. Okay, initially it is at a large distance. Okay, let us say this is the distance which is large. And because this is a large distance, what is going to be the force that will be experienced by this particular fellow? The force experienced by this fellow will be tending to 0. The force will be tending to 0. Negligible force. Okay, because the force is proportional to 1 upon R square. If R is large, R square will be much large. Okay, so force will be very small. The force will be tending to 0. That is acting on this particle. The force is tending to 0. The force acting on this particle is going to be tending to 0. Clear, everybody? Okay, that is going to be 0. Okay, but now if I somehow bring the charge somewhere here, if I bring it here, or maybe if I bring it here, anywhere, okay, not necessarily any one of these two, if I bring it anywhere but slightly closer to Q, okay, then it will start experiencing some force because I have reduced the distance between them. Okay, then it experiences a force, and in these two cases the force experienced by the particle, suppose that is Ft, let me say the force experienced by the charge Qt is known as Ft, and what is going to be the Ft? It is Qt by R square as per the Coulomb's law. Magnitude की बात करते हैं. As per the Coulomb's law, it is known as Qt by R square. K into Q into Qt divided by the R square. That is the value of the force Ft. That is the value of the force Ft. K into Q into Qt is divided by R square. Is divided by R square. Clear, everybody? Is divided by R square. Okay, now this is the force which is proportional to both Q and Qt. Okay, now I want to see the effect of this source. This is my source charge. I call it as source. Okay, I call it as source charge, and this is my test charge. Okay, whenever any particle is brought closer to the source, that particle will experience the force. Now suppose that particle was unit charge, then what is going to be the force experienced? Okay, yeah, let us say I want to normalize the force with respect to Qt. I want to see what is the effect of the source here. Okay, so when I normalize with Qt, I get the quantity kq by r square, and this is actually the force which will be experienced by a unit charge placed around the source charge. This is very evident now that whenever you bring any particular charge closer to the source, okay, that particular charge, when you bring it in a particular region, see, if it is far away, it doesn't experience any force. But when you bring it in a particular region, it is going to experience a force. Okay, that simply shows that around the source, there is a force field. Okay, there is a field, where every charged particle can experience a particular force, and that force field will be known as the electric field of, the source charge. This is going to be known as the electric field of what? Of the source charge, and that is given by E. Okay, that is the force experienced per unit test charge, kq by r square, or you can say that that is the force experienced if you place a unit charge in the presence of the source charge. Okay, kq by r square. Okay, bringing in the vector form, so you can, let's have the vector forms also. So this is what is the idea of the electric field. Okay, this is what is the basic idea. Quickly revise kar rahe. Electric field intensity, which is the force per unit charge when placed in the electric field. It is the force per unit charge, okay, when placed in the electric field. Force per unit charge when placed in the electric field. Okay, when placed in the electric field. Okay, so let us say you have a charge q in the fixed position, and suppose that's what I have done already. Okay, let's come to the final point. Okay, the electric field is the force per unit charge when placed in the electric field, and see, already I've written the formula kq by r square, that is the magnitude. What about the direction? So direction is, what is the direction of the force, because q is a scalar quantity. So direction means that is decided by ft, and the direction of ft is along the line joining q to qt. Okay, so you have to calculate the vector from the source charge towards the test charge. Okay, that is known as the vector AR again, and AR is vector R by R. Okay, AR is vector R by R. Okay, again, let me put it like this. Say this is the source. Okay, and this is the point of observation. Okay, where I want to calculate the electric field. Now there is no test charge. Okay, now eventually I don't place any test charge. Okay, that test charge was there to demonstrate that there is going to be some force here. Okay, if I place a test charge, it is going to experience a force. Force upon charge is known as the electric field. So this point has some electric field. Whenever you place a charge, that will experience a force. Okay, so this has some electric field, and what is the value of the electric field? To calculate, let us say I have the source at the point A. Okay, first of all, as I told you, you need to calculate the vector R, that is the vector from A to the P, point of observation, and A is the source charge. A is known as the source charge, and the electric field in the vector form, as I told you, is given by, okay, ye ho gaya magnitude and then the unit vector AR. Okay, if you place the value of the unit vector is the vector divided by the magnitude. So that is why it becomes kq by r cube into vector R. Again, how do you calculate vector R? Vector AP. How do you calculate vector AP? The position vector of P minus the position vector of A. OP minus OA. Okay, again, we will put this on the calculations. Okay. Now, electric field, okay, F by Q, as we just noted, is F by Q. So one of the common units can be F by Q. Force is Newton, charge is Coulomb, so it can be measured in Newton per Coulomb. It can be measured in Newton per Coulomb, but more commonly in the form of volt per meter. Okay, more commonly because of its relation with potential that we will explore little later, but more commonly it is in volt per meter, or it could be measured in Newton per Coulomb as well. Okay, Acha, as I just told you, that where should I bring the test charge? I can bring the test charge, dear, anywhere. Okay, from here I can bring here also. Okay, from this point I could have brought here also. Okay, I bring the test charge anywhere around the source charge, it is going to experience the force. It is going to experience the force. So okay, I can say that where is the electric field? Okay, is it only in this direction or is it only in this direction? I gave you only two examples, but where is the electric field due to the source? You can place the test charge here also, 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 here also. Okay, then correspondingly, okay, you can have electric field which is in these directions. Direction of electric field is from source to the test charge, na? So where is the electric field? Where is the electric field? Electric field can be in any direction around the source. I can say, na, electric field can be in any of the direction, okay, around the force that is in the radial direction. Okay, and hence we are going to define this electric field by the help of radial lines. Okay, all of these lines, okay, radial lines passing through the origin. Okay, so that is what, okay, electric field. So say this is the source charge. This is what is coming up here. Let us say this is the source charge. The electric field due to it is everywhere around it, okay, in a radial direction. What do I mean by radial direction is ki suppose, okay, suppose you have a sphere constructed around the sphere charge, okay, around the sphere. It's not circular. Don't take it as circular. It's a 2D plane, but in general, okay, it is radially outwards, means any direction. So you can call this as the center of a sphere, okay, and electric field is in any direction from the center to the circumference of the sphere, okay. Everywhere, चारों दिशाओं में, ये ऊपर नीचे दाएं बाएं नहीं, but also up, also outwards of the screen, backwards of the screen, like that. ठीक है? we represent as electric field by the electric field lines, which are hypothetical lines. Okay, we draw it to show where the electric field existing. There is no physical line present here. Okay, they are also known as direction lines or the stream lines. Okay, they are known as the electric field lines. Very important. Okay, now we'll talk about this point. Electric field always flows from higher to lower potential because of the relation with potential. We will learn that. Okay, why it flows only from higher to lower potential? Because of the relation that we are going to discover after some time. Electric field is known as the negative of the gradient of the potential. Okay, and then electric field does not exist inside a perfect conductor. We'll see once we go to conductor cases and boundary conditions also. Okay, electric field does not exist. Some important points I am highlighting right now. Okay, electric field lines never form a closed loop, at least one monopole. Okay. Now, magnetic field lines will always form a closed loop. Now, coming to the second point here. Okay, suppose I take, okay, the separation between these two lines at a particular distance, and look into this separation, dear. Okay, look into this separation. Okay, suppose this is some distance d1. Okay, and this is some distance d2. Yeah, length ki baat kar lete, length of the arc. Okay, L1 and L2. Okay. Right, let us take this as some point A and this as some point B. Tell me dear, which of the length is greater? Which of the length is greater? L2 is greater than L1. L2 is definitely bada dikh raha hai na? But the point B I have taken to be far, and we know that. Okay, we know that the electric field is inversely proportional to the square of the distance. Okay, higher distance. Okay, higher distance. So, you know, this is distance, suppose R2. Okay, and this is R1. So we can clearly say that electric field at B is less than electric field at A. Higher distance means lower field. But at the same time, L2 is greater than L1. So wherever electric field is less, there the separation between field line is more. Vice versa, wherever the electric field is more, there the separation between lines is less. That means electric field lines are more compact. They are more closer to each other. They are more densely populated. Okay, so spacing of the lines is inversely proportional to the strength of the field. The spacing of the lines is inversely proportional to the strength of the electric field. It is inversely proportional to what? It is inversely proportional to the strength of the field. Inversely proportional to what? Inversely proportional to the strength of the field. It is inversely proportional to the strength of the field. Okay. Okay. Chalo. Now next one. Now let's have some fundamental questions also coming up here. Okay, fundamental question also coming up here. Okay. Tell me. Q is equal to 4 microcoulomb located at P1. Q2 is equal to minus 5 coulomb located at some point P2. What is the force F2 on Q2? Okay, let me fundamentally draw the diagram first of all. So what is the diagram coming up here? Okay, this is Q1 and this is Q2. Okay, and they are located at some point P1 and P2. Okay, the point P1 is given by 3, 11, 8. Another point P2 is given by 6, 15, 8. And let me join them. Okay, let me join them. Okay, let us say this is the vector R. This is the vector R, which is the vector from P1 to P2. And this is the charge Q1. This is the charge Q2. The values of Q1 is 4 micro. Q2 is 5 micro. Let me first start here by writing down the value of the vector R. And as I told you, it is from P1 to P2, and the vector P1 to P2 is known as, everybody keep solving, OP2 minus OP1. OP2 minus OP1. Okay. OP2 minus OP1. Okay, now what is OP2? Now that's what I'm telling you. How you subtract that also you'll understand now. Corresponding x to x, so 6 minus 3. Corresponding x to x, 6 minus 3 AX plus 15 minus 11. Okay, along the y direction, and plus 8 minus 8, the z component will become actually 0. Okay, ax, ay, az, you know, is the unit vector in the x, y, z direction. So this is 3ax plus 4ay. Okay. So I can write here what is the vector r, and that is given by, vector r is given by 3ax plus 4ay. 3ax plus 4ay. So unit vector ar okay, is the vector r divided by magnitude r. Acha, what is going to be the magnitude r? R means, only r means magnitude of this vector, and magnitude of the vector square root x square plus y square plus z square under root 3 square plus 4 square will be equal to the 5. Will be equal to the 5. Okay, the magnitude 5 ho gaya. Okay, so now I want to calculate the force on Q2. Okay, so that force F12 bhi likh sakte hain, or simply F. Okay, K Q1 Q2 by R square. That is the magnitude of the force, unit vector AR. Okay, or you can also write it as K Q1 Q2 upon R cube into the vector R, because AR is vector R by R, so R cube hoga, as we know these forms. K is 9 into 10 power 9. Okay, Q1 Q2, Q1 is 4 micro, 10 power 6. Q2 is 5 micro, minus 5, 10 power minus 6, divided by R, which is 5, the 5 cube, into the vector R, which is 3AX plus 4AY. Okay, and then there will be the answers to be followed up, so come on. Okay, it's going to be how much? Yeah, let me just calculate. Yes, guys. Let's quickly calculate. For minus ek aayega. Okay, so minus 4.32 with AX after multiplying by 3 itself, and 5.76, that will be in the form of plus 5.76 with AY. Acha, 10 power 9 and 10 power minus 12, 10 power minus 3 will be left, and that is known as milli. Okay, and we are calculating force, so that is Newton, so it should be millinewton. Okay, it should be millinewton. So the correct answer is, okay, nahi, minus totally outside nahi aayega, that was not totally outside na. Actually totally outside only, sorry, bahari hai. Minus is there to both. Okay, so minus 4.32 plus 5.76. Okay, in the form of millinewton. Yahan pe dhyan rakhna unit ka specially. That is not Newton, it is actually millinewtons, and hence the answer is C. Clear hai? Hence the answer would be equal to the C. The answer would be equal to the C. Done it, done it, done it, done it. Let us come here. Calculate the electric field intensity at the point 345 due to a charge of 5 nanocoulomb placed at 1, 2, 3. Similar calculations will apply here. Okay, electric field intensity at the point P, which is 3, 4, 5. Okay, due to a charge of 5 nanocoulomb, due to the charge, that is a source charge, which is placed at some point. Okay, that is suppose A, and that is 1, 2, 3. Okay, this is known as your source. Okay, that is the charge, which is 5 nanocoulomb, placed at the point 1, 2, 3, and this is what is known as the point of observation. I will in short call it as POI now. Okay, point of observation. Okay, point of observation. Okay, so now this is the vector R. This is going to be the vector R. Vector R is the vector R from A to P. Okay, let us complete this. Here, vector R is the R from A to P. Again, OP minus second minus first point. OP minus OA. So when you subtract x to x, it's going to be 2AX. 4 minus 2, y to y, that's going to be 2AY. Okay, 5 minus 3, 2AZ. Okay, that is the vector R. Okay. Okay, so vector R is basically, you can take 2 common, twice of AX plus AY plus AZ, and vector R is the magnitude of it. See, what is the question? Remember, chalo, isko chhod do. Electric field intensity, only I need the intensity. Only I need the intensity. If I say calculate the electric field, that is okay. I want only the electric field intensity. Okay, so that means, yeah, I want this R definitely, mod R, and what is the value of the mod R? Okay, 2, and then under root of 1 square plus 1 square plus 1 square, that is 2 root 3. So what is the value of field intensity? Okay, mod E, let me write down here only, it is given by KQ by R square. K is 9 into 10 power 9 into the Q. What is the Q? 5 nanocoulomb, 5 into 10 power minus 9 divided by R square, and R is 2 root 3. 2 root 3 ka square. Okay, eventually to calculate R, you can directly calculate the distance formula as well. Okay, so now it is simply 45 divided by 4 3s are 12. 45 by 12, and let me put down the final numeric value. Okay, 3.75 volt per meter. Okay, 3.75 volt per meter. We can put it like this. Okay. Yes, Madhu, it's under planning. It's under planning. We also hope to start it soon. Hari is asking. Yeah, Hari, I think you have got your answer also. ठीक है, चलो. Next one. Okay, next one. Simple. Okay, in terms of intensity only. If vector is also a complete electric field vector required, then also you can solve because we have calculated the vector R also. Okay, a point charge is located at the origin. It's a MSQ question. It's just understanding of the electric field and its direction. Okay, a point charge is located at the origin, and at the point A, the electric field is E1. At the point minus A, the electric field is E2. And at the point minus A, minus A, the electric field is E3. Which of the following is or are correct? Which of the following is or are correct? Okay, multiple select question. A point charge has been located at origin. Okay, let's draw this picture. And it's only 2D picture. The points are just X, Y. A. Okay, minus A, and minus A, A. There are the 3 points that we need to focus here. Okay. So I have the point number 1, A, A, where the electric field, so A, A, of course, both positive. It's a point that's going to lie within the first quadrant. Then there is some another point, minus A, X being negative. And the next point is minus A. Achha, when I join it with respect to origin, na, point charge Q is located at the origin. Okay, the point charge E is located at the origin. Okay, the point charge Q is located at the origin. At the point A, A, at the point A, A, electric field is E1. At minus A, A, electric field is E2. And the point minus A, minus A, electric field is E3. Very much clear from the picture that E1 and E3 are in opposite direction. Straight line, same straight line, but opposite to each other. Okay. Okay, same straight line opposite to each other. Okay, so very clear, E1 and E3. Okay, same straight line opposite to each other. Okay, because this is A, minus A, same slope, M equal to 1. It's a same slope line. Okay, so these two vectors are anti-parallel. Parallel to nahi, anti-parallel, but whether it is parallel or anti-parallel, okay, the sine theta will be 0. Now, for anti-parallel, theta is 180 degree. Okay, so what's going to be their cross products? One of the option is going to be asked as the cross product. Okay, in one of the options, they have E1 cross E3, correct? Look into it. Okay, so E1 cross E3 is going to be 0, and hence its magnitude will also be 0. Okay, E1 cross E3 is 0. Okay. Then very clearly, so देखो अब अगर यहाँ पे angle की बात करना है, this is A, A dear, तो how much is this angle? Tan inverse A, tan inverse height upon base. Okay, 45 degree. Okay, if this is 45, by the same logic, this will also be 45. Okay, so from the straight angle, 180, 45 reduced, so this is 90 degree. So very clearly, the next argument that I am placing is E1 is perpendicular to E2. E1 is perpendicular to E2, theta 90 degree hai. So their dot product will be 0. Dot product between perpendicular vectors is 0. So E1 dot E2 0 hoga. Okay, E1 dot E2 0, E1 cross E3 0, and hence is modulus 0. E1 dot E3 will not be 0. Unka cross product 0 hoga. Mod E1, mod E2, mod E3. Acha. Dear, the next argument is mod E is given by the formula KQ is divided by R square. The mod E will be given by KQ by R square, right? Now, we are talking about the electric field. We are talking about the electric field due to the same charge. Okay, and also the distance of all the 3 points. Okay, let us say, the R1 distance r1 and r2 and r3, will it be same or not? By what is the distance a comma a? Under root a square plus a square, distance formula. But even minus a comma a, under root minus a square becomes same. Here also under root minus a square plus under root minus a square, same you get. All the three distances are equal, and that is why mod E1 is equal to mod E2. Magnitude of electric field at all the 3 points, because they are all equidistant, that is known as the equal electric field. Okay, so for this MSQ question, placed here, the answer is A, B, D. Three choices are correct here. A, B and D. A, B, D. Correct everybody? Correct. Chalo. Now let's come to the next question. It is required to hold a 3-point charge of plus q coulomb each in equilibrium at the corners of equilateral triangle. A good question sometimes. It is required to hold 3-point charges, okay, of plus q coulomb each in equilibrium at the corners of an equilateral triangle. What point charge to be kept at the center of the triangle so that the charges would be in equilibrium? What point charge to be placed at the center of the triangle so that the charges are in equilibrium? Now, first of all, okay, if I consider an equilateral triangle here, okay, there are 3-point charges, all of them are plus q. All of them are plus q. Located at the corners of equilateral triangle. What point charge to be kept at the center of the triangle so that the charges would be in equilibrium? Okay, acha, one thing is very clear that, okay, these two are plus plus, so they are going to repel. Plus plus repel, plus plus repel. So if I only leave these three, they will be repulsive to each other, and okay, and they will be definitely moving. I mean, because let's talk about only this one also. Okay, it is going to be repelled by plus q, it is going to be repelled by another plus q. So ultimately it's going to be, having some net force that we can resolve and calculate. Okay, so it cannot be in equilibrium. A force is applied and it will try to accelerate. Okay, it will be displaced in a sense. But we would like all the charges to be in equilibrium, and that is why we are placing another charge at the center. So very clearly, what is the role of that another charge is to bring an attractive force. So if I say this charge is Q1, keep first thing in mind that this Q1 will definitely be negative. This Q1 will definitely be negative. Then only attraction will be created. Now let us solve with respect to any. Let's solve with respect to any of the charge. Okay, you can solve with respect to any of the charge basically. Okay, now what I can do is some basic properties of equilateral triangle if you apply na. Thoda sa alag se agar isko main bata दूं. Dear, okay, if this is A, what is the height of equilateral triangle? The height of equilateral triangle is given by the formula root 3 by 2a. It's nothing, under root of a square minus a by 2 ka square. Okay. Acha, if this total distance is a, okay, this altitude is also the median, okay, for the equilateral triangle, and it is going to bisect the base a by 2, a by 2. It is going to bisect the base a by 2, a by 2. So keeping these things in mind, what becomes the coordinate of this point? Okay, x coordinate will be a by 2. Ye coordinate rakh denge, and y coordinate is equal to the height. That is root 3 by 2a. That is root 3 by 2a. Clear? Acha. Next, then what is this? Let us assume this as the origin basically. I am starting this as the origin 0, 0. So what about this point? Okay, this point can be at, a comma 0. The side of the equilateral triangle is a. So that is at a comma 0. Whatever may be the side. If you want to take the value of some side a, you can take a equal to something. You can assume a equal to something to make it easy also, but that's okay. Okay. Now, let us test any of the charge. Acha, ab iski baat bhi karni hai. Okay, what is then the coordinates of Q1? What is then the coordinates of Q1? What is then going to be the coordinates of Q1? Okay, what is then going to be the coordinates of Q1? अब देखो, यहाँ तो distance भी निकाल सकते हैं. चलो, first, let me draw out the vectors. Okay, let me draw out the vectors. it is going to experience a force. It is going to experience some force, okay, horizontal direction due to the plus q charge. Okay, let us say this is F1. It is going to experience some force F2. It is going to experience some force F2. Okay, that is at the plus q charge because of the top vertex. Okay, these are going to be repulsive. Okay, but it is going to experience an attractive force. It is going to experience an attractive force. Okay, and that is suppose some force F. That is suppose some force F, and that is going to be towards the Q1. That is going to be towards the Q1. Okay, that is going to be towards the Q1, and that is how they are going to nullify each other. Okay, that is how they are going to nullify each other. Now, what is F1, F2, F3? Okay, again, okay, as I mentioned, this is the charge Q only located at A comma 0. Okay. Okay. So, for equilibrium, what you want equilibrium condition. And that is possible if the vector F, that is the force of attraction, will be equal to the total force of repulsion F1 plus F2. Total force of repulsion F1 plus F2. ठीक है. Now, what about the coordinates of this point? केवल एक point है, इसके coordinates की बात करेंगे. This is again having the x coordinate a by 2. Okay, ये height हो गया. अब अगर इस center की बात की जाए, okay, this is the height h. Now, if I want to talk about this center, the center of equilateral triangle is also the centroid, is also the orthocenter, in center, everything is same for equilateral triangle. Okay, so this is the case. Okay, how much is this distance? इसका जो y coordinate होगा ना, इसका जो y coordinate होगा, देखो इसका x coordinate तो मैंने बोल दिया, it will have the x coordinate a by 2. What is going to be the y coordinate? X coordinate is a by 2. Y coordinate, okay, if it is a centroid, also centroid. Sorry, if it is the median, if it is the centroid, correct, it's going to divide the median into the ratio 1:2. Okay, so this is going to be 1 by 3. This is 1, this is 2. So total 1 out of 3, total is 3 of the h, 1/3 of the h. 1/3 of the h, and h is root 3 by 2. Okay, so this becomes a by 2 root 3. A by 2 root 3. ये लिख लिया यहाँ पे. This is going to be a by 2 root 3. Clear, everybody? It's going to be 1/3 of the total height, basically. It's going to be 1/3 of the total height. Okay. So now, what is the value of f? What is the value of f1? What is the value of f2? Okay. Easy. Quickly लिखते जाते हैं. Okay. So what is f1? Here, let's write individually. f1. देखो k q. देखो what is f1? It is the force on q due to q. Okay. So k into q divided by distance square, that is a square या a cube. Cube वाला formula लिख लेते हैं. Okay, divided by a cube into the vector. What is the vector between these two? A minus 0 and 0 minus 0. Y coordinate nahi hoga, only a minus 0, and that is ax. Okay, so one of the a cancelled. This is fq square by a square ax. What is the force F2, dear? What is going to be the force F2? What is going to be the force F2? Okay, so that is going to be again k. Both the charges are q and q because I am calculating the force on q due to q divided by distance. This distance is still a. Okay, because it is the side of equilateral triangle. Okay, so divided by distance cube ले लेते हैं, and then if I take the vector. Okay, what is going to be the vector? Okay, x to x coordinate subtract. So a minus a by 2. A minus a by 2. Directly लिख रहा हूँ. Any confusion you can ask me. A by 2 ax. 0 minus root 3 by 2. Y to y subtract करेंगे. Final minus initial करते हैं ना. तो 0 minus root 3 by 2. So this is going to be minus root 3 by 2. Minus root 3 by 2 ay. Okay. And what is going to be the force F? And that is going to be F into Q1. Now when I talk about the force F, it is between Q and Q1 where I want to calculate Q1 divided by. Now what is this? अच्छा. This will be, देखो, अगर आपको इसको निकालना है ना, understand this logic. Understand this logic. How much is this distance? एक बात यहाँ तो आप Pythagoras apply कर सकते हैं, और otherwise, as I told you, ना, this is the centroid which divides every median in 1:2. If this is one part, this is twice part. Okay. So this much of the part here will be 2h. Okay. ये जो distance है ना, this will be equal to twice of this formula. Okay. Twice of this formula. A by 2 root 3. Okay. Twice of this formula means a by root 3. Clear, everybody? ठीक है. this much of the distance, अगर इसका जो remaining part है, this will be same as this remaining part, that was a by 2 root 3. This is a by 2 root 3, this will be twice. Okay, twice करेंगे तो a by root 3. Okay, a by root 3. थोड़ा सा ज्योमेट्री को अच्छे से बस डील करना है. So distance is a by root 3 whole cube. Distance is a by root 3, correct, whole cube into the vector. Okay. So force we are calculating on Q only. Direction because of repulsion I have drawn otherwise. Okay, we are calculating the force here. Okay, so A minus A by 2, again A by 2 AX. Okay, plus या minus 0 minus A by 2 root 3. So minus A by 2 root 3 AY. Now, as I have told you, x to x component को अगर हम add कर लेंगे, first of all, let me add F1 plus F2. So if I add F1 plus F2 ना, देखो k q square यहाँ से भी a cancel हो जाएगा. Remember, k q square by a square, it is there. K q square by a square, it is there also if you take a outside. Other than that, देखो, other than that, it is ax. Okay, it is ax. अरे ये f क्यों लिख दिया? That is k ना? Why this typo is coming up? I think I am saying k, but I am writing f. बोल तो मैं k रहा हूँ ना? Okay, or did I say also something else? I don't know. This has to be k, na? Okay. So k q square by a square, I take common. Then ax plus ax, okay, will be 3 by 2 ax. And y के साथ आ रहा है minus root 3 by 2 ay. Minus root 3 by 2 ay. Clear? ठीक है. अच्छा. What is the force F now? Okay, the simplified form of force F will be, again if you take a outside, root 3 का cube, 3 root 3, take upside, 3 root 3, k, q, q1. One of the a cancelled, so denominator will be a square, and this is going to be 1 by 2 ax minus 1 by 2 root 3 ay. Okay. So it's a good question giving you the detailed illustration of the process happening. So when I'm going to equate F equal to F1 plus F2, okay, I have 3 root 3 k q q1 by a square given by k q square by a square into F1 plus F2, that is 3 by 2 ax minus root 3 by 2 ay. ठीक है. अब देख लीजिए what can be done. K cancelled, q, one of the q cancelled, a square cancelled, so 3 root 3 q1 is left. Okay, अच्छा, this was in the, ये f का मैंने ये वाला वैल्यू तो लिखा ही नहीं, sorry. 3 root 3 k q q1 by a square into the components, that is 1 by 2 ax minus 1 by 2 root 3 ay. Okay. Okay, so 3 root 3 q1 by a square भी cancel हो गया है. A square also clearly cancelled. You are only left with 1 by 2 ax minus 1 by 2 root 3 ay, and that will be k q square. One of the q is left. Okay, a square cancelled. 3 by 2 ax minus root 3 by 2 ay. ठीक है. Now let's compare x to x component only. Okay, if I compare, देखो 3 root 3 q1 into 1 by 2 x component, here that is equal to 3 by 2 q. Okay, when I compare, what is the value of q1 I will be getting? 3 by 2 get cancelled. q1 is q by root 3. Okay, q1 will be equal to the q by root 3. Same answer should be coming up by y component also. Anyone, if two vectors are equal, the corresponding x or y components are equal. What is the value of q1? Is q by root 3. Okay, what is the value of q1? Is q by root 3. Okay, but q1 has to be negative, clearly mentioned. So minus q by root 3, correct answer is A. Everybody okay? Good question. Sometimes you can be ready for these questions as well. Minus q by root 3 is the very correct answer. This is minus q by root 3, which is the very correct answer. चलो, minus q by root 3 corrected, done है. Next question then. done. Okay, now let's come to the Gauss law. Let's keep on revising. Okay. See, even if you want to play in terms of magnitude also, Prabhat, I know, but still that, the main idea here was that equilateral triangle formulas. If you know that, you can even try in terms of magnitude also. Okay. Okay. Or other way is resolution of forces. Maybe you try to cancel the resolution directly in x or y component. Okay, that can be another way. Okay, you can try to cancel out directly along the xx components. Along the xx components, एक ये कर सकते हो, या along yy component. ठीक है प्रभात. But each of the approach you apply, it's not going to make much difference of time if you are clear with the equilateral triangle and the concepts. That geometry was more important here. Chalo. So Gauss law, which states that the total electric flux through any closed surface is equal to the total charge enclosed by that surface. Is equal to the total charge enclosed by that surface. Fundamental Gauss law. Okay, the questions on Gauss law and its application are then very common. Okay, the electric flux through any closed surface, okay, is equal to the total charge enclosed by that surface. So if I have any closed surface, suppose isko sphere मान लेना, and there are charges, suppose Q1, Q2, Q4, Q3, Q5 distributed like this. Okay, so the Gauss law states that, we will take proper numericals also, the total flux crossing through this closed surface, because it is a closed surface, is equal to the total charge enclosed by it. And what are the charges enclosed by it? The charges enclosed by it are Q1, Q2, Q4. So here Q3 and Q5 not required. Okay, the total flux crossing is equal to the charge enclosed, that is 1, 2 and 4. Q1, Q2, Q4. That is known as the Q1, Q2 and Q4. Clear everybody? The Q1, Q2, Q4. Okay, now Gauss law, flux is equal to charge enclosed. Flux, okay, is integral of d phi, integral of d psi, and that is calculated as integral d dot ds, where we know that d is the electric flux density. Okay, d is basically the electric flux density vector. Okay, let's have some revision around the Gauss law formula altogether, then we'll go to the question. Okay, electric flux density vector d, and the d is also related to the electric field by the formula d equal to epsilon e. Okay, d is the electric flux density. Okay, that is flux. Okay, what is the unit for flux? Flux is equal to charge enclosed. The flux is measured in coulombs only. Okay, the unit of flux will be coulombs only, because it is equivalent to charge, and the electric flux density hence is measured in flux per unit area, that is coulomb per square meter, and because it is the flux per unit surface area, surface integration of this vector quantity will give you the total flux crossing through any given surface. Okay, so this is how we calculate xi is equal to integral d dot ds, and the total charge enclosed within any particular region can also be calculated as integral rho v dv if you know the volume charge density of the particular region. If you know the volume charge density of the particular medium. Okay, so rho v, volume charge density of the medium, given by charge per unit volume, coulomb per cubic meter. Okay, so total charge enclosed is integral rho v dv. Ab dekho, if I want to talk about a closed surface, okay, as per the Gauss law, xi is equal to q enclosed, but that is only for closed surface. The total flux crossing any closed surface is equal to charge enclosed. That means when I want to calculate xi, it should be integral d dot ds. Xi is integral d dot ds. Okay, but that is over a closed. The integral should be over a closed surface. Integral should be over a closed surface. I put the closed surface I in integral, and q enclosed is given by integral rho v dv. Now what you can do is, whenever you do the surface integral over a closed surface, what can be applied? Surface integration over closed surface is equivalent to the Gauss divergence theorem, can be simplified by Gauss divergence theorem, and that is equivalent to integral of volume integral of divergence of d. That is equivalent to volume integral of divergence of d, integral del dot d rho v. Right side you have integral rho v dv. So when you compare both of them, you get the very, very important formula that divergence of d will be rho v. Divergence of d will be equal to the rho v. Okay, del dot d equal to rho v, and it's one of the Maxwell's equation also for static fields. We'll see one by one. We'll list down final Maxwell's equation, but we'll keep discussing in between only. So del dot D equal to rho V, it's one of the final Maxwell's equation. Del dot D equal to rho V is one of the Maxwell's equation for the electric fields. Okay? On this also produces a lot of question. Directly, indirectly, very important for the question. Very, very important formula. Okay, for the question. ठीक है. Then there can be. अच्छा देखो, यहाँ पे मैं आपको revise करा देता हूँ, because when I start the question, okay, the question may be given the flux density vector, या may be given electric field, calculate the volume charge density of the medium. So rho V, we need to find the divergence. Questions here may not be only in the Cartesian. The question may be in Cartesian or cylindrical and spherical, any of the coordinate systems. So I give you a quick review of the vector formula. Okay, del dot F, and that is given by del Fx. The divergence in the Cartesian everybody knows. Differentiation of x component with x, y component with y, z component with z. If it is cylindrical, then the divergence is given by the formula 1 upon rho del by del rho of rho d rho plus 1 upon rho del phi by del by del phi of the f phi, I'm sorry, and then del by del z of the z component. In spherical, it is given by 1 upon r square del by del r of r square FIR. Okay, 1 upon r sine theta del by del theta of f theta sine theta. F theta is the f theta component of the spherical vector. 1 upon r sine theta del by del phi of the phi component. Okay, these are the divergence formula which you must know before solving it. Okay, so you know, if you by chance don't know, you can have a noted from you can note it also from here. That's not a matter to worry. Okay. Now, before we take up the question, some results which come up from the Gauss law, which come up from the application of Gauss law. Suppose if there is an infinite line charge, okay, infinite line se mera matlab hai line charge of large length, very large length. We ideally call it as infinity, and that has uniform charge density. So its length is very large. Okay, what we define is, okay, the charge density, and we assume it to be a line of uniform charge density. That is, over every particular length you consider, the charge distribution is equal, and that is given by rho L coulomb per meter. That means if you cut any particular 1 meter of the piece of wire, if you take up any particular 1 meter of the piece of wire, let's say this is 1 meter. If this much is 1 meter, then the total charge spread over this wire over 1 meter, that will be rho L. Okay. And I say uniform means you take any 1 meter piece of the wire anywhere, the total charge within any 1 meter will be equal to the rho L. It will not be different. It's going to be the same. Okay. And suppose it is along the z axis, not necessarily z axis, it can be along any straight axis, and the electric field is given by the formula rho L upon 2 pi epsilon naught rho. Okay, yeah, rho L upon 2 pi epsilon, not necessarily epsilon naught for free space. Okay, यहाँ से remove कर देते हैं. It is rho L upon 2 pi epsilon rho. If it is free space, you can put epsilon naught. Otherwise, for any other material, we can put epsilon as well. Okay, we can put epsilon as well. As I mentioned you, the relation, sometimes D may be given, sometimes D may be R, sometimes E may be R. So D is epsilon E, and we know that epsilon is further represented as epsilon naught epsilon R, where epsilon R is the relative permittivity of the medium. Correct? Okay. So now, rho L, as I told you, is the charge density of the line charge. What is rho and what is A rho? What is rho and what is A rho? Okay, so suppose this is the point of observation you are calculating the field at. Okay, let us say this is your point of observation. What is the perpendicular distance of the point of observation from the line charge? Okay. Okay, that means from the line charge I move perpendicularly. Okay, towards the point of observation. This perpendicular distance is known as rho. This perpendicular distance is known as rho. Okay, and the direction of the perpendicular line, is known as A rho. The direction of the perpendicular line is known as A rho. The direction of the perpendicular line is known as the A rho. Is known as what? Is known as the A rho. Clear? The direction of the perpendicular line, A rho. Like it is the A rho of the cylindrical coordinate system. What is the rho direction of cylindrical coordinate system? Okay, when you move perpendicularly from the z-axis, perpendicular movement away from the z-axis is the rho direction. That also can be taken here, A rho. But in general, it is a perpendicular direction from the wire to the point of observation. Okay. Next, this is the standard result that is derived using Gauss law, but derivation is not required here. Then, if you have an infinite sheet of charge, again, infinite sheet means a very large sheet of charge. Okay, whose dimensions are very large, whose breadth and length are both very large. Okay, ideally we assume it to be infinite. So we have an infinite sheet of charge, again having the uniform density, charge density rho as coulomb per square meter. Okay, because it's a planar surface, so what we assume is कि if I cut, okay, suppose if I cut 1 square meter. Okay, पहले इसको 1 square meter मान लेते हैं. Suppose if I cut it, it's infinite in excess. So if I cut a small area, that is 1 square meter. Okay, within that 1 square meter, how much is the charge? That will be rho s. That is known as the charge per your 1 unit meter, charge per meter square. And uniform means if you cut 1 meter square from anywhere on the sheet, it's going to give you the same charge. That is the rho s. That is the rho s. Now let us say there is a point of observation, maybe above or below, anywhere. There is a point of observation at which you are required to calculate the electric field. After solving from Gauss law, it turns out to be rho s upon 2 epsilon naught. Okay, yeah, rho s upon 2 epsilon. Again, if it is not free space, we'll use only epsilon. So rho s upon 2 epsilon a n cap. Okay, now epsilon is the permittivity of the medium. Rho s is the charge density of the sheet available. Okay, and then what is a n cap? A n cap is a... What will be a n cap in this problem? Question will apply karenge. It's going to be a unit vector. Okay, normal to the sheet. It will be a unit vector. Normal to the sheet towards the point P, towards the point of observation. Okay, if the point of observation is top, this is a n cap. It may be bottom, this is a n cap. So not only normal to the sheet, but normal to the sheet where? Towards the point of observation. Okay, towards the point of observation. Okay, that is the a n cap. Next case is volume charge. Okay, all these results derived using Gauss law. Okay, so suppose I have a volume entirely filled with a charge. Okay, let's consider both the cases solid. पहले solid sphere की बात कर रहे हैं. Okay, so you have a sphere of radius a centered at origin, filled uniformly with a volume charge density rho v. Okay, that means the charge is not only spread. The charge is not only spread over the circumference. The entire charge is uniformly filled. Okay, every part of the sphere, even internal, it considers some charge. And how much? When you cut out 1 cubic meter volume of the sphere, okay, when you cut out any sphere of 1 cubic meter, कोई सा भी एक sphere अलग से निकाल लेंगे, that will have the total charge rho v. So that is what is the volume charge density rho v, coulomb per cubic meter. Okay, coulomb per cubic meter. Okay. Then of course total charge can be calculated, integral rho v dv, उसकी जरूरत नहीं है. Now what is the final electric field formula? Okay, what is the final electric field formula? Okay, I'll explain you. Okay, I'll explain you by a logic here. इसको ऐसे देखते हैं. Okay, remember, first case that you are considering is solid sphere. Okay, remember, again, the questions based on sphere are also important. Okay, suppose you are considering what? You are considering a solid sphere. You are considering a solid sphere. Jashwant, you are talking about spherical coordinate. Where is that? 1 upon r square sine theta r sine theta. R square sine theta. No, it's r sine theta only, na? R will get if I derive it that way. No, I think it's going to be r only. I'll just rethink it. I know how it comes up. Just allow me. Okay. ठीक है, आते इस पे आते. First, let me cover up this one. So I'm talking about the solid sphere case. Okay, I'll just recheck it just once. I'm coming to a solid sphere case. So let's say you have a solid sphere in case. Okay. Suppose you have a solid sphere. So case number 1, starting with solid sphere. Now I consider 2 different points here. Okay. Let us say this is one of the point and let us say this is one of the point. I consider one of the point outside. I consider another point as inside. Okay, now this is the center of the sphere. Okay, join both of them with respect to the center. Join both of them with respect to what? With respect to the center. दोनों को center से join किया. Okay, let us say the distance from center is r. Okay, let us say the distance from center is r. Okay, now what is the electric field outside? Very simple way to remember it. The electric field that is going to be outside, dear, will have the same formula. Okay. Will have the same formula just like, yeah, what is happening? Just like point charge. Now everybody knows what is the field due to point charge. What is going to be the field due to the point charge? It is KQ. But where you have to assume the point charge? In this case, you will assume that there is a point charge at the center of the sphere. Okay, so KQ upon distance from the center to this point, that is what I've taken as R, KQ by R square. Electric field here will be KQ by R square, just like point charge formula. Okay, direction wise likhna hai, it's going to be in the radial direction. Okay, it's going to be in this radial direction. This is what is the AR direction. Okay, when you move radially away from the center of the sphere, spherical coordinate system का AR direction. ठीक है, अब आ जाते हैं inside पे. Okay, for the point which is inside, electric field is given by, for the point which is inside, yaar, what is this rubbish going on? Electric field which is inside, the first thing that you must remember, very important, that it is proportional to R. It is going to be proportional to R. Okay, more is the distance from the center, more is the field. That is what actually this graph is also illustrating. Very important point here is that if you are within the solid sphere, okay, so as you move away from the center of the sphere, field is increasing linearly, straight line, linearly. That is why it is proportional to R. You can look into it. R by 3 epsilon rho V. It is proportional to R. More is the distance, okay, more is the field. It is directly, it's like Y equal to mx relation. Okay, but it's going to take the peak at the circumference, but now as soon as you move away from the sphere, electric field is proportional to 1 by R square, and hence it is going to decrease. That is the characteristic shown by this field. Okay, so it is proportional to R, important point to remember. But yeah, suppose agar formula ka zarurat pada, so that is given by R upon 3 epsilon into rho V. Okay, R upon 3 epsilon rho V. Let me put it like this. Rho V by 3 epsilon into R, AR. That's what electric field is like. Y equal to mx, Y equal to mr, something like that. Okay. But on the other side, if you have just a hollow sphere, then also you can connect logically now. Dear, tell me now, suppose if I consider hollow sphere, okay, that means whatever is the charge, it is distributed only on the, okay, only on the boundary of the sphere. Solid se mera matlab hai, the charge Q is distributed uniformly within the sphere. When I say hollow, the charge Q is distributed where? Okay, only on the surface of the sphere. Only on the surface of the sphere. Suppose the surface carries some charge Q. Okay, the total surface carries some charge Q. Okay, only on the surface of the sphere. Acha, so now, dear, once again, let us say this is the center. Okay, again I consider two cases, inside and outside. Let me again consider the two cases, inside and the outside. The inside and the outside. Both the points are supposed at the distance R, at some distance from the center. Okay. If the point is inside and since it is a hollow sphere, do you have any charge available in here? There is no charge inside this medium and hence it does not contribute to any electric field. Logically, okay, there is no source. Electric field is due to some source. So there is no source inside and there is no electric field here. So electric field inside, okay, will be 0 for a hollow sphere. Okay, but for a solid sphere, okay, again, like point charge, KQ by R square, AR. Okay. Again, it turns out like point charge, and that is why the formula with respect to sphere easy to remember. Easy to remember. So whether it is solid or hollow sphere, electric field outside will resemble the formula that due to point charge. Okay, in this R is the distance from the center of the sphere, and if it is a hollow sphere, internally 0. If it is a solid sphere, internally it is proportional to R. Higher the distance, more you move away from the center, more is going to be the field. Okay, the field here is less, the field here is more, the field here at the boundary is maximum. Okay, the field here will again be less. Okay. ठीक है, चलो done. 100% I've told you whatever topics we are covering today is common ECEE. ठीक है जी. Now come on, one question here. The following point charges are located in air. Okay, let us say these are the charges that is mentioned as suppose. Okay, suppose this is Q1, Q2, Q3 and Q4. There are 4 charges located at 4 coordinates given to you. Okay, the total electric flux over a sphere of 5 meter, over a sphere of 3 meter, over a sphere of 10 meter. It is a multiple select question. One or more than one can be correct. Multiple select question, one or more than one can be correct here. Come on, everybody. Come on, everybody. Tell me the answer. Simple one. It's going to be simple one. Okay. Chalo. Just complete this and allow me a minute. I'll be just back in 2 minutes. You take your time, 2 minutes. You take your time. I'll just be back in 2 minutes. It's a simple question. Basic application of Gauss law. This one is on the basic application of Gauss law. Yes. What are the options correct? Let's see if you have done by this time. Okay, chalo. Yeah, let's continue. So, what are the correct options? Okay, in the comment box, I'm able to see BCD. Okay, ACD भी आया हुआ है. Let us check. Chalo. So, let's first draw these particular charges. Again, if you want to draw with the spherical picture, वो भी कर सकते हैं. So, let me place it with the spherical picture. Okay, I only need first of all the XY coordinates here, because the points are only here specified by the X comma Y. There are the sphere of the radius 3, 5 and 10, and the charges first one 0, 0. Okay, so this is the first particular charge that is at 0, 0. Then you have 4, 0, 4, 4 and 0, 2. Okay, there is something at 0, 2 also. And then there is something at 4, 0. And then there is something at 4, 4. Okay, so this is 4, 0, and I say there is the charge. Which charge at 4, 0? Q2. Okay, this one is Q1, no doubt. Then 4, 4 pe Q3 hai. Okay, this is some charge Q3, and then at 0, 2 you have another charge that is Q4, and then you have spheres of different radius. Okay, so what are the spheres coming up? Let us see that. There is a sphere of 3 meter and 5 meter and 10 meter radius. Okay, so sphere of 3 meter radius. Oh. Sphere of the 3 meter radius. Okay, a sphere of 5 meter radius, slightly of course bigger than this. Okay, sphere of 5 meter radius, approximately है ना, एकदम approximately draw कर लेते हैं. Okay, and then a sphere of 10 meter radius. This is radius 10, this is radius 5, this is radius 3. This is radius 3. Now very clearly, when you talk about the radius 3, okay, when you talk about the radius equal to 3, xi is equal to q enclosed. Xi is always q enclosed. For the radius 3, what are the charges enclosed? It is q1 plus q4. q1, q4. q2 is outside. For radius equal to 5, what are the charges that is going to come up is q1 and q4, and q2 bhi aa jayega. Okay, but q3 is still outside. You can measure by the calculation also. q3, it is 4, 4. So 4 square plus 4 square, 16 plus 16 is 32. And here x square plus y square will be 25. Radius 5 hai na? Radius 5 hai, so x square plus y square is r square, 25. But at this point it is x square plus y square, that is 32, greater than 25. So it is outside. By that also you can say, अगर डायग्राम नहीं ड्रॉ किया है. And then for r equal to 10, your xi will include summation of all. Okay, तब तो सारे ही आ गए. I've taken the very bigger radius here. Okay, so what's the answer basically? First and fourth minus 0.01. Okay, first, fourth and second. Okay, minus 0.01 plus second 0.04, the 0.03 plus 0.03. And when I add all, okay, 0.03 plus 0.09, 0.12. And now I will start matching the options. Okay, so for radius equal to 5, it should be 0.03. That is answer A. That is answer A. Okay, for radius equal to 5. Okay. Now, dekho, that means many of you are telling BCD. Many of you were telling BCD, so you have included the Q3 also inside. Wrong hua na? Okay. For radius 3, it is minus 0.01. Perfect hai. It is C. Okay. And then for radius 10, it is 0.12. Okay. The correct answer is A, C, D. Correct, dear Bhanu. Okay. Correct answer is A, C, and D. Correct answer is known as the A, C, and D. Correct answer is A, C, D. Correct answer is A, C, D. Done. Let's move ahead to the next then. Okay, ji. Next, D. Next question. Yes, Hari, correct, A, C, D. Now, given that, next important question. Given that D is equal to Z rho cos square phi AZ. Okay, D is equal to Z rho cos square phi AZ. Okay. Cylindrical coordinate. The vector D is only having the Z component. Calculate the charge density at the point 1 pi by 4 3. But how do we generally calculate charge density? It is given by the formula del dot D. And then the total charge, very, very important question this is again. Total charge by the cylinder of radius 1 with minus 2 less than equal to Z less than equal to 2. ठीक है, अब देखते हैं इसको. Okay, so what is rho V? That is del dot D. अच्छा, del dot D. So dear, in general, the D in general may comprise of the three components D rho A rho, D phi A phi, dz az, and in that case the divergence formula as we just discussed is given by 1 upon rho del by del rho of rho f rho, sorry, rho d rho, okay, plus 1 by rho del by del phi of the d phi component plus del by del z of the dz component. That is what is the formula we have seen. Okay. Because Q3 is outside, Shivam. Because the Q3 is outside. Right? You must have counted in B Q3 also, but Q3 is outside radius 5, na? Option number A and B talking about radius 5, so you don't have to count Q3. Q3 is outside. Okay. Even if you draw it as outside, and if you don't want to draw, x square plus y square at Q3 is 32, which is greater than 25. Up to the radius 5, x square plus y square is 25, na dear? Okay. Yeah. So, what is the condition coming up here is, okay, d rho 0, d phi 0, okay, and then your answer here will be del by del z of only the z component, okay, and that is z rho cos square phi, okay. When you're differentiating partially with z, rho and phi are constant, del by del z of z, del z by del z is 1, so you're only left with rho cos square phi. Okay, so what is the value of rho v? That is rho cos square phi. The value of the rho v is given by the rho cos square phi. Okay, rho cos square phi. Clear? Rho cos square phi. Done. That is the rho v. Coulomb per cubic meter. Now that is a general expression for rho v. आपसे बोला है, tell us at the point, okay, tell us at the point 1 comma pi by 4 comma 3. At the point 1 pi by 4 comma 3, okay, the rho v, put down the value, rho is 1. Okay, what is this? This is the point in cylindrical coordinate which is represented as rho phi z. Okay, so rho is 1 is multiplied by cos square phi, and phi is pi by 4. So 1 by root 2 ka square will be 1 by 2. 1 by root 2 ka square will be 1 by 2. Okay, so at this particular point, rho v is 0.5 Coulomb per cubic meter. 0.5 Coulomb per cubic meter. 0.5 Coulomb per cubic meter. Coulomb per cubic meter. Clear everybody? Coulomb per cubic meter. चलो डन है, ये हो गया 0.5 Coulomb per cubic meter. Now next, okay, what is the next part? Total charge enclosed by the cylinder of radius 1 with these coordinates. Now how do you calculate the total charge enclosed? Okay, the total charge enclosed will be equal to integral rho v dv. Will be equal to integral rho v dv. Okay, now rho v we have calculated. Okay, what is rho v in general? Not at a particular point. Within the region, rho v is rho cos square phi. And volume integral will be basically triple integral always. Na? Rho v is known as the rho cos square phi. And what is the dv for cylindrical coordinate system? For cylindrical coordinate system, the dv is given by the formula rho d phi dz. Okay, it is given by the formula rho d phi dz. Rho d phi dz. Rho d phi dz. Okay. So now let's solve it up. We can separate the limits. Variables are separable. Acha, what are the limits? Rho. Okay, radius is up how much? 1. Okay, the rho is 0 to 1. Entire volume ke liye, maximum radius 1. For the complete cylinder, azimuthal angle. They have told complete cylinder, and to trace any complete cylinder, azimuthal angle is 0 se 2 pi. 0 se 2 pi, and z is given by -1 se 1. Am I right? -2 se 2 hai, sorry. -2 se 2. But all the limits are constant, variables are separable. So rho into rho square. Okay, we can separate this as integral rho square d rho. Then cos square phi d phi, and then dz. It's clearly separable. Okay. Chalo. This is now equal to rho square ka integral rho cube by 3. Rho ka limit has 0 to 1. Integral for cos square phi, okay, you can also write it as 1 plus cos 2 phi by 2 to integrate 1 plus cos 2 phi by 2 d phi, and then integral dz. Integral dz is directly obtained z -1 se 1. Okay, so first answer is 1 by 3. Now next time integrating 1 by 2 ka integral with phi will be 5 by 2. Okay, and cos 2 phi integral, okay, will be sin 2 phi by 2. Okay, 2 2s are 4. Sin 2 phi by 4 ho gaya. Limit 0 se 2 pi, and z integral 1 minus -1. Okay, upper minus lower limit of z, I get the value 2. Okay, so ye ho gaya 1 by 3 into 2 into, now 2 pi by 2 will be pi. Lower limit for phi 0. Now sin, upper and lower limit, sin 4 pi and sin 0, both are 0. So sin ka zarurat hi nahi hai. You are only actually left with this thing, 2 pi by 2. Phi pe upper limit rakha, so that is pi. Correct answer is 2 by 3 pi. 2 by 3 pi coulombs. We are calculating the charge na. If you want to calculate the numeric value, okay, 2.094. Okay, z, acha, z fir maine -1 se. I don't know why I am taking -1 to 1 again. It is -2 se 2. Okay, so then this will become 4. Upper minus lower limit is 4. This is 4, and the answer is also 4 pi by 3 coulombs. That will be how much? 4.18 coulombs approximately. The total charge enclosed is 4.18 coulomb. Everybody clear? ठीक है जी, done है. Next, let d is equal to 5x की power 4, y की power 4, z की power 4 ay. What is the flux enclosed by the volume? X equal to 3 and 3.1, y equal to 1 से 1.1, z equal to 2 से 2.1. Okay, d is given to you. What is the flux enclosed by this volume? Okay, x is 3 से 3.1, y is 1 से 1.1, z is 2 से 2.1. This makes a cube ना. Fixed coordinates है यहाँ पे. Okay, x is 3 से 3.1, या कोई भी x डायरेक्शन ले सकते हैं. Y is 1 से 1.1, z is 2 से 2.1. Okay, between two planes. Okay, there are two walls. Okay, it's going to make a cube. अच्छा, whatever, it makes a closed surface. अब आपको ये देखना है, what is the flux enclosed? Okay, flux. Okay, because you have a closed surface. Cube always makes a closed surface, na? Okay, and that is equal to charge enclosed basically. Okay. So there are two methods here to solve it up, such questions when you need the flux. The question will be flux only. Method number 1 is integral d dot ds. Surface integral d dot ds over the different surfaces. There are 6 surfaces here. There are 6 surfaces here. Okay. Or what is the better answer is Gauss divergence से ही निकल के आया है. Xi is q enclosed, and that is integral rho v dv. Okay, one step you have to calculate rho v, and then this integration will be a easier process to you. Okay, this integration is going to be an easier process to you. Rho v. Okay, del dot d. Okay, they have given me d. Okay, and that is, this d is only in the y direction. This is only in the y direction. Only uy component is there. So that is del by del y. Only y component है तो del by del y of 5x पावर 4 y पावर 4 z पावर 4 यही है ना. ठीक है. Now differentiate with y only. 5 3s are 15. x and z are constant. y power 4 की जगह आ गया y cube and then z power 4. 15 x की power 4 y की power 3 z की power 4. That is the value of the rho v. 15 x की power 4 y की power 3 z की power 4. 15 x power 4 y power 3 z power 4. x power 4 y power 3 z power 4. ठीक है. अच्छा 5 into 4 sorry 20. That is the rho v. Now we will put the rho v here. Okay, so xi, okay, which I am mentioning as q enclosed will be, it's a Cartesian coordinate, so dv will be dx dy dz. So triple integral 20x की power 4 y cube z की power 4 dx dy dz. Okay, the limits of x, y, z are clearly known to you. All are constant. Variable are separable. Separate the variable and even write down the answer of integral x power 4 का integral x power 5 by 5. Direct integrating. Y cube integral is y power 4 by 4. Z power 4 integral is again z power 5 by 5. Limits of x, y, z. X is 3 से 3.1. Y is 1 से 1.1. Z is 2 से 2.1. Okay. So this is going to be how much? ये 20 तो cancel हो जाएगा. Just the rest of the part is calculation. Complete that. It's power 5, correct? And then minus you have 3 power 5. And then you have power 4. And then you have again power 5. And you cancel हो गया. If I divide only by 5, 35.5 approximately. Please check it out. 35.5 coulomb. 35.5. Yeah, that's correct. It's option number C approximately. 35.5 with 35.4. Correct answer, Ashok. Okay. Okay, correct answer. That is 35.5 coulomb. That is known as the 35.5. Correct, Sonali. Okay. That is a very correct answer. Chalo, so just to show you, these are important questions. They keep coming regularly. In recent GATE also, these similar questions based on flux or rho v calculation, they are very common in GATE. So in an electrostatic field, the electric field displacement density vector D is given to you. X cube I plus y cube plus j plus x y square k cap, where I, j, k are unit vectors along the x-axis, y-axis, z-axis respectively. Consider a cubical region R centered at the origin with each side of length 1 meter and vertices as plus minus 0.5, plus minus 0.5, plus minus 0.5. Okay, cubical region given again. Okay, the electric charge enclosed within R. So dear, what is the electric charge enclosed within this region? The electric charge enclosed, directly they are asking Q enclosed, and that is given by integral rho v dv. The electric charge enclosed is integral rho v dv. Okay, integral rho v dv. And now what is the rho v? X, Y, Z Cartesian coordinate. X, Y, Z Cartesian coordinate. It is del by del x of the x component. Okay, all the three components are given. Del by del x of the x component. Del by del y of the y component, which is y cube. Del by del z of the z component, and z component is xy square. So xy square differentiation with z will be 0. So x cube ka derivative 3x square, y cube ka derivative 3y square. Okay, so this is 3x square plus 3y square. Okay, so now let's start calculating. The charge enclosed within this is integral dv आएगा, तो triple integral आएगा, and rho v is 3 x square plus y square, and then dx is dy dz, dv is dx dy dz, and we'll just put down the limits. Okay, limits are, and we'll start solving it. Okay, so if you try to take this here, you cannot separate x square plus y square, but I can separate the integrals first and then separating the variable. Let me first separate the integrals. Let us talk about integral x square dx dy dz. Okay, integral is a linear operator, na? So let's separate the integral. Okay, 3 to outside ही कर दिया है. Then integral y square dx dy dz. Now this is going to be simple for you. How this is going to be simple for you now is, please complete the calculation. चलो कर लीजिए calculation complete quickly. Quickly complete the calculation and tell me the answer. Chalo. So how much it should be? Now first, x square ka integral, x cube by 3, dy integral y, dz integral z. Okay, limits are for all plus minus 0.5. Minus 0.5 से 0.5, minus 0.5 से 0.5, minus 0.5 से 0.5. And next one will be only y square dy integral. So dx का integral x, y square integral is y cube by 3. Okay, and dz integral is z. Okay, all the limits are minus 0.5 से 0.5. देखो now 3. Take 3 common from both, cancel with the outside 3. You are only left with, okay, answer लिख देंगे 0.5 cube minus 0.5 cube, वो twice हो जाएगा. So I have twice into 0.5 cube. Okay, then further multiplied by 0.5 minus 0.5 is simply 1. Okay, these two are 1. And similar answer coming up from here. So इसको further into 2 किया. Net answer 0.5. Net answer is 0.5 coulombs. Check it out. Net answer is 0.5 coulomb. Yes, correct, Jashwant, Meghna, Ashok, very correct answer. Correct answer is total after solving 0.5 coulombs. Okay, NAT type question they have produced, answer 0.5. Answer 0.5. Okay, next question. Okay. So a plane y equal to 2 carries an infinite sheet of charge 4 nanocoulomb per square meter. If the medium is free space, what is the force on a point charge of 5 millicoulomb located at origin? Okay, a plane y equal to 2 carries an infinite sheet of charge 4 nanocoulomb per square meter. If the medium is free space, what is the force on a point charge 5 millicoulomb located at origin? Located at origin. Okay, so a plane y equal to 2 carries an infinite sheet of charge. This question is on infinite sheet of charge, and that is located at the plane y equal to 2. Okay, that is located at some plane that is y equal to 2. Okay, let me first of all take the y-axis here. Okay, and the plane will be located at y equal to 2. Okay, take it. If this is the y-axis, let's say this is the x-axis. Okay, and the sheet of charge is located at y equal to 2. Say this is y equal to 2, through which a sheet of charge, an infinite sheet of charge, okay, assume it to be infinitely large, that is passing through y equal to 2. Okay, at y equal to 2, you have infinite. Hole is horizontal. It's going to be a horizontal flat sheet of charge. Okay, and that has the charge density, okay, 4 nanocoulomb per square meter. Rho s for this is 4 nanocoulomb per square meter. Rho s here will be 4 nanocoulomb per square meter. If the medium is free space, what is the force on the point charge of 5 millicoulomb located at the origin? If the medium is free space, okay, what is the force on a point charge, okay, of 5 millicoulomb located at origin? Okay, and the force can be obtained. Force per unit charge is the electric field. Force can be obtained by Q into E. Okay, we can calculate the electric field at the origin. Okay, where E is the electric field at the origin. Okay, and what is the Q? Q is the 5 millicoulomb charge. Okay, now what is the electric field due to a sheet of charge? Okay, this is the origin point of observation. Okay, to calculate the electric field due to a sheet of charge, okay, first of all, I also need to draw the normal from the sheet of charge towards the point of observation. This is known as A n cap. Okay, I told you now what? What is the formula? The formula was electric field given by rho s by 2 epsilon A n cap. Rho s by 2 epsilon. Is it free space? Of course, it's free space, clearly mentioned. The rho s by 2 epsilon. Not rho s given है, epsilon naught का value मुझे पता है. But A n cap is a unit vector normal to the sheet towards the point of observation. Okay, so from normal towards the point of observation, that is origin, I am actually traveling opposite y direction. I am actually traveling in the negative y direction. So this should be the minus AY. This should be the minus AY. Okay, so placing down the value, rho s is 4 nanocoulomb. 4 into 10 power minus 9 divided by 2 epsilon naught, and epsilon naught can be written as 1 upon 36 by 10 power minus 9, and A n cap is known as the minus AY. So 10 power minus 9s are cancelled, 2 into 36, 72 pi ye aa gaya. Okay, so now my answer force will be 5 milli, 5 into 10 power minus 3. okay, is multiplied by further the electric field, which has turned up to be where? 72. 72 pi. Okay, 72 pi. Force will be Newton. Okay, so 570, 36, 360 and 10 power minus 3, so 0.36. I think a negative tha. Oh yeah, minus y, minus 72 it should be. Minus 72y. Okay, and this is the electric field, minus 72 pi ay. Electric field can be written in volt per meter. Okay, तो यहाँ minus 72 ले आए तो minus 0.36 pi. Okay, Newton. Minus 0.36 pi. Okay, ay Newton per meter. Correct answer is C. Everybody, correct answer is C. Check it out. Check it out. It's C. Sandeep, please check it out. It's going to be C. It is going to be C. The correct answer is C. Chalo. Options are in terms of pi, so let's keep it in terms of pi only. Okay, ji. Next question, next concept coming up here. Okay, the electric potential. Okay, the electric potential. Dear, I think I'll tell you after the break what to be done for tomorrow, because at this attendance, marathon doesn't make any sense. Marathon running morning to evening. Okay, and the attendance students are okay. They are automatically, I think, prepared for gate. Okay, maybe only few days are left. But at this attendance, marathon doesn't make any sense. So I'll tell you what to do after break for tomorrow. Aaj to pura karenge, but I'll tell you. Tomorrow is exclusively EC, so more less attendance. Okay, even more less attendance will be there. Tomorrow is only EC. Today is EC double E syllabus. So that's okay. That's okay. I'll tell you after the break. I'll decide. I'll think. I'll lunch break now. I'll discuss with the team and then I'll tell you what to be done for tomorrow. क्या solution निकाल सकते हैं कल के लिए. चलो. Electric potential. Okay, let's at least cover the today's part completely. Okay, the electric potential. Okay, because it doesn't feel good at this. You know, if students are okay, they have prepared. Then why should we waste our energy also now? Okay. Suppose we wish to move. Let's understand the concept of potential. Okay, and suppose there is a point charge in the presence of some electric field. There is some electric field present due to some any other source. I don't know what is the source, but there is some electric field present. There is a source, okay, due to which some electric field is present, and in the presence of that source, there is a point charge located at a point A, and I want to move it towards the point B. I want to move it towards the point B in the presence of electric field as shown. Okay. Okay. But I'm not able to see that attendance with the more weightage, na? Okay. From the point A to point B in the electric field, we are moving a point charge Q. We are moving a point charge Q. Okay. Now, the work done, and as per the basic law of physics, the work done in moving the point charge is given by let me start with the differential work, small work done, and that is given by minus F dot dl. Okay, we'll talk about the minus sign, why the minus sign significance is coming. So, dw is minus F dot dl, where F is equal to QE. Where F is equal to QE, so dw can be written as minus QE dot dl. Okay, it can be written as minus of QE dot dl, where F is equal to QE, where F is equal to Q. Because of the Coulomb's law, we know that the force here is because of the Coulomb's law, that is Q into E. So dw is minus F dot dl or minus QE dot dl. That can be written as minus QE dot dl. Okay. Now, what is the total work done? Negative की बात बाद में करते हैं. What is the total work done? Okay, is given by the integral of this operator. So minus Q is a constant, integral A to B E dot dl. So here we need to have line integral of the electric field somehow coming up. Okay, work done is minus Q integral A to B E dot dl. Okay, it is minus Q integral A to B E dot dl. The work done, okay, or the potential energy required in moving a charge from point A to point B. The work done or potential energy, okay, required in moving a charge Q from point A to point B is given by minus Q integral A to B E dot dl. Okay, minus Q integral A to B E dot dl. Minus Q integral A to B E dot dl. Okay, this is the work done in moving a particular charge Q. But now let me assume that if the charge was only a unit charge, Okay, let's say, let's normalize with respect to unit charge. So if you take Q equal to 1, or if you normalize with Q, that is W by Q, then that is going to give you the potential difference between the 2 points. Okay, the potential difference between the 2 points, because as we all know, work done also corresponds to the potential energy required in moving the particle from point A to the point B. Okay, so potential energy per unit charge, we are going to call it as the potential difference between the 2 points, that is the A and B. The potential difference VAB between the 2 points, okay, W by Q is minus of the integral A to B E dot dl. Okay, VAB is W by Q, work done per unit charge, and that will turn out to be, after dividing by Q, very important formula, negative of the integral A to B E dot dl. Okay, negative of the integral A to B E dot dl. The potential difference between 2 points is minus integral A to B E dot dl. Okay, is integral E dot dl. Okay, right. So now there are two scenarios here. Let's understand one point here. Okay, I told you there is some source. Because of a source, there is already some electric field present, and in the electric field present, I have a charge Q. Okay, because there is an electric field present, so this charge Q will experience a force that is given by QE. That is what I have taken. That is what I have taken, the Coulomb's force. F is equal to QE. Okay, since it is experiencing a force is mass into acceleration, so it will also accelerate. Eventually, it's going to displace. Okay, and suppose it displaces and it reaches the point B. It displaces and it reaches the point B. Okay, so because it is moving and displacing from one point to another, it is losing the energy. Okay, it is displaced from one point to another due to the presence of electric field. It is losing the energy. That is why I can say that the change in the potential energy, the change in the energy of this particle should be negative. The change in the energy of this particle is negative. Okay, now when you take this particle, as 1 coulomb, when you normalize, this change in energy is known as the potential. By potential energy per unit charge, okay, that is what is the potential difference between the 2 points. So when it is moving from point A to B, it's going to be negative. So VAB is negative if the charge is moving due to the presence of electric field. That is what minus signs means here. But if VAB is positive, how it can be positive? Can there be change of energy? Can there be increase of energy automatically? So if VAB is negative, that means the change in potential energy is due to the already present electric field. The particle is moving due to the presence of electric field and hence loses the energy. But if the potential energy change is positive, that can only be due to the fact if some external energy is being pumped into the system. Okay. Otherwise, law of conservation of energy will fail. This particle moved from point A to the point B. Okay. And you feel that VAB is positive. When you go from A to B, you felt that VAB is positive. That means change in potential energy is positive, and that is only possible if some external agent, somebody takes this charge and intentionally places at Q. If some external body pumps the energy into the system, then VAB will be positive. Otherwise, okay, if the charge is moving on its own due to the presence of the electric field, it's going to represent negative VAB. Clear? It means negative VAB. It's like a very simple idea. अगर इसको ऐसे समझना है, suppose you are at A and you want to reach B. Forget the charge Q. Okay, you run on your own or you walk on your own. Okay, आप अपने आप से जाओगे. You run on your own, you walk on your own. So definitely you will lose energy, ना? You run some kilometers, okay, or you walk some distance, you lose energy, ना? थोड़ा थक जाते हो, you lose some energy. But suppose you don't run on your own, okay, you book a Ola cab, okay, and you comfortably travel within the Ola cab and you are listening to music, you're relaxing, you can take a nap also. Suppose it's a 30-minute journey, you can take a nap. Okay, so you still move to the point B, you reach to the point B, but okay, you have been pushed to the point B by some external agent, like you booked a cab and you were relaxing in the cab. So maybe the energy increases because you listen to some energy, or you listen to some songs, or you had a small nap. So you regain your energy. You are not at all tired. It's simple idea. इस तरीके से आप याद रखना. What is VAB, positive or negative? What is the VAB, positive or negative? Now let's come to the formulation. That is important. So one of the formula here, lots of formula there, and every formula is important for question. The first formula coming up is, okay, VAB. Okay, that is the work done per unit charge is negative of the integral E to B, negative of the integral A to B E dot dl. So one of the question is on this line integral only. Okay. Sometimes they ask VAB, or if they ask the work done in moving the particle from A to B. If the question is work done in moving a particle from A to B, so that is Q into VAB, whatever is the value of the charge given. The question can also be in terms of work done. So that is Q into VAB. Okay, VAB need not prove it. It has a simple proof that not required right now. VAB is very important, independent of the path taken. Okay, independent of the path. Okay, so work done. Okay, when you take the particle, either a straight line or either a circular path or either any zigzag path, okay, in all the three cases, it's going to be equivalent. Okay, it's going to be equivalent. Okay, electrostatic field. Okay, time varying fields में story different होगी, but in the static situations where electric field is not a function of time, the electrostatic field is always a conservative field, and this is your next Maxwell's equation. Del cross E equal to 0 turns out to be your next Maxwell's equation, curl of E equal to 0. Okay, because whenever the line integral of a vector is independent of the path, the curl of the vector is 0. That's what you also learn in the vector calculus in mathematics. Okay, so del cross E equal to 0 or integral E dot L equal to 0 for a closed path. Okay, for a closed path, we can also write integral E dot dl over a closed path. These are known as the Maxwell's equation. This is differential form. This is known as the integral form. Okay, differential form or the integral form. अरे ये अभी derive कुछ नहीं करना है आज. Okay, one of them is the integral form, one of them is the differential form. Then the relation between electric field and the potential. As I already told you this relation earlier also, electric field is negative of the gradient of E. Next important formula, directly producing questions. Electric field is negative of the gradient of V. Okay, it is negative of the gradient of V. Okay, gradient is what? Now, you know, even if you take gradient in, you know, suppose spherical coordinate systems, Cartesian ले लेते हैं. If you take in the Cartesian coordinates, बाद में लेता हूँ. If you take it in the Cartesian coordinates, so you know what is gradient of V? That is del V by del X AX, del V by del Y AY, del V by del Z AZ. Okay, that is the space rate of change of the potential. That is known as the space rate of change of the potential. Okay, ultimately it is rate of change with x, y, z. Okay, so suppose there is one point A and another point B, and you are calculating, okay, you are moving a charge from A to B. Okay, you travel from point A to point B. Suppose the potential here is V1, suppose the potential here is V2. Okay, suppose the potential from point A to B is increasing. Suppose the potential from point A to B is increasing. V2 is greater than V1. Okay, because the potential is increasing, okay, so the rate of change of potential as per the basic law of calculus, for increasing function, the derivatives are positive. First derivative of positive. Okay, so gradient of V will be positive. Gradient of V will be positive, but there is a minus sign. So electric field, see, I am moving in this direction. Gradient is positive in this direction, but electric field is negative of this direction because of the minus sign. Okay, so electric field will be in this direction. That simply means that electric field is from the higher potential point to the lower potential point. Electric field is from the higher potential point due to the lower potential point. Electric field always flows, okay, from the higher to the lower levels of V. Higher to the lower potential. Clear, everybody? It is from the higher to the lower potential. Next point to be noted is, okay, now absolute potential at a point. First we discussed about potential difference between 2 points. Absolute difference at any point due to a charge Q is simply given by, you can remember very simply, KQ by R. K is 1 upon 4 pi epsilon naught. Let's remember again in terms of K only. KQ by R. We know potential is a scalar quantity. So this time, okay, you have some point A where the charge Q is located, and this is P, again your point of observation. Okay, so they are separated by some distance R. Okay, the potential at this point P, suppose Vp, is given by KQ by R. Simple. It is given by KQ by R. Okay, where Q is the source charge and R is the distance of the point from source. Here no vector calculation is required. This is even more simple. It is known as KQ by R. This is known as the KQ by R. See, the gradient formula again I have given you for all the three coordinates, because we'll be taking up the question on this. E equal to negative of the gradient of V. Okay, Cartesian coordinates, del V by del X AX, del V by del Y AY, del V by del Z AZ. In cylindrical, del V by del rho A rho, 1 upon rho, del V by del phi A phi, del V by del Z AZ. In spherical, del V by del R AR, 1 upon R, del V by del theta A theta, 1 upon R sin theta, del V by del phi AY. Okay. Okay. Chalo. That is gradient in different coordinate system. Then there can be the questions for the Poisson and Laplace equation. Not deriving it. Again, inka simple derivation hai, but right now you can just note down. What is the Poisson's equation? Okay, the del square V, okay, is minus rho V by epsilon, where del square is known as, del square ko alag se likh dete hain. Okay, the del square is the dot product of del with itself, del dot del, and that is known as the Laplacian operator. That is known as the Laplacian operator. So, and that is basically given by, agar Cartesian की बात करें, okay, so sum of the second derivative operators of x, y, z, del 2 by del x square, del 2 by del y square, del 2 by del z square. Okay, so when I want to say del square v, it simply means that del 2v by del x square, del 2v by del y square, del 2v by del z square. Okay, ठीक है. ठीक है. So del square v is minus rho v by epsilon, known as the Poisson's equation. And if the medium is charge free, I've told you what is rho v. It is the volume charge density of the medium. And if it is a charge free region, so rho v will be 0. Del square v equal to 0 is known as the Laplace equation. Is basically known as what? That is the Laplace equation. That is the Laplace equation. Then energy density, not important for formula. Just you should, not important for question. Just formula you should know. Not at all important. Here, direct question nahi aayega. But somewhere, somehow, you know, the energy density, when you talk about fields, when you talk about wave propagation, this formula may be required. If there are n point charges, then the total energy in the system is given by half summation qk vk, where vk is the potential at, at the kth point. Okay. Not important. Okay. This also not important for numericals, but one formula. What is the electrostatic energy density required in the wave propagation classes? That's it. Okay, the electrostatic energy density WE is given by, specifically ये formula याद रख लीजिए, half epsilon E square. If it is free space, epsilon naught, otherwise it is half epsilon E square. Okay, that is the energy density. So the total energy, if you want to calculate, it is the volume integral of this WE. Okay, it is the energy per unit volume, joules per cubic meter. Okay, but for numericals, not important. ठीक है, starting with the first one. चलो बताइए simply. I have a simple question. Now let's take up different questions here on the potential. Yes, dear, tell me. What is the potential difference between 2 points x and y if the electric field intensity is given to you? What is the question asking? What is the potential difference between x and y? Vx minus Vy. Acha. When I told you VAB, I think मैंने लिखा या नहीं लिखा, but let me still tell you. When we were talking about VAB, okay, that is given by potential of second minus potential of first, VB minus VA, where VB and VA are the absolute potentials at the point A and B. And what is the formula for absolute potential that we have seen? Na? KQ by R simply. So VAB, when I write it, is VB minus VA. I am here asked the question, difference between x and y, potential difference between x and y, Vx minus Vy. So I should write it as Vyx. Second minus first karte hai na? Acha. Then what is VAB if electric field is given? Negative of the integral E dot dl from A to B. So here what I should write, Vyx is negative of the line integral E dot dl from the point y to the point x. 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 Now let's start doing that integral. So this is going to be negative of integral E dot dl. E is x ux, so simply let's call it in our language xax plus yay plus zaz. Now what is the dl in the Cartesian coordinates? It is dxax, Cartesian coordinates, and dyay, dzaz. So when you take the dot product, eventually it will be x into dx. Ax dot ax to 1 hota hai. It's negative of x dx, y dy, z dz. Okay, from the point x and y. Okay, we are actually integrating y from the point y and x. Okay, now all of them are individually with their own variable only. X with dx, so directly integrable. Y with dy, z with dz. There is no mixing here. Okay, so this is going to turn up as minus of x with dx, x square by 2. Similarly, next is y square by 2. Next is z square by 2. After solving the integral, we need to put the limit y to x. Y is 1, 2, 3. X is 200. Okay. Now put down the limit. Minus 1 by 2 को बाहर ले लेते हैं. Upper limit is only 2 square. Minus lower limit will be 1 square, 2 square, 3 square. That is minus 1 by 2. 2 square cancel. You have minus of 10. Minus minus भी plus होगा. Plus 5 volt is the potential difference. Correct answer, Ananta, Bhanu, Meghna. Correct answer, it's going to be the plus 5 volt. Here it is. Option number C, the plus 5 volt. Okay. Okay, Ji. Next question. So one of the question important is directly on the line integral application. On the line integral application. Next. Now again the next important. Given the potential, find the flux density or find the electric field. Okay. How do you approach this? They are asking the flux density basically. Not a problem. The flux density is epsilon E and we know the relation between E and V. Na? Negative of the gradient of V. So this is going to be epsilon negative of the gradient of V. That's our answer. Okay. So only thing you need to work out is the gradient of V. यहाँ पे बाद में पुट करेंगे V is 10 by r square how much? Sin theta cos phi. Sin theta cos phi. Spherical coordinates. Okay. What is gradient? Let's only calculate the gradient separately. Spherical coordinate है del V by del r AR plus 1 by r del V by del theta A theta plus 1 by r sin theta del V by del phi A phi. Just put down the values and get it. And then we need it at the point. वो point बाद में put करेंगे. Calculate this expression quickly. Okay जी, done है. Okay, so let's calculate this one. Okay, so del V by del R. Differentiation with what? 1 upon r square derivative minus 2 by r cube. So minus 20 upon r cube sine of theta cos phi AR plus 1 by r del V by del theta. Differentiation of sine theta will be cos theta. Plus 1 by r sin theta. Differentiation with phi. Cos phi derivative is minus sin phi. Minus 10 by r square sin theta sin phi A phi. Okay, now this is the gradient expression, but let's not simplify. Let's only put down the point, na? 2 comma pi by 2 comma 0. So we need this at the point 2 pi by 2 0. Okay, this is r, this is theta, This is phi, r theta phi. r theta phi, तो ग्रेडियंट कितना होगा? देखो यहीं पे अगर हम लिख ले, ओके, थीटा इज पाई बाई 2, साइन पाई बाई 2 1, cos 0 is 1. But here you have cos theta, cos pi by 2 0. Forget answer is 0. Third term you have sin phi, phi is 0, so sin phi will be 0. So only first of the term is left. Only first term for you is left for you, and that is minus 20 upon r cube. R का value है 2, तो 2 cube sin theta 1, cos phi 1, AR. Other components are just 0, so you have minus of 2.5 AR. That is the gradient formula. Minus of 2.5 in the radial direction. So the D density now turns out to be epsilon, will be epsilon naught, of course, because there is no medium, the by default free space, into minus of minus 2.5 AR. Okay, so the flux density vector is minus minus plus 2.5 epsilon naught AR coulomb per square meter, and we can put down the value of epsilon naught 8.854 10 raised to the power minus 12, okay, AR coulomb per square meter. So the final answer, dear, okay, would be becoming in term of picocoulomb 8.854 into 2.5, 22.135, okay, in the form of 10 power minus 12. So let me call it as picocoulomb per square meter. That is your final answer. Okay, very important question. Okay, very important question. Okay, the potential field is given to you 2x square y minus 3y square z. If x, y, z are the unit vectors along x, y, z directions respectively, what is the field intensity at 0, 1, 0? What is the field intensity at 0, 1, 0? Zero, 1, 0. Chalo. Same field intensity question given the potential function phi. So electric field is given by negative of the gradient of phi. पहले electric field निकाल लेते हैं, and this time it is going to be only Cartesian coordinates. So minus del phi by del x. Okay, then you will have the term del phi by del y. Del phi by del z az minus del phi by del x 2y square. Del phi by del y differentiation with y, तो 4xy minus 6y. Del phi by del z differentiation with z, okay, so minus 3y square az. Okay, at 0, 1, 0 now, at 0, 0, 1, 0 electric field कितना हो गया? Okay, it's going to be minus 2ax, y 1 है, x 0 है, okay, x 0 है, तो next term आ गया minus 6 into 1 minus 6 ay, y is 1 minus 3 az. 0, 1, 0 with respect to z minus 3y square with respect to x 4xy minus 6yz. ठीक है, तो ये वाला टर्म भी 0 हो गया. Okay, because x and z are both 0, and then you have minus 3az, minus 2ax minus 3az. Okay, okay, so minus 2ax plus 3az. Answer will be C if you open the bracket. Yes, yes, correct answer Ashok, C. शिवम एक बार रीचेक कीजिए, it's C. It is C. चलो डन है. Next question. The potential distribution is given to you, V equal to 10y power 4 plus 20x cube. If epsilon naught is the permittivity of free space, what is the charge density at the point 2, 0? What is the charge density at the point 2, 0? Okay, potential and charge density, direct relation. Okay, relation between potential and charge density. Poisson's equation. Okay, Poisson's equation. This is on Poisson's equation. And that is given by del square V equal to minus rho V by epsilon. Correct? So I want rho V here. Minus epsilon del square V. Del square V, del 2V by del x square. Sum of the second derivatives of x, y, z. Del 2V by del y square. Del 2V by del z square. Okay, putting down the value. Epsilon naught rahega yahan pe, clearly mentioned. Permittivity, it's free space considered. Del 2V by del x square. Now dekho, differentiation of V, double derivative with x. Let's write down the first derivative. So dear, what is the first derivative? Y ka to 0 ho jayega. I'm differentiating with x. X cube derivative 3x square. Then again differentiate with x. Na yahi likh do. Why to take two step? So x square derivative 2x. Del 2v by del y square. Okay, 10 into 4. Okay, y cube ka derivative. Y power 4 ka derivative 4y cube. Again derivative y cube ka derivative will be 3y square. Okay, I need this at the point 2, 0. So chalo wo bhi rakh dete hain. Directly when you put the 2, 0, you get minus epsilon naught. X is 2, so 20 into 360 into 2. Okay, 120. Further x is 2, so 240. Plus, okay, y is 0, so next part is 0. So answer is minus 240 epsilon naught. Minus 240, answer is D. Answer is D. Correct, Ashok. It's a basic question on Poisson's equation. Yes, Bhanu, correct answer. So the answer is D. A good question taken from the last year gate 2022 2 marks. Okay, yeah, Sonali, correct answer D. Okay. As shown in the figure below, two concentric conducting spherical shells which are centered at R0 and they are having the radii R equal to C, R equal to D, are maintained at potential such that the potential at R equal to C is V1. Okay, so potential throughout the sphere will be definitely maintained at V1. Okay, and then potential at R equal to D is V2. Assume that VR depends on R, where R is the radial distance. Okay, the VR depends only on R. So at every fixed distance, even if you consider this, okay, the potential will be constant. At this, potential will be constant. But if you move away, the potential will change as a function of R. But for a fixed R, potential is constant. Ye ho gaya. Okay. Assume that VR depends only on R, where R is a radial distance. What is the expression for VR in the region between R equal to C and R equal to D? Okay. What is the expression for VR in the region between R equal to C and R equal to D? Between R equal to C and R equal to D. Okay. Now, number one thing. VR depends only on R. VR depends only on R. What does it mean? What does it mean? Okay. So, it depends only on R. So, you can take only spherical coordinates. Just a second. You can take only spherical coordinates, correct? It is only a function of R. Okay. Chalo. So VR depends only on R and potential is only a function of R. This question takes you towards the fundamental Laplace equation. There is no charge mentioned. So of course, the given region, if no charge is mentioned, so it's of course going to be 0. So let's take the charge-free region condition and that takes you towards the Laplace equation. Del square V equal to 0. Previous one was on the Poisson equation. This is the Laplace equation. Del square V equal to 0. Now, what they are telling that V is a function of only R. Only R. So V is just like VR, function of R. Okay, and because it only depends on the function distance from the center, so let's assume that it is a spherical coordinate parameter because R comes in the spherical coordinate. Okay, so in the spherical coordinates, in this spherical coordinate, what is the del square V? It is given by 1 by r square del by del r of r square V. R square del V by del r. Laplacian है ना, double derivative. 1 by r square del by del r of r square del V by del r. Correct? But now let me take it to be 0. We need to solve del square V equal to the 0. Del by del r. Okay, as I told you, del square is del dot del. Del dot del. So from there you can relate and get this. Okay, so r square del V by del r equal to 0. Why I am writing only one term of the Laplacian? Because it's a function of only r. Okay, the theta and phi terms I'm not writing. Del by del theta, del by del phi, it will be 0 anyways. It does not depend on theta or phi anyways. So derivative with theta and phi will be 0. Okay, Acha, now this is 0, so there is no role of r square, because even if you multiply by 0, result is 0. So we are left with del by del r square del V by del r is 0. Now first thing is, differentiation of a parameter is 0. Differentiation of some parameter equal to the 0. Differentiation of some parameter equal to the 0. So r square del V by del r. Okay, differentiation of a parameter is 0, so that parameter can be taken as constant. So r square del V by del r is some constant. Okay, r square del V by del r should be some constant. Okay, suppose c. या C1, अभी C रखते हैं. Okay, so that means, okay, del V by del R is C by R square. So what is going to be V? Now when you integrate, 1 upon R square comes from the derivative of minus 1 by R. Okay, so we can take it as minus C by R. Derivative of 1 by R is minus 1 by R square. Okay, so V is minus C by R, but because again you are integrating, na? Again you are integrating, so there will be a constant of integration. That is why isko C1 liya. C. Some constant of integration will be there. Okay, so now we have got the potential function. Okay, without the constant, but yeah, we have got the rough form that it is minus C1 by R plus C2. But they have mentioned that the potential, okay, is maintained on the inner and outer sphere as V1 and V2. V1 and V2. So we'll use these parameters now. Okay, we'll use these parameters. Okay, we'll use these parameters. So we have V, which is equal to minus C1 by R plus C2. Okay, minus C1 by R, the potential at the radius. Radius is also mentioned as C, na? Radius is mentioned as C. So thoda sa confusion aayega naming mein. I'll rename it. But radius is also given as C. So let's take the constants as K. It doesn't matter. So this is minus K1 by R plus K2. Let us deal with the constants as K1, K2. Because now I am going to put the boundary condition minus K1 by R plus K2. Okay, and now the first condition that I am going to put at the radii C, the potential is V1. Okay, the potential is V1. Okay, so that means V1 is equal to minus K1 by C plus K2. Okay, similarly at R equal to D, at the next radii R equal to D, the potential is maintained at V2. Okay, at here's this, at the radii D, potential is maintained at V2. Okay, so V2 will be minus K1 by D plus K2. Okay, so number one, K1 can be obtained if you directly subtract these two equations. Okay, if you subtract these two equations, if you do 2 minus 1, bigger minus smaller potential, anyways, V2 minus V1, okay, K2 will get cancelled. K2 will get cancelled. You have minus K1, 1 upon D minus 1 upon C will come, isn't it? Right. हाँ ठीक है. Minus K1, 1 upon D minus 1 upon C. Okay, that is the K1. Okay, so we can write down V2 minus V1 is minus K1 into C minus D by CD. Okay, yeah. What is the value of K1? It can become CD upon D minus C कर देते हैं, minus को अंदर adjust करते हैं, into V2 minus V1. Okay, now again let's use any one of the equation here, 1. Okay, V1 is minus K1 by C. तो minus K1 by C, C को वापस divide करेंगे, तो minus D upon D minus C into V2 minus V1 plus K2. So now from here we can get what is the value of the K2. Okay, from here we can get what is the value of the K2. Okay, it will be V1 plus D upon D minus C V2 minus V1. Okay, so देखो एक बार सेपरेट कर देते हैं, dV2 upon d minus c, and with V1, okay, with V1 if I check, this is 1 and then this is minus d upon d minus c, d minus c minus d. तो देखो K2 का वैल्यू आ गया dV2 upon d minus c, और यहाँ पे आ जाएगा dd will get cancelled, minus c, तो minus cV1 upon d minus c, तो इसको कॉमन लिख दिया. That is the value of K2. That is the value of K2. So now putting down the value, potential was given by minus K1 by R plus K2. Minus K1 by R plus K2. Okay, so putting down the value of K1, minus K1 by R, that is minus CD upon D minus C into R, V2 minus V1 plus K2, and K2 is dV2 minus CV1 upon D minus C. Okay, that is the complete answer solved by a Laplace equation problem. Solved by the Laplace equation problem. Have a look into the options now. Potential equal to, so all the options are starting with CD. ठीक है, तो minus को adjust कर देंगे हम. Minus को adjust कर देंगे. So if you take minus inside, V1 minus V2 आना चाहिए. Okay, either V1 minus V2 or either C minus D. देखते क्या मैच हो रहा है. Okay, CD into, yeah, correct, V1 minus V2 होना चाहिए. Okay, so option number B or C. Then look into the next part. Next part what we have derived is dV2 minus CV1. dV2 minus CV1 ये आ रहा है. Okay, ये दोनों सेम है बाबा. If you take minus inside ना, ये हमारा प्लस आया है ना. I think there's a typo error. Both of them are actually same only, plus K2, and K2 has been obtained as dV2. ये यहाँ पे अगर माइनस रख दिया तो माइनस V1C plus V2D. Doesn't make sense. Okay, so let's say the answer is B, and I'll just do a small correction here. Okay, C में it should be plus basically. Okay, so otherwise ये दोनों same हो जाता. Correct. Answer is B. Let's make the answer as B. Okay जी, चलो. Let us move ahead. Okay. Let us move ahead. Next question. Okay, पहले इस पे आते, then we'll come back to it. Okay, some good gate questions to be discussed. Two electric charges Q and minus 2Q. Two electric charges Q and minus 2Q are placed at 0, 0 and 6, 0 on the XY plane. The equation of zero equipotential curve in the XY plane. The equation of the zero equipotential curve in the XY plane. Zero equipotential curve. Now, what is a zero equipotential curve? First of all, what is equipotential curve? Equipotential curve will be any curve at which potential is constant throughout. Potential equal to constant throughout the curve. Throughout. So you take any point on the curve. Okay, the potential is same. Okay. You take any point on the curve. Suppose this is the curve. Okay, this is some point P, this is some point Q, this is some point R. If it is equipotential, okay, on the curve, sorry, curve की बात कर रहे हैं, path की बात कर रहे हैं. You take any point, equipotential surface नहीं बोला. Okay, suppose P, suppose Q, suppose R. Okay, so VP is equal to VQ is equal to VR. That is what equipotential curve. Now they mentioned zero equipotential curve. That means potential will be zero throughout the curve. Okay, I want that curve where potential is zero throughout the curve. Given there are two charges at the given 2.00 and 6, 0. Okay. So such questions, equipotential curve or maybe zero equipotential curve. Okay, we can be ready for that also. But ultimately the solution will be, you see, in a very fundamental here. The solution when you see here, it's going to be very fundamental only. The solution that you are going to see is very fundamental. So you have 2 point charges. Okay, Q and minus 2Q at 0, 0. एक है 0, 0 पे. And next है 6, 0 पे. 6, 0. Okay, they are placed at 0, 0, 6, 0, q and minus 2q. Okay, ये है charge q, ये है charge minus 2q. And I want to find the equipotential curve. Let's say any point on the equipotential curve is x, y. We have xy plane here. Let us say any point here. Let me pick up any point here. Say this is some point P, x, y, where P is suppose any point on the equipotential curve, on the zero equipotential curve, on the zero equipotential curve. P is any point on the zero equipotential curve. Got it? Any point on the zero equipotential curve. तो इसका क्या मतलब होगा? Any point on the zero equipotential curve means at this point the potential must be zero. Okay. Now what is the potential at this point? That can be calculated. Na baba? What is the potential at this point? Absolute potential at any point. Easy to calculate. No vector calculation. Only scalar calculations here. Field में vector calculation आता है. Potential only scalar calculation will come. Okay, let us say, and there are two charges, so superposition will be applied. So let us say this is some distance r1. Let us say this is some distance r2. Okay, what is going to be the total potential at the point P is going to be k. Okay, q1 by r1. Okay, चलो पहले यहाँ पे r1 r2 का वैल्यू लिख लेंगे यहाँ पे. हाँ, so k q1 by r1 plus k q2 by r2. It is kq by r. Now that's what I told you. Okay, kq by r. Okay, so what is r1 and r2, dear? X, y, 0, 0. The distance between x, y and 0, 0. Distance from the root over x square plus y square. What's going to be r2? Distance between x, y and 6, 0. Again apply the distance formula. Under root of x minus 6 whole square plus y minus 0 whole square, that is only y square. So we know both of them. Okay, now Vp is equal to k, commonly q1. The first charge is q, small q, divided by distance r1. And second charge is basically minus 2q. So this becomes minus 2q by r2. But this has to be equated to 0 because we need Vp equal to 0. So this means q by r1 will be 2q by r2. Q also will get cancelled. You will have a relation basically r2 is to r1. You have the r1 r2 formula put down. Yeah, even not put down in the form of under root, square kar lenge. So r2 square is 4 r1 square. R2 square, which is x minus 6 ka square plus y square, is 4 r1 square. So solving up x square plus 36 minus 12x plus y square is 4x square plus 4y square. So what is the 3x square plus 3y square? Okay, all the terms on one side plus 12x. Okay, constant को यहाँ रखते हैं equal to 36. Okay, so if I just simplify this, इसको यहाँ लेते हैं. Okay, 3 will be cancelled up. X square plus y square plus 4x is equal to 12. Okay, so x square plus 4x, add a 4 here, plus 4 plus y square, add 4 on both the sides. Okay, so x plus 2 ka whole square plus y square equal to 4 square equal to 16, that is 4 square. So that means that equipotential curve will be a circle. That equipotential curve will be a circle at the center minus 2, 0 and the radius 4. There will be a circle at the point minus 2, 0 and radius equal to 4. Okay, and radius equal to 4. There will be a circle so that when you consider any point on the circle, okay, it will always be at zero potential and everywhere it's equal. That is a zero equipotential curve. That is what is a zero equipotential curve. Now let's match the option. हमें draw नहीं करना है. We have the answer as D. Simple. Okay, the fundamental of solving the question is simple, but these questions are also relatable. Be prepared. Equipotential curve, zero equipotential curve. Okay, zero equipotential curve. Chalo, next question. Simple, 1 mark. Simple, 1 mark. Okay. A 1 microcoulomb point charge is held at the origin of a Cartesian coordinate system. If a second point charge of 10 microcoulomb is moved from 0, 10, 0 to 5, 5, 5 and subsequently to 5, 0, 0, then the total work done. Okay, see, it's a simple 1 mark means always believe, most likely always believe 1 marker question in GATE should be very simple and logical. Okay, it's not going to be that calculative. 3 different points are given. A 1 microcoulomb is charge is held at the origin of Cartesian coordinate system and the second point charge is being moved because of the first point charge. Let me call this as source, and this source will produce some electric field. Okay, this source will produce some, okay, it's a point charge, na? Okay, it's a point charge that will produce some static electric field. That is a point charge that will produce some static electric field, and we know that electrostatic fields are conservative in nature. The electrostatic fields are conservative in nature. Okay, conservative in nature means the potential difference or the work done, both is independent of path. So because of this conservativeness, देखो क्या पूछा है? Let us say this point is A, okay, this point is B, and subsequently to the point C. Okay, the question is work done in moving the particle from point A to the point B to the point C. ये पूछा है ना? Point A to the point B to the point C. But because of conservativeness of the field, the work done is independent. Whatever path you take, it is only dependent on the initial and final point. कहाँ से start हुए, कहाँ खत्म हुए, that's the only thing matter. So it should be just work done from A to C. And the work done, dear, from A to C, work done per unit charge is known as the potential, na? Work done per unit charge is known as potential. The work done will be the value of charge multiplied by the potential difference between A to C. There is no role of the point B here. Okay, it is only the work done between the point A to C. It is only the potential difference between A to C. Now that is further equal to Q Vc minus Va. Absolute potential at any point due to a point charge is how simple we all know. Okay, what is the point charge? That is at the origin. Okay, the point charge Q that is at the origin. Then I only need A and C. केवल A और C की बात करेंगे. A is 0, 10, 0 y axis and C is 5, 0, 0. Okay. Say a rough diagram. Let me draw X and Y. So the point C, the point A is 0, 10, 0 y-axis point and the point C is 5, 0, 0. I don't even care about the point B and drawing it, okay? That's actually a three-dimensional point that might have created complication if you involve in calculation, but logic. That is why one marker. If suppose by chance there was no conservativeness, then this point will be required, then some more lengthy calculation can become a 2-marker question. But it is concept based. Okay. Calculation तो बहुत minimal होगा. Okay, so this is my actual source. Okay, what is my source? 1 microcoulomb charge. It is 1 microcoulomb of charge. So dear, what is the potential at the point C? Okay, we will just use the potential at KQ by R. Okay, so it is going to be K, 9 into 10 power 9, directly putting down. The value of charge is 1 into 10 power minus 6, 1 microcoulomb, divided by distance in front of your eyes, it is 5. Okay, so it's going to be in 10 power 3, 9 by 5, so 1.8, 10 raised to the power 3. Similarly, the potential at the point A is going to be 9 into 10 power 9 K into the value of charge remains to be same 10 power minus 6 divided by distance 10. So this is 9 by 10, 0.9 into 10 raised to the power 3. Okay, these are the potential at both the points, correct? Okay, now we'll place the value of the charge further. Okay, so we will now have the answer. Okay, the work done from A to C is the value of the charge. Now, which charge here? The charge that is being moved, जिस पे work done हो रहा है, that is 10 microcoulomb. Okay, so don't mix. One is the source and one is the charge which is being moved. Okay, onto which work is being applied. Okay. ठीक है. So that is given by how much? Q is 10 microcoulomb, 10 into 10 power minus 6 into Vc minus Va. Okay, Vc and Vn निकाल लिया था 1.8. Okay, minus 0.9. Both are having 10 power 3. तो इसको separate कर दिया. तो 10 power 4, 10 power minus 6, 10 power minus 2. तो 0.9, 10 power minus 2. So options are in millijoules. Okay, no problem. So multiply and divide by 9 into 9. Sorry, multiplied by 10, 9. 10 power minus 3 will be millijoules. The unit of work done or energy is the 9 millijoules here. 9 millijoules is the answer. Done है जी? Done है. That is in case you have n discrete point charges and you need to calculate total energy within the system. The answer is 9. Okay, good. So such questions are also there for you. This was a good question on the Laplace equation. Moving ahead to the next. Yes, next important technique to be learned. Next important technique to be learned. Okay, a grounded conducting plane. Anybody able to think? ये question किस direction में होगा? Are you able to just relate? Okay, there is a grounded conducting plane. You know the field formula and potential formula due to point charge. Then you have also studied due to infinite sheet of charge, carrying some charge density, line charge. What is the field or potential formulas due to a conducting plane? No, not developed as of now. No need to develop also. Here, yes, very correct. Okay, so that is what actually revision means. Now we are into the revision marathon, guys. So at least ideas can be striked by you. Okay, study किया है तभी तो revise कर रहे हो. But yeah, still I'm telling you, I am taking in a way that even if you have not studied once also, this session can help you get decent marks in the EMFT, the ECEE part. Tomorrow we'll talk about the EC part. But again, I repeat, tomorrow now, what is my plan? In the lunch break, I will first discuss with the team and I'll tell you. Kuch karenge, we will do something tomorrow. But at this low attendance, now I don't think you people really are looking for some marathons. So what to do tomorrow? Tomorrow is the exclusive EC part. Give me some time after lunch break. We will come back and discuss. We'll do something. I know at least some of you are trying to study. Okay, so I need to balance both. We'll do something, but what to be done? Let me think. Okay, I'll tell you. A grounded conducting plane is located at z equal to 0. So guys, whenever you see the question where a grounded conducting plane has been mentioned, think about MOI. Yes, at least that method can strike to you, method of images. Now, what do we do in the method of images? Learn what do we do in method of images. Here the question, okay, is with respect to potential. It can be even due to electric field. Understand the method once. A grounded conducting plane is located at z equal to 0. That is xy plane in the free space. Okay, पहले इसको बना लेते हैं. Okay, so say you have a grounded conducting plane, means 0 potential. This is a grounded conducting plane. Okay, and that is also located at z equal to 0. Z equal to 0 is also known as the xy plane. Okay. Now, and a 60 nanocoulomb point charge is present at the point 2, 4, 6. 2, 4, 6 में ये देख लेना कि z is positive. That means it is going to be above the plane or below the plane. ये बस locate करना है हमें. तो z is positive. Plane is at z equal to 0. So this point is gonna be above the plane. 2, 4, 6. There is a point at which the charge of 60 nanocoulomb is present. Okay, so let us consider this as the point. Okay, Q 2, 4, 6. Am I correct? 2, 4, 6, at which the charge 60 nanocoulomb is present. Okay, here there is a charge that is 60 nanocoulomb is present. Okay, here we have the charge that is the 60 nanocoulomb charge. Okay, that is present at 2, 4, 6. What is the potential at 5, 3, 1? What is the potential at the 5, 3, 1? At the 5, 3, 1. So there is some point of observation 5, 3, 1. That is again above the plane only because plane is z equal to 0. And I am looking for the potential at this point. Now, normally you might think that what is the potential due to this point is, of course, there will be a potential due to point charge also, and there will be some potential due to this plane, due to this conducting plane. Okay, we know what is the potential. Okay, due to the point charge. But what is the potential due to this conducting plane? We don't know. And neither we are going to discuss that, but we will discuss something known as the method of images. Now, what will the method of images is going to display to you? Okay, in the method of images, we are going to replace this conducting sheet, this conducting grounded conducting plane, okay, by something known as a mirror. Assume that this is not available, and in place of that you have a mirror. In place of it, you have a mirror. Replace the conducting plane, replace the conducting ground plane by something known as mirror. And the role of mirror is to create reflection. The role of mirror is to create the reflection. Okay, so let us say if this is the charge Q, that is 60 nanocoulomb. Okay, at the point 2, 4, 6, there will be, okay, now where is the image created? At equal distance from the mirror, na? Okay, so equal distance, ye hai z equal to 0, so you are 6 units above, you will now come 6 units down. You will now come 6 units down, approximately ye le lete hain, 2, 4, -6, and there the image charge is created, which is equal in magnitude to the original charge, not deriving here, which is equal in magnitude to the original charge, but opposite in sign. This actually theory is developed using the concept of electric dipoles. Okay, so we have plus Q and minus Q, but we are not deriving here. Okay, but what you have to take standard result, guys, whenever there is a conducting grounded plane, okay, replace the conducting grounded plane and whatever is the source above it, okay, place the image of that. Place what? Place the image of that. This is known as the image charge. Okay, image at equal distance, and now they are asking what? They are asking the potential at some point. Okay, they may ask the field at some point, anything. What you have to do now, you have to apply superposition. There is no plane now, there is no conducting plane, that is gone, but there are two sources now. You have to calculate the potential due to the plus Q and also due to the minus Q. Got it? Similarly, if field is required, electric field due to first and second, electric field vector, so there will be vector summation. This is going to be a scalar summation. Only there is a difference going to come up. Okay, so join this and join this. Okay, this is at a distance r1 from the original source. Suppose this is the distance r2 from the image source, from the image charge. Okay, we need what is the potential at the point P. So that is why first we need the value of r1, r2, and this point P is also mentioned. Let me write this as 5, 3, 1, so that I can write down what is r1 and r2. Okay, so that I can write down what is r1 and r2. So directly, let's put down the formula. Now, Vp at the point will be V1 plus V2. Okay, and V is given by the formula KQ by R. The first is Q, distance is R1. Second will be minus Q. Be specific about the sign. Distance will be R2. Let us calculate R2 here only. Let us put down the value of K, 9 into 10 power 9. What is the value of the Q? It is 60 nanocoulomb. 60, 10 power minus 9. Okay, KQ common, so minus will be left inside. Minus 1 by R1. R1 is the distance formula. Okay, under root of 5 minus 3, 3 minus 4, 1 minus 6. Under root 5 minus 2 whole square. 5 minus 2, 3 minus 4. 1 minus 6. Okay, minus 1 upon under root of, okay, now distance between these 2 points, so 5 minus 2 again, that remains to be same. 5 minus 2, y coordinate be same chalega, 3 minus 4 whole square, difference will be 1 minus 6. 1 minus 6, that will become plus 6. Okay, so this is 10 power minus 9 and 9 cancel, 9 6 the 5, 40 outside, 1 upon square root of now how much? Now 5 minus 3, 9, 9 plus 1, 10, plus 25, under root 35, minus 1 upon under root, again 9 plus 1, 10, plus 49, 59. This is under root 59. Calculations and answer. Calculations and then answer. Minus 20.9, sorry, plus 20.97 volt. 20.97 volt, that is approximately D. 21 volt approximately is the answer. Correct, Bhanu. Yes. So, you know, image of image, okay, will become plus Hari. It will be something like this. Okay, देखो, ये तो हो गया. Okay, one conducting plane. Okay, now there can be case. Okay, this is a conducting plane z equal to 0. Now, what is z equal to 0? XY plane, that is infinite in length. Okay, so you have considered an infinite conducting grounded plane. Okay, if there are by chance, okay, if there are, ये भी बता देता हूं मैं आपको, if there are two semi-infinite, okay, grounded conducting sheets, okay, which are separated by an angle theta, okay, then first of all, number of image charges formed, okay, number of image charges formed is given by 360 degree divide by theta minus 1. 360 degree divide by theta minus 1. Where theta of course will be in degree because I'm using 360 degree. Theta will also be definitely degrees. Okay. Say for example, if I take two semi-infinite sheets separated at right angle. Separated at right angle, 90 degree. And let's say this is the original charge Q. So how many image charges will be available? How many image charges will be available? Because theta is 90 degree. Okay, so number of image charges. Okay, 360 by 90, that is 4 minus 1, that is 3. There will be 3 image charges. Okay. Now what are the 3 image charges? Okay, for 3 image charges, okay. Okay, the first of the image charge with respect to the vertical mirror, and image is always negative in sign, so this will come up here at equal distance. If this is D here, this will be D here, this will be minus Q. Similarly, image due to the horizontal mirror, again this is minus Q, but there will be third image charge, that is image of minus Q, and image of minus Q will be actually plus Q. Image of minus Q will actually be plus Q. Okay, these three will be the images. Image charge, image charge, image charge. Okay, so negative of negative becomes positive. Now, in simple, you can remember this way. What is the shortcut to remember it? That whatever may be the number of image charges, they will keep alternating in sign. Okay, so if original is plus, then I have minus, then I have plus, then I have minus, I stop at plus. They will keep alternating in sign. They will keep alternating in sign. They will keep alternating in sign. Clear? They will just keep alternating in sign. Chalo. Okay, some more quick revision before we go to lunch break. Okay, before we go to lunch break. But yeah, quick reminder that guys, Saturday, Sunday be ready. Complete mathematics revision marathon 20 and 21st of January. Okay, 20 and 21st of January. Okay, theta is the angle between the two sheets, Bhanu. This one. They are separated by what angle? These two are separated at right angles, 90 degree. Okay. That will give in the question. Definitely. They will give in the question. They can be separated by any angle. They will give that in the question. Acha ji, theek hai. So see you on YouTube once again at 20 and 21st Saturday, Sunday, again 10 a.m. Okay. 10 a.m. इसके बारे में already बता दिया है. So now, okay, some basic discussions about capacitor. Quickly कर लेंगे इसको. Okay, so there are 3 cases that you need to study here. Parallel plate capacitor. Okay, cylindrical capacitor, spherical capacitor. Capacitor used to store electrostatic energy. Okay, capacitor, to build any capacitor, be it parallel plate or cylindrical or be it spherical, you always need 2 conductors, parallel in nature, 2 parallel conductors. One of them will carry a plus charge, one of them will carry a minus charge of equal magnitude. Ideally equal magnitude. Okay, so you need to have 2 conductors parallel fashion mein, one of them carrying the plus Q charge, one of them carrying the minus Q charge. Let us start with the parallel plate configuration. So these parallel plates, when I say parallel plate capacitor, the plates are rectangular in nature. Okay, that is why they clearly appear parallel. So parallel plate capacitor comprises of 2 parallel rectangular plates. 2 parallel rectangular plates. Okay, identical. So each with area. Suppose each with the area of rectangle can be determined or might be given to you. Each with the area S. Okay, and they are separated by some distance that is D. Okay, they're separated by some distance that is known as D, and this is the plate area that is S. Okay, they are separated by some dielectric which may have the dielectric constant or relative permittivity as epsilon. Okay, relative permittivity as epsilon. Okay, because of the potential difference between the two plates, there will be electric field between the two plates, and we know that electric field just now discussed is from higher to lower potential. So electric field is from, okay, plus to minus charge. Okay, let us say the plate carrying the plus positive charge is 1, plate carrying the negative charge is 2, so electric field is between 1 to 2. Okay, okay. Okay, now the basic definition of any capacitance, whether it is parallel plate or whatever, it is the charge carried over any one of the plates. Both carry the equal magnitude of charge. Okay, the capacitance value for any capacitor is given by the charge carried by any one of the plates divided by the potential difference between the plates. Correct? The charge carried over any one of the plates, the magnitude of the charge over any one of the plates divided by potential difference between the plates. Okay. Now for parallel plate capacitor, this is the general formula for C, that is Q by V, or Q equal to CV. For parallel plate capacitor, okay, for parallel plate capacitor, dear, okay, for the parallel plate capacitor, C turns out to be what formula? Everybody must be aware about this. A very basic formula, network mein bhi study karte ho. Epsilon A, yeah, epsilon S, I have called the area as S. Epsilon S is divided by D. It is given by the formula, that is epsilon S is divided by D. Epsilon S is divided by D. The parallel plate capacitance is given by the formula epsilon S is divided by D. Epsilon is the permittivity of the medium, okay, which is filled between the two plates. S is the area of any one of the plates. Both are identical in nature. And D is the separation between the plates. D is the separation between the plates. Okay. Achha, because the charge Q and minus Q are uniformly distributed on them, okay, there is going to be a uniform field between them. And in the case of uniform field, what is going to be this field? This will be basically equal to, this field will basically be also equal to the potential difference divided by D. The potential difference is divided by D. Okay, the strength of the field here will be simply V by D. Will be simply given by V by D. Okay. Chalo. Okay, ji. Now this is for parallel plate capacitor. Similarly, you have a coaxial cylindrical capacitor. Okay, where the two parallel rectangular plates are now replaced by two parallel. Parallel here would mean concentric basically, or coaxial. So two concentric cylindrical plates. Okay, this is one cylinder. Okay, carrying some charge. Okay, over it there is another cylinder concentric to it. Concentric here means coaxial. Coaxial, they both share the same axis, that is coaxial. Okay, that is a coaxial. Okay, they will be separated. They will be again separated by some material which has the relative permittivity, which has the permittivity epsilon. Okay, they will both have some radii, suppose A and B. Okay, so one of them will have the radius that is A, another will have some radius, bigger radius of course, that is equal to the B units. Okay, let me assume again that one of them carries the plus Q charge. This carries the plus Q charge throughout, and this carries the minus Q charge throughout. Okay, right. And L is the total length, which can be anything. Okay, which can be anything. L is the total length of the system that you're considering here. Okay, so we have a length L of two coaxial conductors of inner and outer radii A and B. Okay, and the space between them is filled with a homogeneous dielectric with some permittivity epsilon. One of them carries the plus Q charge, one of them carries the minus Q charge. That is what you require to build a capacitor to store electric energy. Okay, two parallel bodies, one holding a plus Q charge, one holding a minus Q charge, separated by a particular distance. Okay, for coaxial capacitor, the formula turns out to be, okay, here it is written, it is always Q by V, but for the coaxial capacitor, it turns out to be the formula 2 pi epsilon L divided by ln B by A. It's going on live, Tech Master, and thank you for your words. Thank you. Good to know that you're learning, you're enjoying. Okay, so this is 2 pi epsilon L divided by ln B by A. Okay, again, by the basic, this involves basically the potential relations and the Gauss law. We're not deriving. Okay, not basically required much. Okay, 2 pi epsilon L divided by ln B by A. 2 pi epsilon A divided by ln B by A. ठीक है. construction similar to it, Ashish, but not really the body. For optical fiber, what are both the bodies? Okay, here we have taken conductors. What are both the bodies for optical fiber? Think. Chalo. So it is given by 2 pi epsilon L divided by L and B by A, where B and I are the internal and external and internal radii respectively. L is the length. Acha, sometimes they also discuss. Okay, this is the total capacitance. What is the capacitance per unit length? I told you length can be any length that you can consider. Let us say that capacitance is C dash and that is given by C by L. The capacitance per unit length is 2 pi epsilon upon ln B by A. Okay, 2 pi epsilon upon ln B by A. Okay. Spherical capacitor. Okay, the two plates here are two spherical plates. Okay, so two spherical conductors, one charged with plus Q, one charged with minus Q. Okay, concentric in nature rather than parallel, we make it concentric here, sharing the same center. One of them have the radii A, another one has the radii B. Okay, one of them carrying plus Q charge, one of them carrying minus Q charge, leads to the development of the field between the two charges, between the two spheres. Okay, from the 1 to the 2. Okay, from the 1 to the 2, and hence, okay, because of the development of field, this will be storing some electric energy, some electrostatic energy, and that is given by the formula. Again, some Gauss law will be involved here. Okay, finally coming up with the formula for spherical capacitor turns out to be 4 pi epsilon upon 1 upon A minus 1 upon B, reciprocal of the radius. Okay, remember, A is less than B, that is why 1 upon A will be greater than 1 upon B. Ye positive hi aayega, it has to be positive only. 4 pi epsilon upon 1 upon A minus 1 upon B. Okay, sometimes they also can discuss the question with respect to isolated sphere. What do I mean by isolated sphere? So A and B are the inner and outer radius. So what happens if I keep on increasing the radius of outer sphere? Okay, if I keep on increasing the radius of the outer sphere, so B becomes large. Okay, you increase it up to an extent so that, okay, what we will be only able to see and visualize is the inner sphere. That becomes isolated. It looks like only one sphere is there. The radius of the outer sphere becomes very large. Ideally, very large means tending to infinity, and 1 upon infinity, this factor becomes 0. So your answer is only 4 pi epsilon upon 1 upon A. Yeah, A will shift to the numerator. Answer will be 4 pi epsilon A. I think यहाँ पे होगा ये. Correct, yeah. 4 pi epsilon A. Okay, capacitance of a spherical capacitor whose outer plate is infinitely large. Okay, we can call it as an isolated sphere. Okay. We can call it as the isolated sphere. ठीक है. A and B, inner and outer radius. Okay, radius of the cylinder, na? Radius of the base of the cylinder. That is what it is, Bhanu. ठीक है जी. चलिए. So a capacitor. Now let's see what type of questions actually turn up for you. A capacitor consists of two plates, each 500 cross 500, and spaced 6 mm apart. They are spaced 6 mm apart. The space between the metal plates is filled with a glass plate of 4 mm thickness and a layer of paper of 2 mm thickness. The relative permittivity of the glass and paper are 8 and 2. Neglecting the fringing effect, what is the capacitance will be? Neglecting the fringing effect, what is the capacitance will be? What is the capacitance will be? Okay, a capacitor consists of two plates. अब देखो, definitely a parallel plate capacitor. Okay, there are two plates, 500 cross 500, plate area given है. Okay, they are spaced 6 mm apart. Okay, the space between the metal plates is filled with a glass of 4 mm and paper of 2 mm. The relative permittivities of both are given. So let me, first draw up this one. So what exactly the configuration is given to you? There are initially two parallel plates. Okay, there are two parallel plates which are separated totally by a distance of 6 mm. 6 mm, and they have the plate area S, which is 500 into 500 mm square. Okay, so 500 into 500, 25, 10 की power 4, but mm is 10 power minus 3, so mm square 10 power minus 6, so total 10 power minus 2. I can write it as 0.25 square meter. So plate area is, after solving, 0.25 square meter. Now the what is that? The space between them is filled with a glass of 4 mm and a layer of paper of 2 mm thickness. Okay, so they are also, the space is not filled with a uniform material. Okay, there are two different materials. that are given. Okay, it is glass and paper. The relative permittivities are 8 and 2. Okay, for the glass epsilon r is 8, for the paper epsilon r is equal to 2, and okay, glass is up to 4 mm thickness, so this one is 4 mm, and paper is for 2 mm thickness. That is what is given. Now definitely capacitance for a parallel plate capacitor, this also becomes a parallel plate configuration, but capacitance depends on epsilon s by d. Different epsilon, different material means different capacitance. Okay, so this particular portion will have some capacitance C1, this will have another capacitance that is C2. Okay, and they are clearly connected in series to each other. So the equivalent picture that you are obtaining here is the case of a series capacitance. Okay, one of the capacitance is C1, another capacitance is C2. Okay, C1 and C2. Okay, and they are in series with respect to each other. Okay, so what is the equivalent capacitance, guys? Series capacitance formula C1 C2 is divided by the C1 plus C2. C1 C2 divided by C1 plus C2. Come on, complete the calculation. Chalo. Hanji. So first let us work on C1, C2 now. Okay. What is C1? Epsilon 1 S. S is common to both, but D is different. Okay. Epsilon 1 will be 4 epsilon naught. Sorry, 4 nahi, 8 hai. So that's 8 epsilon naught into plate area 0.25 divided by the separation, that is 4 mm. 4 into 10 power minus 3. Okay. 4 into 10 power minus 3. So 8 into 0.25 is 2 by 4 half. 10 power 3 ऊपर चले गए तो 500 epsilon naught लास्ट में पुट करेंगे. Similarly C2 will be epsilon 2s by d2. Epsilon 2 is 2 epsilon naught into separation is 0.25 divided by d2. What is the value of the d2? 2 mm. 2 into 10 power minus 3. Okay, so you get 0.5 by 2, 1/4. So 250 epsilon naught. 250 epsilon naught. Okay, so what C equivalent? C1 C2 divided by C1 plus C2. Solve कर लेते हैं quickly. Okay, 500 epsilon naught multiplied by 250 epsilon naught is divided by addition will be 750 epsilon naught. One of them gets cancelled. Okay, one of them gets cancelled. एक बार 1/3 से भी cancel हुआ. 500 by 3 epsilon naught only one time left. 8.854, 10 raised to the power minus 12. So the final answer, guys, come on, let us write down this one quickly. 1475.6. 0.66, 10 power minus 12 picofarad. 1475.66 picofarad. Correct answer is approximately B, 1475 picofarad. Very common. Okay, parallel plate capacitor given either series or parallel fashion. Okay, either series or parallel fashion, and you are asked the capacitance, equivalent capacitance of the overall system. Okay, next one, dear. The capacitance of an air-filled parallel plate capacitor is 60 pico when a dielectric slab whose thickness is half the distance between the plates is placed on one of the plates covering it entirely. The capacitance become 86 picofarad, neglecting the fringing effect. Okay, that is the external field. Okay, we assume that there is no field external to the plates. Okay, and that can be maintained and that can be justified if you take the plate separation very small. Okay, the relative permittivity of the dielectric will be how much? Come on, tell me. Come on, tell me. Hanji. The capacitance of an air-filled parallel plate capacitor is 60 when a dielectric slab whose thickness is half the distance between the plates, again parallel plate configuration बनने वाला है. The capacitance initially air-filled capacitor. देखो दो cases लेंगे. Okay, initially it's a air-filled capacitor. Okay, initially it is an air-filled capacitor. Okay, it may be having some plate area S and separated by a distance D. The capacitance of this configuration, let's call it as C naught, and that is air hai, so permittivity is epsilon naught S by D, and that is given by the formula 60 picofarad. That is given the value. Now, when a dielectric slab whose thickness is half the distance between the plates, okay, whose thickness is half the distance between the plates. Okay, so here we filled up another dielectric. Okay, and we need the relative permittivity. First, suppose let's assume that it has the permittivity epsilon. Okay, and this distance is basically d by 2, and this also remains to be d by 2. Plate area remains to be same. So what is going to be the capacitance? Again, this is going to be the parallel series capacitor case. Okay, C1 and C2. Okay, so what is the C equivalent here? Okay, that is C1, C2 by C1 plus C2. Okay, whose thickness is half the distance between the plates, covering it entirely. This parallel, this capacitance is 86 picofarad. Okay, now what is this one? The remaining part is of course air only with the permittivity epsilon naught. So dear, what is the C1 and C2? Okay, what should be the C1 and C2? Individually, if I calculate C1, epsilon naught into S same rahega, epsilon naught S upon D by 2. So that becomes 2 epsilon naught S by D. That is 2 C naught. C naught के terms में लेके चलते हैं. And the C2 is, okay, C2 is कितना हो गया? Okay, that is epsilon R epsilon naught. Okay, this epsilon can be written as epsilon R epsilon naught, and we need the value of epsilon R only. Epsilon R epsilon naught. Okay, divided by again D by 2, okay, into S. Okay, so 2 epsilon R epsilon naught S divided by D. So this is 2 epsilon R C naught. Okay, so अब यहाँ से आ जाएगा C equivalent. Okay, C1 C2, that is 2 C naught into 2 epsilon R C naught divided by addition of them. Okay, so 2 C naught plus 2 epsilon R C naught. Straight away 2 C naught common, one of them is cancelled. You are left with 2 epsilon R C naught. Okay, 2 C naught from here is cancelled. Okay, so you are left with 1 plus epsilon R. ठीक है, अब देखो C equivalent is 86 picofarad ना. Okay, that means 2 epsilon R, C naught is 60 picofarad upon 1 plus epsilon R. This should be 86 picofarad. This should be 86 picofarad. Okay, तो picofarad भी cancel कर दीजिए. Okay, you have 2 epsilon R upon 1 plus epsilon R should be equivalent to 86 is divided by 60. In the simplified form, if I cancel with 2, 43 by 30. Okay, 32s are 60 epsilon R is equal to 43 plus 43 epsilon R. So the value of 17 epsilon R is 43 and epsilon R is 43 is divided by 17. Numerical answer type question hai. Okay, 43 divided by 17, it's 2.53 approximately. Anybody with the answer? Do we have options here? No, it's an NAT question. 2.53. 2.53. Correct, Bhanu? 2.53. Correct, G. Okay, Ji. All right. Thank you, Kishan. Chalo. Next question, dear. A coaxial cylindrical capacitor of inner radii 1. So inner radii is known as the A. Outer radius is known as the B. Has the capacitance per unit length of 172 picofarad per meter. Capacitance per unit length C dash, which was C by L, that is given to you 172 picofarad per meter. Capacitance per unit length, so per meter. If the ratio of the inner to the outer to the inner radius is doubled, then what will be the new capacitance per unit length? देखो, अब सबसे पहले क्या बोला है, देखो in the first scenario C1 dash will be, okay, 2 pi. What is the formula for C by L? 2 pi epsilon. Epsilon remains to be same. We are only changing the radius. 2 pi epsilon upon ln b by a. And what is the inner to outer to inner radius? B by a, outer to inner. 5 by 1. mm cancelled. And this is 172 picofarad per meter. Okay. Now, what you are looking for is, okay, now, if the ratio to outer to inner is doubled, B by A becomes twice of what was earlier. So earlier 5 by 1. So now it is 10 by 1. Okay, now it is 10 by 1. ठीक है, रेशियो का डबल क्या, मे बी आउटर रेडियस डबल या मे बी इनर रेडियस हाफ, वो नहीं बोला, बट रेशियो डबल्ड एंड एनीवेज आई नीड द रेशियो ओनली ln b by a. Okay, so now the new capacitance C2 dash will be given by the formula 2 pi epsilon upon ln 10 by 1, that is ln 10. Okay, so 2 pi epsilon will be fixed, na? 2 pi epsilon, we are not changing the material between them, so epsilon will be fixed. So what is this 2 pi epsilon? It is 172 ln 5 now divided by ln 10. Okay, that is the answer. The new capacitance will be natural log, right? (120.22). अच्छा, what was the unit here? 172 जो लिखा है मैंने, that is pico. So here same unit pico will be copied. 120.22 pico farad per meter, and ये भी है 120.22. They are asking in pico only, pico farad per meter, perfect. Pico farad per meter. Okay, ji. So guys, yes, a reminder that today at 7:30 p.m. Wednesday, okay, that is just today only, at 7:30 p.m. on your BYJU'S exam prep, I am coming you with the free live interactive workshop. 7 golden and very important rules to make your gate preparation solid, to ace gate in the first attempt. Okay, with the ranks like single digits. Okay, what should be the techniques? Okay, let's learn the strategy on the BYJU'S exam prep app. Download the BYJU'S exam prep app from the Google Play Store, or you can directly go to the description of this video. You can directly download the app from there itself. Okay, and also then if you plan to enroll into any courses and looking for scholarships, looking for financial assistance, appear in the National Scholarship Test coming Sunday. You can appear anytime from 9 a.m. to 9 p.m. as per your convenience, and based on your performance, you can get as much as up to 90% scholarships. Okay guys, so time for break. It's 1:30, it's almost 1:34. Okay, so now we go for a lunch break, dear, and we will resume after it. Okay, we will resume after it. Okay, so lunch break, approximately, it's a proper lunch break. Let's take it to be round of 20-25 minutes. Okay, let's make it 20-25 minutes, so that after that we can have another non-stop 2-3 hours discussion, whatever it goes on. Okay, magnetostats, boundary condition, we'll see other topics also. So let's start. Okay, let's start immediately at, it's almost 1:35, so let's start. Let's keep the target 2 p.m. Let's keep the target, dear, at 2 p.m. Let's keep the target at 2 p.m. So that makes it more or less 25 minutes. That makes it more or less 25 minutes. Okay, ji. See you. See you. Okay. Okay. All right. Hi, good afternoon. Let's continue once again. Good afternoon, everybody, and let's continue this session. Very, very good afternoon, everyone. Let's continue. Let everyone join quickly. Chalo. Not knowing right now, Shivam. Okay, chalo. So let's get moving ahead. Confirm me if there is any issue. I hope the audio, video, everything is good at your end. Okay. Okay, ji. Chalo. So we are resuming now. Very good afternoon, everyone. This is the updates I told you. And now let's move towards the Biot-Savart's law. Okay. The Biot-Savart's law. Okay. The Biot-Savart's law, which states that the differential magnetic field, the small magnetic field produced at a point P due to a small current element IDL is proportional to the product IDL and the sine of the angle alpha between the element and the line joining the point to the element, and is inversely proportional to the distance. Okay, to the distance, the square of the distance again will come up. Okay, joining the element. So this differential magnetic field proportional to IDL, it is also proportional to sine alpha. What angle alpha I'll explain you, and it is as always proportional to 1 by r square. Okay. So in general, dH proportional to ideal sine alpha by r square. To remove the proportionality sign, we introduce the constant of proportionality known as k, and dH will be known as ideal sine alpha divided by 4 pi r square. Okay, that is a differential field due to a small current element. So let's say this is a small current element. See, this looks like a big picture. Okay, but the reason that I take a big picture, simple reason is that we need to zoom the picture and see. Ultimately, what you have to assume, it's a very small current element. Okay, now I join this point P. This is the point of observation where I am interested in calculating the magnetic field now. Okay, I join this point, okay, with respect to the current source. Okay. The angle alpha between the current source, that is a small current element ideal, and this line joining the current source to the point of observation, that is known as alpha. That angle is known as what? That is known as the alpha. Okay, we can assume that the point of observation is at a distance r with respect to the source. As per Biot-Savart law, we have ideal dH equal to ideal sine alpha by 4 pi r square, and then we know that ultimately magnetic field is a vector quantity, though we'll be representing in the form of a vector product because sine alpha comes in the form of vector product. So, we can express this particular numerator in the form of vector product. The vector product, cross product, basically given by ideal cross AR, where AR is the unit vector, as again AR is the unit vector from the line source towards the point of observation, from the line source towards the point of observation. So when you solve it, now ultimately what do you get? A cross B is, okay, A cross B is, okay, magnitude ki baat kare, then direction I'll explain to you separately. A cross B is AB sin theta, na? Okay, so A, that is ideal. B, magnitude of AR is 1. The only ideal sine of angle between them, that is sine alpha. So it will be eventually equal to ideal sine alpha that we have written. Okay. And then replacing the AR. What is AR? It is again the unit vector along the line joining the source to the point of observation. Vector R by R can be represented. Let us say this representation is vector R. Okay, so the length of the vector will be this magnitude R. Okay, writing down in terms of capital vector R, so ideal cross R upon 4 pi R cube. Ideal cross R divided by 4 pi R cube. Okay, now since the cross product is coming, so for direction, let's again refer to the right hand thumb rule. Okay, right hand thumb rule or also the right hand screw rule. Okay, now how do you find out the direction, okay, of the magnetic well? Very important. Some questions can be there only on the right hand thumb rule. How? Okay, how? Suppose this is the current element carrying the current in a particular direction. You should know the direction in which the current is flowing. The direction in which the current is flowing. Okay, what you have to do is take up your right hand and place the thumb of your right hand such that the thumb is in the direction of current. Such that the thumb points in the direction of current. Thumb points in the direction of current. The thumb points in the direction of current. Clear? Then the direction of your fingers, the direction in which your fingers curl, the direction in which your fingers rotate, that is known as the direction of magnetic field. So direction, this circular direction in which the fingers rotate, this is mentioned here also. This circular direction in which your fingers are rotating, that is known as the direction of the magnetic field. So here magnetic field, okay, is in the circular direction around the axis of the current. Now for simplicity, what we can do is, let us suppose that this is the z-axis. Okay. Now, if this is the z-axis, dear, what is the circular direction around z-axis known as? We can relate it to the cylindrical coordinates. Okay. We can relate it to the cylindrical coordinates. Okay. The circular direction around z-axis is basically known as the azimuthal direction. Okay. So we can create this like this. Suppose if the current, okay, if the current is along the z direction, then the magnetic field is in the circular direction about z axis, and that is known as the azimuthal direction. That is known as the azimuthal direction of cylindrical coordinate. The circular direction around the z axis is the azimuthal direction a phi. Okay. Not only right hand rule, we can also find out by right hand screw rule. Okay, this is thumb rule and that is screw rule. Now, what does the right hand screw rule says? Okay, in the right hand screw rule, okay, just imagine you are fastening up a screw. Ek screw ko tight karte hai na, you are tightening, you are fastening a screw such that the tip of the screw, okay, should be moving in the direction of current. So current I have taken as upwards. Okay, so if this is my screw and current is upwards, so I should be tightening it in the up direction. Okay. Now, if you are tightening the screw in the direction of current, whatever is the direction of this head, na, ye to circular hai. Whatever the direction in which this head is moving, that is the direction of magnetic field. Okay. The direction in which the head is moving, okay, that is the direction of magnetic field. That is the screw rule. But commonly, thumb rule itself is okay to enable you solve the problem. Okay, to enable you solve the problem. Okay. We'll take up questions on that. But for first, what I'm thinking, let us discuss some formulas and concepts from magnetostatics, and then let's jump to the questions. Okay, Tech Master, we have started from Biot-Savart law only. Okay, chalo. So this is what DH would mean. Okay, now some applications of Biot-Savart law, as again we told in revision, we don't need the derivation part, but there are some important results. A straight current carrying filamentary conductor. Firstly, finite length, and then we will take large length also. A straight current carrying filamentary conductor. Filamentary means a conductor which is very thin, okay, whose diameter is negligible as compared to the length of the conductor. Very thin conductor, you can assume as a very thin piece of wire, okay, carrying a current in a particular, and that's a straight conductor carrying a current in some direction, and that has a finite length, and that is spread here from A to B. Okay, from A to B, you should be able to distinguish. So this is what I mean by the current. This is the current element that is point A to point B, and this is the direction in which the current is flowing. Okay, and out of this current element, we take a small piece. Okay, we take a small piece, and that is known as the small current element ideal, having a small length dl. Current, although is same in this portion, the current is I only, but I consider a small length. Okay, so that I can apply the Biot-Savart law. Okay, then here I apply the Biot-Savart law. Okay, ideal cross AR upon 4 pi R cube. Then solving and integrating, that is the formula for DH. Integrating DH, the derivation again not required here, but integrating DH, what is the formula that you get? You get the formula I divided by 4 pi rho cos of alpha 2 minus cos of alpha 1 A phi. Okay, now see, I have taken the current to be in the Z direction. So that is why the magnetic field is turning out to be in the A phi direction, azimuthal direction. Okay, in general, if the current is not in the Z direction, so what is the direction of magnetic field? Right hand thumb rule. Or I will give you another way to find the direction. Okay, uski baat bhi karenge. Uski baat bhi karenge. But now what is alpha 2, what is alpha 1, what is rho? Dekho, actually this is the axis of the wire. This is the wire and I am calculating the magnetic field at the point P. Okay. Now, the wire, the length of the wire is in this zone. With respect to Z axis is in this zone. Okay. When I connect any part of the wire, when I connect any point of the wire towards the point of observation, I will never get a perpendicular line. Okay. So what I do is, listen to me very carefully. What I do is I extend the axis of the wire. Wire is only from A to B, it has finite length, but at least I can extend the axis of the wire. Okay, so iski axis le li minus infinity se infinity. Take a point on the axis from which you can draw the perpendicular to the point of observation. That perpendicular distance is known as rho. That perpendicular distance is known as rho. So listen to me. Let me place it here. What is rho here? Rho is known as the perpendicular distance of the point of observation from wire nahi bolenge, from axis of the wire. Sometimes it may not be possible to draw the perpendicular from wire to the P, but at least from the axis. Axis can be from minus infinity to infinity. Okay, from the axis of the wire, whatever is the perpendicular distance to P, that is known as rho. Okay, then A rho. What is A rho? It is the direction of this perpendicular line. Okay, it is known as the direction of this perpendicular line जो मैंने ऊपर specify किया है. Okay, so dear, so this distance is rho. This distance is rho, and the direction of this line, perpendicular line, this direction will be A rho. Okay, this direction will be known as the A rho direction. Clear, everybody? Okay. Now, I is the current carried by the conductor, of course. What is alpha 1, alpha 2? देखो, alpha 1, alpha 2 को ऐसे समझ लेना. I will write it in the simple format. So, what is the alpha 1 and alpha 2? Please understand. Okay, alpha 1. Okay, it is the angle with respect to the starting end, but it is coming as an exterior angle. See, when you join point A and point B to the point of observation, okay, ये जो angle alpha है ना, it is coming exterior of this triangle. Okay, so alpha 1 will be known as, we will apply to the problem dear very shortly. Alpha 1 is known as the exterior angle, the exterior angle of the point P, exterior angle of the point P, okay, with respect to the starting end. Okay, exterior angle of the point P. Okay, of course point P का होगा, let me put it simple. Exterior angle with respect to starting end. Starting end मतलब जहां से current start हुआ है, so you need to look into the direction in which current flows. Alpha 2 is the interior angle. Now when you look into alpha 2, okay, this is the angle with respect to the ending end, terminating end of the current, but that is coming interior of the triangle. So I will say that alpha 2 is the interior angle with respect to ending end of the current. With respect to what? With respect to the terminating end बोल दीजिए, ending end बोल दीजिए. Okay, that is the alpha 2. Okay, so alpha 1, alpha 2 clear, rho clear. Now A phi, as I told you, A phi either by right hand thumb rule, or how do you find A phi? Okay, A phi you can find either by the right hand thumb rule. Okay, okay, direction of the field either by the right hand thumb rule, okay, or you find the direction of magnetic field by the formula. You can also find it by the formula AL cross arrow. AL cross arrow. Okay, arrow, direction of perpendicular line, already I explained you. AL, direction of current flow. What is the direction in which current is flowing? Okay, so that is known as direction of current flow. That is known as what? That is the direction of current flow. And arrow is the direction of the perpendicular line, as I already explained you here. Okay, so arrow, this is the direction arrow. Like here current is in the Z direction. Okay, alpha 1, alpha 2 सब कुछ explain कर दिया. Now there can be special cases of it. Okay, there can be special cases of this. Okay, देखो ये मैंने कुछ points हैं यहाँ पे, इसको लिख लेते हैं. The expression is applicable for any straight, this is for any straight filamentary conductor of finite length. Conductor need not be on the Z axis, as I told you. It can be on any axis, but it must be straight. We are talking about straight filamentary conductor. Okay, now the direction is, as I mentioned, AL cross arrow, ये भी explain कर दिया. AL is the unit vector along the line current, जिस direction में current जा रहा है, and arrow is the unit vector along the perpendicular line. Okay, from the axis of the wire to the field point, to the point of observation. ठीक है. Now, when the conductor becomes infinite in length, that is large length, there will be a lot of questions where you will be getting the conductor of large length. So if the conductor is very large in length, I mean ideally infinite, mathematically we put very large to be infinity. Okay, so in that case alpha 1, alpha 2 will have some specific case. Okay, directly formula पे रखते हैं. A very simple logic. Na? If you keep going down, infinite in length means minus infinity से infinity. Okay, so if this point goes towards infinity, आप जितना ऊपर जाओगे देखो alpha 2 will be smaller. Okay, further smaller. ये जो angle है ना, small tending to 0. Okay, alpha 2 will be tending to 0. But what happens to alpha 1? What happens to the alpha 1? By alpha 1 को क्या होगा? Okay, this is currently obtuse angle. Okay, sorry, this is currently acute angle. Okay, suppose point A comes here. Okay, alpha 1 will become 90. Okay, point A goes down. You have to go till minus infinity. So this is now obtuse. This is now obtuse. It was acute, 90 obtuse. It is increasing. When you go to minus infinity, it will be the 180 degree full straight angle it is going to become. Full straight angle it is going to become. Okay, so alpha will be 180 degree. Okay, the alpha 1 will be 180, alpha 2 0. Putting down in the formula, you get I upon 2 pi rho A5. This is actually more important. Both are important, but here lots of direct questions are also coming up. I upon 2 pi rho A5. I upon 2 pi rho A5. Okay, that is the direction of magnetic field due to a long conductor. I is the current carried, rho is the perpendicular from the axis of wire towards the point of observation again. Okay. Then there can be another applications of Biot-Savart law, and that is, okay, a circular loop carrying the current I. Okay, so let's say a circular piece of wire, okay, having some radius rho. This time rho is the radius, okay. Rho is known as the radius of the circular loop of wire. It has some current I, okay, that has been taken in the anti-clockwise direction. By default, okay, that has some current I in the anti-clockwise direction, and we are trying to calculate magnetic field at a point on the z-axis, which is at a distance h above the center. There is a distance h above the center. That magnetic field again from Biot-Savart law turns out to be I rho square upon 2 rho square plus h square power 3 by 2. H is that z coordinate, okay, and rho is the radius of the loop here. So I rho square upon 2 rho square plus h square power 3 by 2 a n cap. A n cap is a unit vector. Okay, A n cap is a unit vector. So before I describe A n cap, let me write down one more case and then I will write down A n cap. So what about the magnetic field at the center of the loop itself? At the center of the loop, so if you calculate the magnetic field here, okay, so what will be the h coordinate? That will also be 0. Okay, that will also be 0. So at the center of the loop, h will be 0. The h coordinate will be 0, and then the magnetic field h को 0 किया. Rho square की power 3 by 2 will be rho cube. So rho square upon rho cube, a rho will be left, and your answer will be I divided by 2 rho A n cap. I upon 2 rho A n cap. And what is A n cap? Now let me write down. What is A n cap? It is a unit vector. Okay, it is a unit vector normal to the plane of the wire. The wire is in xy plane, so unit vector normal to it is AZ direction. Here it will be AZ, in general A n cap. Unit vector normal to the plane of wire, the plane in which the wire, the circular wire is contained. The plane in which the circular wire is contained. Okay, chalo. Next we can go to Ampere circuit law and other discussions also. But chalo, let's complete some theory part here, then let's all together jump to the questions. Okay, then we'll take up questions to all of this. Okay, so now Ampere circuit law. Okay, थोड़ा और continuity में कुछ theoretical points देख लेते हैं, at least basic concepts. Ampere circuit law next important. Okay, which will again give you the next Maxwell's equation also for the static magnetic field. So Ampere circuit law, which states that the line integral of H, circulation of H around a closed path is same as the net current enclosed by the path. Okay, that is integral H dot dl along a closed path sign. Integral H dot dl over any closed path is equal to current enclosed by the closed path. Okay, current enclosed by the closed path. ठीक है? Right. At the same time, the current enclosed can also be calculated as the surface integral of J dot ds. What is J? What is J? The current density. Okay, J is the term which is known as the current density of the medium, which is the current density of the medium in ampere per square meter, current per unit surface area. Okay, so integrating, okay, for the complete surface, you can calculate the net current flowing out of that surface. Now we have integral h dot dl for a closed path, which can be simplified by Stokes theorem. Line integral along closed path, Stokes theorem apply karenge. Okay, so here I apply the Stokes theorem. Okay, and Stokes theorem says that line integral of a vector is equal to surface integral of curl of the vector. So surface integral del cross h, integral del cross h dot ds. Now both are surface integral. Current encloses surface integral of J, current encloses surface integral of del cross H. When you compare both, you have del cross H equal to J. Okay, that is your next Maxwell's equation in the differential form. Commonly for questions, the differential form will be more important for you. So we have the Maxwell's equation related to the Ampere's law. This will be modified later on, but this is for static field, that integral H dot dl equal to current enclosed. Integral H dot dl equal to current enclosed. Okay. और डिफरेंशियल फॉर्म डेल क्रॉस एच इक्वल टू जे. यहां से डायरेक्ट क्वेश्चंस आते हैं आपके लिए. गिवन एच फाइंड द वैल्यू ऑफ जे. ओके, डेल क्रॉस एच इक्वल टू जे. ओके, नाउ नेक्स्ट पॉइंट हियर वुड बी okay, the magnetic energy. Again, like I told you, electrostatic energy density not important for numerical. Only remember the formula for wave propagation. Similarly, magnetostatic energy density. Okay, magnetostatic energy density Wn. Okay, remember the formula, half mu h square, like half epsilon e square, half mu h square. Okay, this was the total energy. Dekho, We, electrostatic energy density, small. Okay, the small We, that is known as half epsilon e square energy density. Similarly, Wm, magnetostatic energy density, is half mu h square, energy per unit volume. Okay. Next point is infinite sheet of current. Okay, what is the magnetic field? Okay, if an infinite sheet of current, again infinite means a large sheet of current. I've again assumed it to be spread on the xy axis. It could be anywhere, but a large sheet of current carrying some current, okay, having the current density K, carrying some current having the current density, that is K ampere per meter. So if I cut 1 meter of this sheet, if I just cut 1 meter of this sheet, what will be the current? Okay, within this sheet available, that is known as K, current density in ampere per meter. Okay, and then the magnetic field, this is again obtained by Ampere's law. That is why you are seeing the ampere and path and all those things coming up. And the magnetic field here is given by, again on the application of Ampere's law, we'll have question. Magnetic field is given by half K cross An cap, where K is the current density. Okay, and An cap is again the unit vector, normal to the sheet towards the point of observation. Okay, An cap is a unit vector that is normal to the sheet towards the point of observation. Okay. Now, just like we had D, let's be analogous in some of the cases. Let's just like we define the electric flux density, D is equal to epsilon E, where E is the electric field intensity. Similarly, H is the magnetic field intensity, and we define the B, that is the magnetic flux density, as mu into H, yeah, mu naught into H for free space, where H is the magnetic field intensity, mu naught is the permeability of free space, whose value we know 4 pi 10 power minus 7. In general, B will be equal to mu H for any other material. B can be in general written as mu H, where mu can be written as mu r mu naught. Mu r is the relative permeability. Okay, and B is known as the magnetic flux density. B is known as the magnetic flux density. Now, B is unit in the measure is measured in the units of magnetic flux density, flux per unit surface area. Okay, flux per square meter, and magnetic flux is calculated in the unit Weber. Magnetic flux is calculated in the unit of Weber. So B will be calculated flux per unit area, Weber per square meter, that is also equivalent to the unit named as Tesla. In short, we'll call it as T. Okay, the magnetic flux density is measured in Teslas or Weber per square meter. Okay, and the magnetic flux here is measured in Weber. So if you know the magnetic flux density, how do you calculate the magnetic flux crossing any surface? That is the surface integral of the flux density over that particular surface. Integral B dot ds. Okay, integral B dot ds is the magnetic flux through a surface, and that is measured in the Weber. And magnetic flux density, of course, is Weber per square meter or Teslas, as I mentioned. Okay, the magnetic flux here will be measured in terms of the unit, that is Webers. Okay, that is known as the Weber. Okay, now the next important theorem coming up to the next Maxwell's equation. Okay, the magnetic flux, okay, through a closed surface, this is through any surface, the flux through any surface is given by surface integral B dot ds. Okay, the magnetic flux through any closed surface in a magnetic field must be zero because of the concept of, okay, because of the concept that there are no magnetic monopoles due to the absence of magnetic monopoles. Magnetic field always forms a closed path. Okay, magnetic field always forms a closed path. Okay, so let's say you have a magnet, you know, even if I assume it to be Bohr magnet, assuming it to be north and south pole, the magnetic field line direction is always from the north to the south. That is how we define north and south. The magnetic field is oriented from north to south. But you take any closed surface, okay, Acha, first of all, if you cut it into two parts, what's going to happen? Okay, if you cut it into two parts, does it mean that you have separated a north pole and the south pole? No, each individual piece of magnet will still have their own north and south pole, will still have their own north and the south pole, will still have their own north pole and south pole, and when you try to measure their magnetic field, you will again get the pattern of the closed path. You will again get the pattern coming up in the form of closed path. Okay, at how many pieces you want to consider? Break it even into the smallest possible piece. Okay, break it even into the very smallest possible piece also. Then when you observe the magnetic field, it will again be coming in the form of closed loop. That means there is again a north pole and the south pole. The field lines start from north pole, terminate on the south pole. Okay, however small piece you take, you can never separate magnetic monopole. You can never separate the north pole and the south pole. Magnetic lines always exist in the closed path, always exist in pair. They are known as magnetic dipole. And whenever you take any closed surface, okay, whenever you take any closed surface, so what is going to be over this closed surface, the flux crossing is calculated as B dot ds. Okay, and that must be how much? Okay, because there are two poles of opposite polarity available. When you integrate, you get zero. This proper derivation I have not completed, but yeah, rough hints I am giving you. Okay, and that's going to turn up to be zero. When you calculate the flux through any closed surface, it's always going to turn up to be zero. So integral B dot ds over a closed surface is equal to 0. And then integral B dot ds over an integral of any vector over a closed surface can also be simplified using Gauss divergence theorem. And as per Gauss divergence theorem, you can write down surface integral of B is equal to volume integral of divergence of B. Okay, so this is also 0. So that means del dot B equal to 0. The final Maxwell's equation, the fourth Maxwell's equation for static field. Okay, the fourth Maxwell's equation for static field. Okay, this is analogous to Gauss law discussion for electrostats. Okay, so the next and the fourth Maxwell's equation in our sequence is del dot B equal to 0. This may be important hai. Okay, questions can be expected on this also, as we are going to see. We'll take up questions soon. So del dot B, the divergence of magnetic flux density vector, is always 0. Okay, is always 0. Okay, is always 0. Okay, so these are the Maxwell's equation that we have discussed till now. But for static electric and magnetic field, for time varying fields, results will change. But this is for the static electric and magnetic field. Okay, after time varying field discussion, we'll have a quick conclusion of all this. Okay, so the differential form is basically known as, okay, one by one. First of all, we had the discussion with respect to Gauss law. Okay, flux is equal to, see, what was the Gauss law? Xi is equal to Q enclosed, onto which, from which we got del dot D equal to rho V. We have taken the questions also, important questions here. Okay, that is a differential form. Integral form, देखो अब xi कैसे निकालते हैं? The flux over any closed surface is integral of flux density vector is equal to charge, and charge is calculated as volume integral of charge density. So that gives the integral form. Okay, ये सब हम देख के आ चुके हैं. Then just now I told you magnetic monopoles do not exist, and that is why del dot B equal to 0, or flux through any closed surface. Okay, flux through any closed surface, xi over any closed surface. Okay, closed surface, here is 0. Okay, here is 0. In the electrostatic field, you can have an isolated charge, but here you cannot have an isolated pole, and that is why, and there are two poles of opposite polarity. It's like Q1 plus minus Q1. Q plus minus Q, resultant will give you as 0. Okay, so that is the next Maxwell's equation. Third, that we discussed with respect to potential. The potential difference between any 2 points is independent of the path taken, and that is why we have del cross E equal to 0. Okay, the electrostatic field is conservative in nature, or the line integral of electric field over a closed path will be 0, integral form. And just now, a few minutes back, we saw Ampere's circuital law. Okay, del cross H equal to J, or okay, del cross H equal to J, or line integral, okay, of H is equal to current enclosed, and we have written the current enclosed as integral J dot ds. That becomes the integral form. But again, I repeat, for majority of the questions, what will be important for you is the differential form. Okay, will be the differential form. These are for static electric and magnetic fields. For time varying, the final results will be slightly different. Okay, not all four, 2 of them will be changed. 2 of them will be changed. Okay, 2 of them will be changed. Okay, the curl results will be changed. Okay, del cross E will not be equal to 0 for time varying field. Let me see how much you remember. Revision session, hai na? Can you say, I'll tell you, for time varying fields, del cross E will not be equal to 0. Okay, which law will be used to come up to the final expression of del cross E? Which law will be used to come up with the final derivation of final discussion of del cross E? It will be non-zero. And there we discuss one more form, one more law. And what is that? What is that? Tell me. बता दीजिए, we'll revise, we'll come to that also, but अभी यहाँ पे इसको finish करते हैं. Okay, so forces due to magnetic field. Okay, sometimes a question can be on forces due to magnetic field. Yeah, correct. That is due to the Faraday's law. Correct, Abid. Correct, Ananta. It's basically the Faraday's law. Faraday's law of electromagnetic induction. Okay, a magnetic field can exert force only on a moving charge. It cannot exert force on a stationary charge. Okay, and again, experimentally, it has been found that the magnetic force Fm experienced by a charge Q, which is moving with some velocity U in the magnetic field, okay, is given by the formula Fm, the force Fm, Q into U cross B. Q into U cross B. Okay. Because of the cross product, we can say that the net direction of force is perpendicular to the plane containing both the vectors u and b. That means it is perpendicular to both u and b. It's perpendicular to both u and b. Okay. Now, if there is a charge moving in the presence of both electric and magnetic field, so what is the total force? Fe plus Fm. Okay, so there you get the Lorentz force equation. Total force experienced by a point charge in the presence of both electric and magnetic field is Fe plus Fm, where Fe we all know is Q into E. The Fe part is Q into E, Fm part is Q into U cross B. Q into U cross B. Addition of both will give you the Lorentz force equation. But if it is by chance a stationary charge, maybe electric and magnetic field both present, but if it is only a stationary charge, then the net force acting on it will be given by what formula? Okay, will be just equal to Fe. Okay, a stationary charge will not experience any magnetostatic force. That will be just equal to Fe, and that is given by Q into E. Okay, that is given by Q into E. Simple questions can be expected from here. Okay, simple questions can be expected from here. Calculation of the forces, maybe electric force or magnetic force, and sum total of them, Lorentz force equation, Fe plus Fm. Okay, that will be Fe plus Fm. Now, what is the force on the current element ideal? Force on a small current element ideal in the presence of magnetic field. That small force is given by ideal cross B. Okay, if it is a uniform line current, the force can be also written as IL cross B. Okay, the Fm, okay, on a uniform line current, IL cross B can also be written here. Okay, that forms one more next category of question. अच्छा, ये जो point charge वाला हमने theory देखा है ना, देखो. Let's talk about this magnetostatic force. Okay, let's talk. There are some cases that can come up for you. Okay, so we have Fm is equal to, we have the magnetic force on a point charge moving is given by, okay, Q into U cross B, moving with the velocity U. Okay, good afternoon, Chinmay. Now, there are important and two cases. Okay, if particle is moving in a direction, okay, if particle is moving in a direction which is parallel to the B field, okay, which is parallel to the B field, okay, which is parallel to the B field, okay, so U cross B 0 ho jayega, no net force, and when you derive the trajectory of the particle, again, I'm not deriving it up, but when you derive the path of the particle, okay, the particle will continue in a linear motion in its original direction. Particle will move along a linear path, decided by its initial velocity. Okay, the particle will be simply moving along a linear path. Okay, but if it has the velocity component perpendicular to b, two special cases, it could be in any other direction also, but two special cases, if u perpendicular to b, okay, then the particle will move. Okay, we derive and we come to a conclusion that the particle will move along this was along a linear path. Particle will move along a circular path. The particle will move along a circular path. The particle will be moving along a circular path. Along what? Along a circular path. Clear? Along a circular path. Okay. Right. Achha, in that case, if it is moving along a circular path, it will have a radius. So, dekho, the net magnetic force, okay, the net magnetic force here, okay, is equal to how much? QUB. It will become QUB. Why QUB? Why QUB? Because I have taken perpendicular, theta equal to 90, sine theta will be 1. So magnitude of the force will be QUB, and that will be equal to this magnetic force provides a necessary centripetal force for the circular motion, and that centripetal force is given by the formula mv square by r, yeah, mu square by r. Okay, so this magnetic force provides a necessary centripetal force, and now the radius of the circular path in which the particle is going to move, that turns out to be how much? U and U, once you can cancel. Okay, you will have the formula m into u, okay, divided by qb. M into u divided by qb. Right? Acha, so there was one question also. Okay, there was one question also. Okay. So there can be third case. A question पूछा था ISC ने 2016 ISC asked one question. So if you have a U, okay, which is having two components, U1 plus U2, such that one of them is along B, okay, one of them is perpendicular to B. Okay, say for example, the magnetic field is given as somewhere, suppose B naught AZ. Okay, and the velocity of the particle is given as okay, suppose the velocity of the particle is given as, suppose, ux ax, okay, plus uz az. Okay, so velocity has two components here. Okay, one of them along the x direction where x is perpendicular to z, so this is perpendicular to the B field. Okay, and another one is in the z direction, which is along the B field. That means parallel to the B field. Okay, whenever the particle has velocity components, one of which is parallel, one of which is perpendicular to the field. Okay, so the parallel component, what is the role of the parallel component? Okay, the role of the parallel component is to make the particle move in a linear path. The role of the perpendicular component is to make the particle move in a circular path. The combination of them, the particle will be trying to move in the circular path, but also along the linear line decided by the initial velocity of the particle, and ultimately it is traveling in a helical path. Okay, so there the trajectory of the path that turns up is the helical path. Okay, is a helical path. The particle will be then moving along the helical path. The particle will be then moving along what? Along the helical path. Along what? Along the helical path. Okay. Chalo. This was done. This is done. Yeah, guys. So this is just quick reminders that we are meeting on the YouTube channel only Saturday and Sunday, 20 and 21st of January, with the complete mathematics revision. 2 days we are taking so that lots of chapters are there in maths. Okay, so that we can discuss majority of the concepts there. Revision marathon 21st January engineering maths on the YouTube, same YouTube channel where you're watching this session. Okay, and Friday 5 p.m. before that the strategy session. Okay, because limited time is left. So in the limited time, what should be the strategy to target full on full in the maths? Okay, now let's get started with the question. Let us get started with the question. Okay, Acha, something before I start the question, I want to discuss. Something before I start the question. So tomorrow I was supposed to take EMFT EC part 2, but your attendance is not promising, and this low attendance, putting, giving you the content, putting the entire day, I don't think it makes sense. And tomorrow will be only EC. Today's EC plus EE attendance. I doubt what's going to be the EC attendance. So it's not that I don't want to take, I will not be taking. But what I do is, so there are four major parts जो exclusively EC होता है. Okay, there are four major parts: wave propagation, transmission line, waveguides. Within the waveguides, you can consider fibers also. Optical fiber is a type of dielectric waveguide. Okay, so wave propagation, transmission line, waveguides, and antenna. These are the four major parts. Okay, there can be internally many topics. Okay, and I know the topic which is very, very important and little complicated and little typical for students is antenna. Let's see, that will be proved tomorrow, no, Jashwant? That's what I'm telling. Okay, I also need to assess that the energy is being put in the right direction. So just wait, I'm announcing something, Jashwant. Thoda sa wait kijiye. Okay, so what I'm doing is, I believe you also let me know if I'm right, that the major area where students sometimes they miss up the topic, they leave that topic, but questions are almost coming up every time. And I think ISC making the paper, definitely antenna questions and waveguide questions will be there. Waveguide is mostly easy. Once you study the waveguide, the questions based on waveguides are mostly very easy. Antenna is one topic where students little bit feels challenging. Let's do this tomorrow. Listen to me completely. Let's do this tomorrow. पूरा अच्छे से detail में antenna discuss करते, rather than revising it. Let's discuss the antenna, different variety of questions. One of the more important topic. Okay, tomorrow. Okay, then tomorrow same morning hours. Then if you feel that yes, if I feel that yes, you are really interested and you want to maintain the attendance, कल ही discuss करेंगे. Dear, I will take transmission line, wave propagation ले लेंगे. But let me see. Okay, because if I come with the complete planning and then students are not there, initially I start with wave propagation, attendance और drop हो गया होगा. Finally last topic तक आते आते मेरा ही motivation नहीं रहेगा. How will I be able to cover the most important topic then? So let us start with antenna. Sounds good now? Tell me. Sounds good? Okay, sounds good. Let's cover it. Antenna, at least very important. I'll see tomorrow how the attendance, how the strength is. We'll cover other topic. उसका एक अलग session बना लेंगे. No issues. Okay. Fair enough. Tell me, chalo, quickly. Acknowledge this quickly. So it's up to you to decide. It's not up to me to decide. It's up to you to decide. So I'll tell you honestly also. I know today I will be busy. So today I have a workshop also. Today I already having a marathon. I know I am busy till evening with the marathon. Then I have a workshop. So I knew that I'm going to be busy today. So the PPT for this class, the PPT for this class, I've already given for creation. By evening, I will automatically get the entire PPT ready. Okay. So मेरे लिए वो भी problem नहीं है. We have the PPT also ready. But let's see the motivation. Let's see the motivation. Okay, there is no number, but it's logically understood, Jashwant. So we'll see. We'll discuss that tomorrow. ठीक है, कल आते हैं. Tomorrow I am not cancelling any session. I am there for you. Okay, and have I selected the right topic for tomorrow? ये भी बता दीजिए. ठीक है, अगर सबसे पहले कुछ सबसे जरूरी करना है तो एंटीना सही लिया है कि नहीं? Tell me. See, wave propagation mostly easy question. There you face the challenges in reflection, refraction. उसको अलग से discuss कर सकते हैं if you want. Reflection, refraction is challenging here. Okay, transmission line, some good question practice can be held from transmission line. But overall, whether I've selected the right topic to begin or not, at least ये तो कर लेंगे. And then we'll spend good time on it. Okay, the advantage will be, I'll tell you one more advantage of this scheme. We'll spend more time over it. Start यहीं से कर रहे हैं ना. Beginning we'll spend more time over it. Different variety of question and concepts that can come up from the antenna, every possible thing. Okay, including up to the Frisch equation related with radar concept, everything cover करेंगे. ठीक है? Fair enough? चलो, so all are happy with this decision. And tomorrow we'll decide. ठीक है? Tomorrow we'll decide कि Friday एक और topic ले सकते हैं after the maths marathon. Okay, reflection. So tomorrow you can let me, that also we can do. Okay. Tomorrow you can let me know कि if you face any difficulty in any of the topic like reflection, refraction, उसको अलग से cover कर लेंगे, especially oblique case. Okay, especially oblique case. ठीक है. So yeah, some of you are coming up with waveguide, no problem. You let's see how the response is tomorrow. Friday or Monday, Saturday, Sunday, so we have maths. Any one of the day we can think about waveguide also. Waveguide is actually very easy. Waveguide एक बार पढ़ लिया ना, it is scoring. Waveguide you should never miss, because if you study 100% question convert होगा. It is 99% very easy question. Antenna से तो still there can be a good question. So in antenna we'll cover up to antenna array also. Antenna array भी cover करके जाएंगे, ठीक है? Antenna array भी cover करेंगे. I think fair enough. Okay. A conducting wire of length 2 meter along x-axis as shown in the figure. Okay, I'll of length 2 meter. Now I'll slightly highlight this line clearly. Okay, a conducting wire which is along the x-axis and that has the length 2. Okay, this is the wire that I'm talking about. This is the wire specifically that we are talking about. Okay, length 2 along the x-axis. Okay, and carries a current of 10 ampere. Direction of current is also shown. This current is 10 ampere. Okay, find the magnetic field at the point 005, which is a point on the z-axis. Start attempting. Acha, normally you have the habit of looking into the current in the vertical direction. I told you it could be any straight current, finite length wala case hai. But if you want make it vertical, rearrange the picture, make it vertical. Just do it. Just do it quickly, guys. Hanji. Yeah, antenna array also will covered. Okay, yeah. Morning antenna first, antenna. Chalo, so guys, as our regular habit, let's look into this picture from a vertical point of view. Doesn't matter. Okay, and that is oriented from x equal to 0 से x equal to 2. Okay, x equal to 0 से x equal to 2. तो पहले तो coordinates को draw कर लेते हैं. Just what is the one thing I'll do? I'll make the x-axis vertical. And only the y-axis there, because the point of observation is 005. So that is a z-axis point, okay? So what I'm putting here is, this is the z-axis, suppose, and this is the x-axis. The current source is on the x-axis. The current source is on the x-axis of the finite length, which is 2. Okay. Okay, so there is the current in the x direction, and that is the current of 10 ampere. That is known as the value of I. Okay, and the point of observation is 005. That is the z-axis point. Okay, now dear, what is the formulation? We know that H is given by what formula? Wire of finite length. I upon 4 pi rho cos alpha 2 minus cos alpha 1. Cos alpha 2 minus cos alpha 1. Okay, AH. Okay, अब देखो, what are the values? Okay, what are the values? देखो, I, current is 10 ampere. Okay, AH, चलो इसको निकाल लेते हैं पहले. Direction of magnetic field, wherever the current may be, whichever axis is, that is why I given you the formula. AL cross arrow. Now, what is going to be the AL? What is going to be the AL? Direction of line current. Tell me what is going to be the AL. That is the direction of line current, the direction of current basically, and that is along the x direction. So ये लिख दिया x. What is the arrow? Direction of the perpendicular line. So what we do is, we draw a line perpendicular from the axis of wire. So we can start from here only. This is the point A. Okay, when I join it from here, this itself is perpendicular. No need to extend the axis. So let me draw this particular line. Okay, let me know this particular line, and this is known as the arrow direction, and this is clearly along the Z direction, and the distance of this, the perpendicular distance of the point of observation from the axis of the wire, 000 to 005, that's 5 unit. So rho ka value bhi aa gaya. Okay, so we have rho equal to 5, and this is ax cross az, x cross z, z cross x is y, so x cross z, the direction of magnetic field will be in the minus y direction. You can calculate from right hand thumb rule also. Okay, now alpha 1 and alpha 2. Acha, so alpha 1 was the, dear, alpha 1 is known as the starting angle with respect to starting end, and that is the exterior angle. Bahar ki taraf lenge, so it is clearly perpendicular 90 degree. And alpha 2 ke liye ye joining kar dete hain. Alpha 2 interior angle with respect to terminating end. Okay, point of observation terminating end se join karenge, and the interior side angle, that is alpha 2, and alpha 2 can be obtained by trigonometry. Opposite side we know, opposite side upon base, that is tan alpha. So alpha 2 is gonna be tan inverse of opposite side 5 divided by the base, and base of this line, this is the length AB. Length of the wire is given to be 2. Tan inverse 5 by 2. 68.2 degree approx. Okay, so we know all the values now. Alpha 1 ka value pata chal gaya 90 degree. Okay, this is 68.2. Okay, so the value of the magnetic field here, answer coming up straight in your path, 10 is divided by 4 pi rho, that is equal to 5. Cos of alpha 2, that is cos of 68.2 degree, minus cos 90 degree, which is 0. Direction will be minus AY. Calculate cos 68.2, multiply by the given parameters. Cos 68.2. (0.059). So the final answer for the magnetic field is minus 0.059 AY. It is minus 0.059 AY. It is minus of 0.059 AY. Okay, in the form of magnetic field is measured in ampere per meter. Or if you want, you can also write 10 power 3 le jayenge. So this is minus 59 AY milliampere per meter. Okay. No, alpha 1 is always exterior angle, Jashwant. Alpha 1 has to be exterior angle only. Clear, everybody? Alpha 1 exterior. Okay. So even if you are taking interior, here both will be 90. Otherwise, in general, if you can, to solve in general, you first take interior only, 180 minus interior. Solve karne ke liye, suppose if it was not 90, Jashwant. Okay, if it was something like this, suppose the current was starting here. This is the alpha 1. But how do you calculate? First calculate the interior. Okay, first calculate the interior wherever you require. नहीं, ये तो directly यहाँ से भी निकाल सकते हो. So that you have to see basically what is given, what is not given accordingly. Okay, accordingly. Here directly exterior आएगा, but for that you should know this much of the length. Okay. Here directly exterior निकल सकता है, but you should know this much of the length. Ultimately, however you solve, the final angle has to be the exterior angle. It has to be the exterior angle only. ठीक है? Chalo, moving ahead. Done. This question is done. Minus 59 AY milliampere per meter. Next question. Okay, purely direction based. ठीक है, ये direction based है, इसको देखते हैं. Two infinitely long wires carrying the current are as shown in the figure below. One of the wire is in the YZ plane and parallel to the Y axis, and another wire is in the XY plane parallel to the X axis. Which component of the resultant magnetic field are non-zero at the origin? Which component of the resultant magnetic field are non-zero at the origin? Okay. Which components of the resulting magnetic field are non-zero at the origin? Are non-zero at the origin. Which of them are non-zero at the origin? देखो, two infinitely long wires carrying the currents are as shown below. Okay, right? नहीं, there is no sign formula, Lokesh. What non-zero at the origin? तो देखो, यहीं पे solve करेंगे. This is the origin, and they are infinitely long wires. Okay, infinitely long wires. Let us only try to focus on the direction of magnetic field at this point due to both. Okay, due to the both. Okay, now for direction of magnetic field, what is the formula we can use? We can use the formula AH as AL cross arrow. We know the direction of current. We also need what is the direction of the perpendicular line. Okay, this is the first wire. Let us call it as AL1, and this current is along the y-axis. This is the second wire. Okay, the direction of the current in the current flow in the second wire AL2, and that is clearly parallel to x-axis. Mentioned bhi hai upar. So this is AX. Now this is A rho 1, the direction of the. Okay, what do? We join the point of observation perpendicularly through the axis of the wire. Okay, so this is A rho 1, the perpendicular distance from the axis of the first wire towards the point of observation, clearly in the minus z direction. Okay, and then similarly we have to draw this perpendicular from the axis of the second wire. Okay, from the axis of the second wire towards the point of observation, and let us say this direction is known as A rho 2, and this is opposite to y direction. This will be minus AY. Okay, so what is the direction of AH1? AL1, okay, that is y direction, cross A rho 1, that is minus z direction. Okay, y cross z is x, so this is going to be minus x, no problem. AH2, okay, again AL, what is the direction of the line current AL2? That is AX, cross product with AZ. Okay, cross product with the A rho, and that is minus AY. X cross y is z, x cross minus y minus z. So there will be two components of magnetic field. One will be in the x, one will be in the y direction. Okay, it's in the xy direction. Option number B. There will be the x. One is the x, one is the z. So it's D. X and z components are available. It is D. That is the x and z component available here. Correct answer: Hari, Lokesh, Bhanu, Chinmoy. It's a correct answer. D. X and z components are available. The x and z components are available. Okay. So direction based questions can also be there. Next one, the magnitude of magnetic field at a radius 2, okay, from a long linear conductor. See, when I say long, how long? Did I mention? How long? Not mentioned. So infinitely long, very long. Okay, when I say long, there is no length mentioned. It means infinitely long, that is infinite length. You have to consider, these are very common languages, you have to consider infinite length. Okay, now due to wire of infinite length, okay, it's like a wire, long straight wire of infinite length. So magnetic field is given by I upon 2 pi rho. Only magnetic field intensity is given, na? Okay, so केवल वो लिखेंगे हम magnitude I upon 2 pi rho. What is that magnetic field given? 1, and that is the current. How much? That is what they're asking. It should be equal to I divided by 2 pi rho. At how much distance from the wire? At the distance at the radius of 2 from the wire. So what is the current flowing in the wire? Okay, to produce this magnetic field is 4 pi ampere. Okay, it's 4 pi ampere. So I told you for infinite long wire, direct questions can be expected. Next question. How much current must flow in the loop radius? Okay, circular loop of wire. Okay, to produce the magnetic field 1 milliampere per meter at center. Okay, so at the center, okay, the magnetic field, again strength is given, na? Only strength. The magnetic field is given by what formula? I divided by 2 rho. Direction is AN cap, but यहाँ पे केवल strength compare करना है. At the center it was I upon 2 rho, where rho was the radius. In case of circular loop of wire, rho was the radius. Now magnetic field given है 1 milliampere per meter, and that should be equal to the current. How much current must flow? वो निकालना है, divided by twice the radius. So the current is equal to 1 into 2, and the unit will be milliampere. Meter cancel होगा. 2 milliampere. Answer is C. It's going to be 2 milliampere, and the correct answer is C. Next, the magnetic field intensity is given to you H. 3AX plus 7YAY plus 2XAZ ampere per meter. What is the current density J? Okay, a very regular question. Given H, find the value of J. Ampere's law, direct application. J will be obtained as del cross H. Question can be in any coordinates, but here, okay, here it is in the cylindric, it is in the Cartesian coordinates, X, Y, Z, Cartesian coordinates. And to calculate the curl, we have the simple formula, the determinant formula, where first row I will write down unit vectors AX, AY, AZ. Next row I will write down the partial derivatives del by del X, del by del Y, del by del Z. And next I would be placing the vector components, that is 3, this is 7y, and this is 2x. Okay, just solve it up. The determinant, cross multiply AX del by del Y of 2x 0, del by del Z of y component 7y term will be 0, minus AY del by del X of 2x, del by del Z of 3, plus az del by del x of 7y, del by del y of 3, both are 0. So answer is just turning out to be minus 2ay. Your question is solved. Minus 2ay, answer is A. Minus 2y, the correct answer here will be equal to the A. Okay. Next question. Given the magnetic vector potential, okay, you are given the magnetic vector potential 2 by ax minus xay Weber per meter. What is the magnetic flux density? What is the magnetic flux density given by? What is the magnetic flux density given by? Given the magnetic vector potential, okay, what is the magnetic flux density? Now, what is the relation between flux density and the vector potential? I think ye cover nahi hua tha. We'll write it separately. Okay, if A is the magnetic vector potential, then the magnetic flux density is given by the curl of A. In electrostatic, we define the electric potential as the scalar electric potential, but in magnetostatics, we define it as the magnetic vector potential, and that is del cross A. Okay, so this is also the next category of question. Given the vector potential A, what is the magnetic flux density? Okay, what is the magnetic flux density? Okay, so magnetic flux density B, as I just told you, has to be solved using curl of A. Okay, the curl of A, okay, Cartesian hai once again, so simple. Okay, the first row ax, ay, az, the unit vectors, that is ax, ay, az, then the partial derivatives del by del x, del by del y, del by del z, and the vector component, x component is 2y, y component is minus x, and there is no z component. So I'll place 0 here. Okay, solving it up, so I will be getting ax del by del y of 0, del by del z of minus x will be 0, minus ay del by del x 0, del by del z of 2y 0, plus az del by del x of minus x minus 1, del by del y of 2y will be 2. So this is resultant minus 3az. Minus 3az. It's C. As we know, the magnetic flux density measured in Weber per square meter or Teslas. So minus 3az Teslas. That is known as the minus 3az Tesla. Minus 3az Teslas. Next question. The vector B represents a magnetic field. See, because of the involvement of this magnetic flux density in the calculation of force, okay, if you go and check once again, we have written for line current, we have written the magnetic field as IL cross B, assuming it to be parallel, assuming it to be theta equal to 90 perpendicular direction. We can also write it as ILB, and then the B is known as force per unit current element. Okay, just like force per unit charge was known as electric field, right? Force per unit charge was known as electric field. Similarly, force per unit current element, because current element produces field, just like point charges produce the electric field, force per unit current element is also known as the magnetic field. Okay, so magnetic flux density commonly is also represented as magnetic field. Okay, the H, magnetic field intensity. So now if we call B as the magnetic field, so H will be clearly now known as magnetic field intensity, magnetic field strength, magnetic field intensity. Okay, the force per unit current element gave this definition. Okay, now ultimately, whether it is magnetic field or flux density vector, what is the important property we have learned? It satisfies. The B vector always satisfies. Okay, the Maxwell's equation, guys, del dot B is always 0. Del dot B is always 0. So यहाँ पे भी questions आते हैं आपके लिए. Del dot B equal to 0. Okay, so divergence of B, and that is again a Cartesian coordinate. So del by del x of the x component, del by del y of the y component, del by del z of the z component, which is minus kxz, and this must be equal to the 0. Okay, so ये हो गया 2x, ये हो गया y का derivative 1, so minus x, and z का derivative 1, minus k is x is still left, and that is equal to 0. Okay, so 2x minus x, this is x, minus kx equal to 0, that can give you the solution k equal to 1. Okay, so the value of constant k to satisfy this condition is k equal to 1. So whenever you have a question on B, you can easily use the condition del dot B equal to 0. It's always applicable. Okay, the answer will be 1. Option is B. Correct? Option number B, correct answer 1. Next. This is also a decent question. Let's take this. Let's take this question. This is also a decent one. We'll plan and let you know in the mathematics class, Jashwant. Yeah. Planning something, I'll let you know in the mathematics marathon. Okay. Chalo. So two identical copper wires W1, W2 placed in parallel as shown in the figure. They carry the currents I and 2I respectively in the opposite direction. Okay. If the two wires are separated by a distance of 4r, then the magnitude of magnetic field B, okay, between the wires at the distance r from W1. At a distance r from W1. Okay, so there are two identical copper wires. What is their length? Not mentioned. So we'll take case long wires, infinite in length. Okay, they are placed and they carry currents I and 2I. Okay, they carry the currents I and 2I. In what direction? Not mentioned, but opposite direction. The currents I and 2I. So let us take this current I in the forward direction. So 2I will be in the backward direction. We can define these coordinates also. These axes also. If the wires are separated by a distance of 4r, then what is the magnitude of magnetic field B at a distance r? Okay, ab dekho. To calculate B, we can again use relation as B is equal to mu h. Okay, mu naught h. It's free space, nothing is mentioned. Okay. What is the h we are going to use due to a long wire? H due to a long wire, I upon 2 pi rho. Okay, I upon 2 pi rho AH. Direction निकाल लेंगे क्या हो सकता है? I upon 2 pi rho AH. ठीक है? Now look into it. Okay. Now for simplicity, let us assume that this is the x-axis and this is the y-axis. Okay, this is x and y-axis. The first current is in the x direction, second current is in the y direction. Okay. So what is the direction of the first magnetic field AH1, that is known as AL cross arrow? AL1 cross arrow 1. AL1 cross arrow 1. AL cross arrow. Okay, so what is the direction of the first current? I have taken to be in the x direction. Now, where is the magnetic field required? I require the magnetic field at a point r, distance r from the first wire. So let us say this is the point of observation. Perpendicular from the first wire, that is known as arrow 1, and that is in the minus y direction as per this case. And perpendicular from the axis of second wire towards the point of observation, that is arrow 2, and that is upwards plus ay direction. Okay, plus ay direction. So for the first one, arrow 1 is minus ay direction. Minus ay direction. So what is the value of AH1? X cross y is z, minus यहाँ पे आ जाएगा, so that is minus z direction. Similarly, AH2 will be AL2 cross arrow 2. Okay, the second current, that is also in the minus x direction, and AL2 is upwards, that is y direction, and x cross y is z. X cross y is z, so this becomes minus az. X cross y z hai, so this is known as minus z. That is the direction AH2. That is what is known as the direction, that is the AH2. Clear? Okay, so both are in the minus z direction. Both are in the minus z direction, so they can be directly added. Vectors in the same direction can be added, na? Okay, so what is that? It is h1 plus h2. Okay, it is h1 plus h2, both in the z direction. Okay, both in the minus z direction. तो लिख लेते हैं, formula लिखते हैं दोनों का. And what is the h? It is given by I upon 2 pi rho. For the first one, what is the perpendicular distance? For the first one, the perpendicular distance is r. So for the second one, perpendicular distance will become 3r, because total distance 4r था. Because the total separation is given as 4r. Okay, so I upon 2 pi rho, rho is here, r, direction minus az. Second wale mein current is 2I. Okay, divided by 2 pi, the distance is 3r and direction is still minus az. Okay, so h is I upon 2 pi r, itna to common hi aa gaya, 1 and 2 pi r is common, so 1 plus 2 by 3 is extra into minus az direction. Okay, so the magnetic field H is known as 1 plus 2 by 3, 5. So 5I upon 3 to the 6 pi r, 5I upon 6 pi r az. Minus 5 upon 6 pi r az. तो अगर mod h की बात करें तो mod h is 5I upon 6 pi r. Okay, magnitude की बात करें and hence the magnitude of B will be mu naught into 5I divided by 6 pi r. Answer is C. 5 mu naught I by 6 pi r. Correct answer C. Yes, Lokesh. Correct answer C. So, based on magnetic field due to long wires, straight wires, important for you, इस पे questions बनते रहते हैं, बनते रहेंगे. Okay. चलो जी, next question then. Okay, next question. This is done. This was done. ये तो simple cases थे. This is also done. हाँ. Now next NAT question. In a certain conducting region H, is minus 4y cube AX. Okay, magnetic field is given. What is the current through a square of side 1 meter? Okay, with the corner at the origin. Okay, and the sides coinciding with the positive x and y axis. Okay, current through a square of side 1 meter. Okay, with the corner at the origin and the sides coinciding with positive x and positive y axis. Okay. No, that randomly I assumed, Bhanu. Okay, currents, both the currents are in opposite direction. So any one direction x, the other will minus x. You can take y minus y, anything. That was just assumption. Okay, to make you explain simply with the directions assumed. ठीक है, चलिए. Okay, so you have a square of side 1 meter and with the sides coinciding with 1 meter and x and y axis respectively. Okay. Okay, this is the square of side 1 meter. Closed figure. Okay, now what is the current? Okay, the current flowing, okay, the current enclosed, the current flowing through any closed surface is given by integral h dot dl. देखो दो तरीके से सोच सकते हो. Okay, either by the Ampere's law. Straight away you start with the Ampere's law. The current enclosed by any closed path is equal to the line integral of the magnetic field along the closed path, and then you can apply the Stokes theorem here. Okay, then you can apply the Stokes theorem here. H given है आपको. Okay, so what is the Stokes theorem? Integral del cross H dot ds. Surface integral curl of the vector. Okay, so we need curl of H. Or else what you can do is, okay, और आप यहाँ से S को ऐसे भी सोच सकते हो. You can directly start I enclosed as the current is the surface integral of current density. Okay, now here you can apply the Ampere's law, the differential form of the Ampere's law, one and the same thing. What is J? Del cross H. So J dot ds becomes del cross H dot ds. So ultimately, for any of the thing, in whatever direction you start thinking, we need del cross H. H is given to me. H has been given to me. Minus 4y cube AX. Ampere per meter. And the first thing I need is the current density to calculate the current, and that will be obtained as del cross H. And what's going to be the del cross H? Okay, curl निकाल लेंगे again. Unit vectors AX, AY, AZ. partial derivative terms del by del x, del by del y, del by del z, and the vector component, only x component is available, that is minus y cube, and y and z, there is no ay az term, right? Yeah, there is only the x term. Now this is further equal to ax del by del y 0, del by del z 0, minus ay del by del x 0, del by del z of y cube is 0, plus az del by del x to 0 hai, del by del x of 0 is 0, minus del by del y will give you minus 3 to z 12y square. तो यहाँ minus minus plus 12y square z direction. That is the current density. It is 12y square in the z direction. 12y square in the z direction. That is the value of the j vector. Okay, that is the value of the j vector. Okay, now what I need to do is, as I told you, it is integral del cross h. J आ गया ना, directly j लिख देते हैं. Okay, it is known as integral j dot ds. Now where j is along what direction? What is the direction? It is in the z direction. Oh, j, it is in the z direction. Okay, j is where? It is in the z direction. Now if j is in the z direction, what about ds? If j in the z direction, what about the ds? Okay, the differential surface area along z direction, we need to consider only along the same direction. Along perpendicular direction, dot product 0 hoga. So along az, the differential surface area is given by dx dy. Okay, so hence we start completing the result. I will be equal to integral, double integral because surface integral hai, 12y square az dot dx dy az dot az we know 1, that is why I have taken the same direction component only. 12 is also a constant. You need double integral y square dx dy, the limit of x and y, देखो, with the corner, one of the corner was at origin, so and unit and the side is 1 unit. Okay, so this is x 0 से 1, y also will go 0 to 1. Constant limit होगा because it's a rectangular portion. X is 0 से 1, y is also 0 to 1. Completing the integral quickly, separating the variable, dx का integral x, y square dy का integral y cube by 3. Both the limits are 0 to 1. So answer is 12. X 1 minus 0, it's 1. For y 1 cube minus 0 cube 1 by 3. So answer should be 4 ampere. Check out your calculation, guys. Answer should be equal to the current flowing as 4 ampere. In ampere, it will be 4. Check out the calculation once. Okay. Check out. It should be equal to 4. And confirm me. Done है? चलो, okay Abid. चलो done है, तो answer is 4 ampere. Next question. Here for you. The plane y equal to 0 carries a uniform current density minus 20 k milliampere per meter. What is the magnetic field intensity at x equal to 1, y equal to 10, z equal to minus 2? Okay. There is a uniform, there is a plane, a particular plane y equal to 0 is like xz plane, which is almost infinite in length. Okay. And that carries a uniform current density. So it is basically on what? Infinite sheet. The y equal to 0. The xz plane is infinite sheet carrying some current. So infinite sheet of current hai. Okay. And the magnetic field due to infinite sheet of current is given by half K cross A n cap. Where K is directly mentioned to you. Okay. K is the current density. Minus 20 K milliampere per meter. What is A n cap? What is the A n cap? The sheet is y equal to 0. That is xz plane. Okay, y equal to 0 is the entire xz plane. Okay, so you are at the xz plane and you need to go up to y equal to 10. Chalo, if you want to understand with picture. Okay. Which plane? Xz plane. Okay. Let's say this is the y axis and then let's say this is the Z axis. XZ बोला है ना? अच्छा. Okay. So I need to take Z. अगर इस डायरेक्शन में ले लिया, I will be taking Y vertical, no issues. ठीक है, Z cross X. हाँ, तो let's take Z here, regular XY. That works. That regularly works. ठीक है. So now the infinite sheet of current is in the XZ direction. Is it the, यहाँ से इससे coincide करते हैं, is in the XZ plane, Y equal to 0. Okay, and we have the point of observation, which is X1, Y10, Z minus 2. So Y is positive. Okay, so there will be point, randomly I can locate, suppose this is the point 1, 10, okay, 1, 10 and minus 2, Z is negative, that does, I just want to worry about Y 10 hai. Okay, so what is the unit vector normal to the sheet towards the point of observation? That is important, and that is known as AN cap. Okay, unit vector normal to the sheet towards the point means you are in the plus Y direction. You are moving parallel to Y, so it's going to be Y direction. Okay, rest is all value. This is a sheet carrying the current in minus 20K, minus Z direction mein current flow kar raha hai. If this is Z direction, so current on the sheet is along the minus Z direction as evident by its current density, and that current density is minus 20 milliampere per meter in the Z direction. Minus 20 AZ likh dete hain, milliampere per meter. Okay, writing down the values here. So H is half minus 20 AZ milliampere per meter cross AN cap, and AN cap हमने कितना लिखा? AN cap is equal to AY. Okay, that's the Y direction, and milliampere per meter will still be there. Now Z cross Y, okay, yeah, minus of Z cross Y will be Y cross Z, and that is X, and 20 by 2 is 10. Okay, so it should be plus 10 AX. Z cross Y is basically minus X, so minus minus plus X लिख लिया यहाँ पे. So it's basically plus 10 AX milliampere per meter. Plus 10 AX, that is plus 10 I cap milliampere per meter. Correct answer B. Yes, Bhanu, the very correct answer is B. Plus 10 A cap milliampere per meter. Okay, so continuity equation that we don't need here for any questions, but we just need to refer the continuity equation of current. You also, relate this with your theory in the EDC as well. Okay, the continuity equation which says that del dot J is equal to minus del by del T of rho V, that is J is the current density. Okay, the divergence of J is equal to minus del by del T of rho V. Okay, now why I am taking up the current the continuity equation here. Okay, this is the continuity of current equation, or simply just known as continuity equation, to again relook into the Ampere's law. Ampere's law for static field. Okay, we have seen that del cross H is given as J. Okay, so when I take the divergence of J here, when I take del dot J, that will become del dot del cross H. So del dot del cross H and del dot del cross H is divergence of curl of a vector is always 0, na? Yeah, you can also relate it to a scalar triple product property. A dot B cross C, scalar triple product, and in any scalar triple product, if two vectors are equal, then the resultant is 0. If the two vectors are 0, the two vectors are equal, resultant is 0. Okay. So del dot J will be 0. Okay. So as per the Ampere's law here, the del dot J is 0. Okay. But as per, just now I told you continuity equation of current. So as per continuity equation of current, okay, what is del dot J? minus del by del t of rho v, and if rho v is a function of time under time varying situation, okay, if this is time varying, assuming now the electric field now producing the rho v, okay, it's also time varying, and in the time varying situation, del by del t of rho v under time varying situation, okay, if it is a function of time, if it was constant with time, then the derivative is 0. If it is not a function of time, if it is independent of time, then the derivative will be 0. Our Ampere's law holds true. But if it is time varying, okay, it will be a function of time, and then we can calculate its derivative, which may have some expression. It's not necessarily 0, so we cannot say it to be 0. So Ampere's law is somehow inconsistent here. The Ampere's law is not consistent. Okay, in time varying fields. It is not consistent in the time varying field. So we need to have a modification to it. We need to have a modification to it. Okay, we need to have a modification to it. Okay, so we modify it slightly. Okay, how do we modify it slightly? These topics are conceptually just known to you, but not that important for numerical point of view. Okay, it is, okay, del cross H till now we were calling it as J. Okay, J, which is the conduction current density. Okay, now we will also add another correction term here, JD. Okay, we'll call another correction term here as JD. Okay, and now when you take del dot del cross H, del dot del cross H, okay, that will become del dot J plus del dot JD. Del dot del cross H 0. That is a basic vector property. Okay, it has nothing to do with time varying or time independent. Okay, that is del dot J continuity equation minus del by del t of rho v. Okay, as per the continuity equation plus del dot JD. Achha, that means the new term that we have added, correction term, del dot JD will be equal to del by del t of rho v. But as per the Gauss law, what is rho v? So I put back the Gauss law here. Okay. Now we are talking about time varying situations. So if the fields are time varying, okay, D definitely depends on time. We can differentiate with time, but del, that is a space derivative operator. It has nothing to do with time. So what I can do is, let me take that term inside. Let me take the derivative of term inside. So del dot JD is del dot del by del t of t. Okay, and JD, rate of change of flux density vector, rate of change of flux, electric flux displacement. Rate of change of the displacement flux is basically the JD, and that is known as displacement current density. Displacement current density. Okay, we now call this term as the conduction current density, leading to the conduction current density. Okay, this term, okay, known as the displacement current density. Okay, the displacement current. Any common example where you see displacement current? We're not deriving and not going into detail of it, but just I need to come up to the final Maxwell's equation, because the time varying final Maxwell equation required for wave propagation theory. Okay, direct question point of view, competitive exam, not important. Okay, the very common example, capacitor, representing the flow of displacement current. Because of the displacement of flux, the displacement of charge from the +1 to the +2, from the plate 1 to the plate 2. Okay, that displacement flux gives rise to the current flowing through the capacitor, and that sort of current is the displacement current. This is the displacement current density. Of course, this is the displacement current density. Okay, this is the displacement current density, and then, okay, the displacement current will of course be the surface integral of it. Okay, that is a displacement current. That is the displacement current, sorry. That is a displacement current. ठीक है. Next concept, not taking in numericals from here because you really don't get as such numericals from here. Okay, next Faraday's law. Okay, the Faraday's law of electromagnetic induction. Okay, the basic Faraday's law which states that if there is a static magnetic field, static se mera matlab hai what I told you earlier also, the static here means independent of time, which does not depend on time. The static magnetic field produces no current flow. Okay, a static magnetic field will produce no current flow, but a time varying field will produce an induced voltage, okay, in a closed circuit, and that induced voltage causes a flow of current. Okay, causes a flow of current. Okay, we know that a current can produce magnetic field. The question is, can a magnetic field, we know that current produce, okay, magnetism. Okay, current flowing through a wire, suppose, produces magnetism. Okay. Now, question is, can a magnetic field in turn produce flow of current, produce electricity? Faraday is starting hunting the answer for this question. Okay, and yes, a magnetic field can produce electricity, can produce rise of current in a closed circuit if it is, means if the magnetic field is time varying. And after several experiments, what sort of experiments, not needed here, but after several set of experiments, he came to the conclusion that the induced EMF, okay, in any closed circuit is equal to the time rate of change, okay, of the magnetic flux linked to the circuit. Okay, and VEMF, time rate of change, okay, minus del xi by del t. Okay, it is given by minus del xi by del t, that is the induced EMF, and where xi is the total flux linked through the circuit. Maybe there is a circuit consisting of n turns of wire, and let us suppose that xi is the flux through each turn of the wire, and suppose there are n turns, so the total flux will be, here we call lambda as n into xi, and where lambda is known as the total flux in that case, and xi is the flux through each turn. Okay, and the VEMF, the induced EMF, is then given by minus del by del t of lambda, and that is why I write it as minus n del xi by del t. Okay. Okay, VEMF is minus del xi by del t. Now, V is also equal to, neglecting the negative sign, considering the amplitude here, the VEMF is also integral E dot dl, as per the relations we have discussed in the before the lunch break, na? The relation between the potential and electric field. Okay, so let us say there are both electric and magnetic field present. So VEMF is integral E dot dl, but VEMF is also equal to how much? Now here we can write it as minus d by dt of xi, where xi is known as integral B dot ds. Where xi is known as integral B dot ds. The total magnetic flux is calculated by surface integral of the flux density vector. So we can write this as minus d by dt integral B dot ds. So that simply means that in the time varying situation, forget the VEMF. Now look into this part, which has a left hand side and right hand side. It clearly proves that in the time varying situation, there is a relation between E and V. There is a relation between electric field and the magnetic field in the time varying situation. In the time varying situation, both the electric and magnetic field are related. Okay, that in a time varying situation, both electric and magnetic fields are present and they are also interrelated. Okay, a time varying magnetic field induces a voltage, and if there is an induced voltage, there will be some electric field. That means in time varying, both of them are present and they are related. Okay, and they are related to each other. Okay, they are related to each other. Okay, now Now, when you talk about EMF, now basically there are two cases of EMF, and as per the EMFT portion, I need to only discuss with you right now. That is a transformer EMF. देखो, EMF भी जो है ना, we can discuss into two parts. I'll write down at least basic. I'll write down EMF. Okay, the electromotive force. Transformer EMF, motional EMF. Motional EMF, all electrical champions. Okay, you use entirely this motional EMF, okay, in the discussion of your generators, motors, and design of all the thing. Okay, transformer EMF is the case. Okay, transformer EMF is the case when you have a stationary loop around which you are calculating the flux. So let's say there is a single stationary loop, or maybe n turns, whatever. There is a stationary loop, but that is present in a time varying field. Okay, time varying field. In short, I will keep writing TVF. There is a stationary loop present in a time varying field. The EMF that develops here is known as the transformer EMF. Okay, motional EMF. Okay, when you have a moving, okay, you have a moving loop. Okay, a rotating loop, but in a static field. That is linked with the static field. But right now we are into time varying field, so that is why we will not discuss this motional EMF. Let's talk about this. If there is a stationary loop in the time varying field, if there is a stationary loop that is available in the time varying field. Okay, so if we have a stationary conducting loop in a time varying field, as I just told you, that EMF is, here we just call it as EMF, but that is actually known as transformer EMF. You can just know at least the points. Okay, so see here what I have written. Let's come back. I have written that VEMF is minus d by dt integral b dot ds. But what I am telling you is, listen to me carefully. Let me complete. If there is a stationary loop but in a time varying field. Okay, this is a stationary loop. We are integrating over a surface. And that surface is stationary, but this is time varying. I can say that all the points of the surface, whether it is the entire surface or any differential surface out of that body, this is not a function of time. This is stationary. It is not moving, but only this is a function of time. Okay, so I can also write down this equation. Only B is the function of time. Na? So what is d by dt doing outside? It can only be shifted with B. So minus of del B by del T dot ds. I converted into the partial derivative. Simple reason is B will also be a function of space. Na? See, I don't write d by dt. I write del by del T partial derivative, because any field is a function of distance. That we have known since beginning. Away you move, the field decreases. But here we are talking about the field which is also a function of time. Okay, so it's a function of multiple variable. That is why I write a partial derivatives minus del by del T minus integral del by del T ds. Okay, under the case that B is time varying and the loop is stationary under the transformer EMF condition. Okay, so I'll put it down here like this, integral E dot dl. Okay, let us shift this inside. And this is, now what is this? Okay, इस पे apply करेंगे Stokes law. Okay, that is what is done here. Yeah. So this is shifted inside. Now onto which I apply the Stokes law. Because this is the line integral along a closed path. Stokes theorem apply करेंगे. Integral del cross E dot ds. This is minus integral del B by del T dot ds. Both are surface integral. Now compare the integrands. When you compare the integrands, del cross E is minus del B by del T. Del cross E minus del B by del T. Okay, giving rise to the point that del cross E not equal to 0 in the time varying situation. For time varying fields, our Maxwell's equation, one more Maxwell's equation, one is already modified, that is the Ampere's law because of displacement current concept, and this is also modified. Okay, under time varying situation, okay, del cross E is minus del B by del T. Okay, it is minus del B by del T. Okay, that it also says that time varying electric field is not conservative. Static electric field is conservative, but time varying field is not conservative. Del cross E not equal to 0. Okay, conservativeness is not there. Okay, and by the combination of both the results, dear, we can also write down the final form of the Maxwell's equation. By the combination of both the results, we can write down the final form of the Maxwell's equation. Okay, we can form the final form of the Maxwell's equation. Okay, so what is the Maxwell's equation? What is the Maxwell's equation? Okay, so now earlier where we were talking about conservativeness of electric field, that has been replaced by Faraday's law, del cross E not equal to 0, but it is minus del B by del T. Final form, time varying field. Okay, for time varying field. Integral form bhi likha hai, but let me show you one. Others you can understand. Okay, del cross H was only equal to J due to Ampere's law. Now this is modified Ampere's law. Let me mention it clearly. This one is attributed to modified Ampere law, modification based on the continuity equation. Okay, that give rise to the displacement current density. That is J plus del D by del T. Okay, or we can also call it as JC plus JD. Okay, this is the conduction current density. This is the displacement current density. Okay, what is the formula for conduction current density? Sigma E. What is the formula for displacement current density? Del D by del T, which is already written in front of you. Then two of the Maxwell's equation, okay, which came up from the concept of Gauss law and magnetic monopole, they remain to be unchanged. They are in the similar form, del dot D equal to rho V, Gauss law, and del dot B, divergence of V always 0. Okay, even in the time varying situation, there cannot be any magnetic monopole. Okay, so both the equations you can say like that, which are related with the curl, they have been modified. Both the divergence or the results remains to be similar. This is the final form of the Maxwell's equation. The very final form of the Maxwell's equation. Okay. Now next, yeah, let us also cover up the boundary conditions. Okay, यहाँ से भी question आता है कई बार. Okay, first let us start with the dielectric boundary condition, and I'll tell you the boundary condition for both electrostatic, electric fields as well as magnetic field. Okay, the conditions that must exist on either side of the boundary if there is a boundary separating two media. Okay, let's say this is some boundary. Okay, on one side of it we have the electric field, one side of it we have the region 1, on one side we have the region 2. How do we classify the region? Both the sides have different permittivity. So this has some permittivity epsilon 1, this has some permittivity epsilon 2. Okay, on one side of the field there will be electric field which is known as E1, on another side there will be electric field E2. What is the relation between the E1 and E2 at the boundary? Near about the boundary, at the boundary, those conditions which decide the relation between E1 E2 at the boundary is known as the boundary condition. Okay, now what we are going to do is we are going to break E1 and E2 both in the tangential and the normal form. So what is the tangential and what is the normal form? Suppose let me take this point, okay, and let us say this is the electric field E1. Okay, now this electric field can be decomposed into one part which is going tangential to the boundary and another part which is normal to the boundary, perpendicular to the boundary. Okay, decomposed. Similarly, there may be electric field E2. Okay, there may be electric field E2 in some random direction. Okay, this electric field E2 will also have a component which is along tangential and along normal to the boundary. Okay, so ET and EN are the tangential and the normal component. Okay, tangent to the, the direction which is tangent to the boundary, the direction which is normal to the boundary. Okay, you have to separate the electric field, given electric field, into two parts, tangential and normal. How do you separate? With question you will understand that also. Okay, with question you will understand that also. Okay, so what are the conditions that will exist for you? Achha, it is not written. Okay, I'll write down the conditions that will exist here. Okay, again derivation not required. These are again derived using Maxwell's equation only, nothing new. They are derived using Maxwell's equation. The condition that turns up is number 1. Okay, the tangential component of the electric field is continuous at the boundary. Okay, that means E1t, the tangential component of the first field, the tangential component of the second field is equal. Okay, these two will always be equal. Okay, the tangential components are continuous at the boundary. Okay, so let me put down this as the result with respect to tangential components Okay, we'll have two boundary conditions, one giving the conclusions for tangential component, another one for normal component. Okay, so E1t equal to E2t. Tangential components will be continuous at the boundary, maintaining same value. Continuous means maintaining same value either side of the boundary, and the second result will be normal components. Okay, with respect to normal component. What will be the condition with respect to the normal component? Okay. Normal component में we'll first write down the condition with respect to the flux density vector D. So we get the result D1n minus D2n is equal to rho s. Okay, D is the electric flux density vector. Okay, D1n minus D2n equal to rho s, where rho s is known as if there is any surface, if there is any free charge existing on this boundary, on this surface, if this surface also contains some charge, that charge density over the surface will be known as rho s. Okay, so surface density at the boundary, we can call it as interface, okay, charge density. If there is any particular charge on the interface, okay, that is the interface matlab boundary. Okay, any charge density at the boundary, that is rho s. But if rho s is 0, if there is no free charge at the boundary, okay, then you will have the continuity of the normal components of the flux density vector. D1n equal to D2n. Acha, most commonly question will be in terms of electric field E, not in terms of D. So start with D1n equal to D2n, and dear, if D1n equal to D2n, so you can also write na D is epsilon E. So first video में epsilon 1 use करेंगे, तो epsilon 1 E1n is equal to epsilon 2 E2n. Epsilon 1 E1n equal to epsilon 2 E2n. So there you can find the relation electric field normal components also. So देखो, every electric field E1 will be given. We need to find E2. ठीक है? तो E1t and E2t ये तो same है. Okay. देखो, let me put it like this. Okay. How to break the tangential and normal component, that I will tell you. वो मैं आपको अलग से बताता हूँ. With question I'll explain. This is given. Okay, E1. The question is E2. Okay, E2 can also be broken as E2t plus E2n. This is the question mark. So what is the answer? Okay, E2t is same as E1t. So that is given. Given means given. What is E2n? So dear, what will be E2n? Just remember this condition. No need to mug up E2m formula, but just I'm adding here. E2n कितना हो गया? Epsilon 1 by epsilon 2. That will be equal to epsilon 1 upon epsilon 2. Epsilon, कहाँ गया? Epsilon 1 upon epsilon 2 into E1n. E1n given है ना? तो epsilon 1 by epsilon 2 E1n. So we can find the second electric field also. Okay, how to apply in the questions we will see. But one more condition before we go to the question, and that is the conductor to dielectric boundary condition. That is the conductor to the dielectric boundary condition. Conductor to the dielectric boundary condition. Acha. Now, let's say you have a boundary. Okay, simply assume that. Okay, let's say you have a boundary separating a dielectric and separating a conductor. On one side you have conductor. Let's say this is the conductor and this is the dielectric. First one is dielectric. Okay, second one is conductor. Okay, electric field E1 is known to you. Okay, let us say this is some electric field E1. Okay, let us say this is some electric field E1. Okay, and I can again break it into a tangential part and a normal part. Okay, that is E1t and E1n. Okay, but what about the electric field inside a conductor? What about the electric field inside a conductor? What we have discussed about the electric field inside conductor? Tell me. What about the electric field inside the conductor? Waveguide is not in the EE part. Today is EC plus EE common part, Chirag. Yes, so electric field inside the conductor, basically the main reason to that attributed to skin effect. Very correct, Prabhanjan. Okay, so electric field inside a conductor, because it is a conductor, na? Okay, so the electric field E2 would be 0. Okay, if E2 is 0, that electric field can also be broken into tangential and normal, but if the field is 0, both of them will be 0. Both of them are 0. Now, conditions to same रहेंगी, whether it is conductor, conductor, dielectric, dielectric. The same condition that I have written here, na, I am applying here, and now we can say that as per the boundary condition I discussed, E1t will be E2t, but what is E2t? That is going to be 0, so E1t is also 0. Now, if E1t is 0, this means an important condition. If E1t is equal to 0, this leads to an important condition that the electric field E1, okay, will not have any E1t component, will only have the E1n component. The electric field which is in the dielectric, okay, is having only the normal component. That means any electric field which is present external to the conductor, which is present external to a conductor, can only have normal component. Can only have normal component. Can only and only have normal component. Electric field can be normal to a conductor. There cannot be any other component. Okay, no other direction, no tangential direction, only normal component will be available. Electric field external to a conductor is always normal to it. Okay, is always normal to it. Okay. Acha, because E is equal to 0, na? One more thing, I think the key points will come up here. Okay, so सबसे पहले, an electric field is external to the conductor, inside the conductor is 0, and that external field is always normal to it. That external field is always normal to it. Okay, acha, now what is that normal component? Now, ये तो हो गया first max, ये तो हो गया first boundary condition. ठीक है, ये apply किया. Now, what is the second boundary condition? Second, I told you D1n minus D2n equal to rho s in general. General वाला, assuming that there is some surface charge. Okay, but भाई जो second वाला है वो तो conductor में है ना, तो D2n तो 0 होगा, so there will only be D1n, that is rho s. Okay, so it is only having the normal component, and what is that normal component? E is epsilon. Sorry, E is d by epsilon. भाई D कितना होता है? D is epsilon E. So this is epsilon 1 E1n. Okay, epsilon 1 E1n. So what is the E1n? Okay, that can be written as rho s by epsilon 1. Rho s by epsilon 1. Rho s by epsilon 1 in the normal direction. Okay. So it will only be normal. Okay. No electric field exists within the conductor. E is 0. Okay. Acha. Electric field is 0, and electric field, as per the relation with potential, electric field is also the negative of gradient of V. Okay. So, if the gradient of V is 0, gradient means what? Rate of change of V with respect to space. Space rate of change of V. That means, when you move in space, time ki baat nahi kar raha, when you move between any two points in the space on the conductor where electric field is 0, okay, within any conductor electric field is 0, and when you travel any 2 points within the conductor, okay, the gradient of V, rate of change of V is 0. That means rate of change is 0, derivative is 0, means the quantity is constant. That quantity is constant. The potential here and potential here will be same. Suppose V1, V1. Okay, so there can be no potential difference between any 2 points in the conductor, and that is why conductor is an equipotential body. Okay, some important points, important for concept, important for factual question also. Conductor is always an equipotential body. Okay, the conductor is always an equipotential body. Okay, you charge it to any potential, entire body will be at that potential. Conductor is an equipotential body. Okay. नहीं प्रवंजन, I'll tell you what is the point. I got your doubt. What is the point you're telling me? Explain करता हूँ. It's not the boundary along a particular axis, along a I'll tell you something like that you're telling. देखो, suppose आपने बोला boundary z equal to 0 है. Okay. Then the normal direction will be z. But boundary is not z axis. Boundary is z equal to 0. So your statement now I think you get. Because if I talk about the boundary which is z equal to 0, so that is known as xy plane. Okay. That is known as xy plane. So what is the vector direction to the, what is the vector perpendicular to xy plane? If this is y, if this is x, this is the xy plane. Let us say this is the horizontal. So this vertical direction will be the z direction. Na? So if z equal to 0 is the boundary, then a n cap is az. That means boundary is z equal to 0. Boundary is not z axis, boundary is the xy plane. ठीक है. So yeah, ये generally true है. Suppose they give you boundary z equal to 0, a n cap will be az. Clear everybody now? Okay, xy plane. This is xy plane. This is y axis. This is x axis. I've taken x axis here means outwards. Okay, so this is the xy plane, horizontal one. Okay, so what is the vector normal to it? Z direction. Z direction. ठीक है. Similarly, if I tell you, अब देखो यहाँ पे बात छेड़ा है तो इसको नोट ही कर लेते हैं. तो similarly, if I tell you in any question, this is very common data. In any question, if they give boundary x equal to 0, okay, boundary x equal to 0 का मतलब होता है yz plane. So what is the an cap? That turns along the x. Okay, and similarly, if they give the boundary y equal to 0, y equal to 0 is actually nothing but xz plane. So what is the vector normal to xz? Is the y direction. तो देखो ये वाला y आएगा यहाँ पे. Okay, hope Prabhanjan that is what you were asking. If there is something else, let me know. ठीक है, चलो. अच्छा. So before we go to any question, let me also review the magnetic boundary condition and then let's take the question. Okay, so magnetic boundary condition. Magnetic boundary condition. Again, there is a boundary separating two regions, region 1 and region 2. Say this is region 1. Okay, having permeability mu1 now. We'll talk in magnetic terms now. Region 2 permeability mu2. This has some magnetic field H1. This has some magnetic field H2. Okay, where where H, okay, maybe in any direction, but we can break it. One along the tangential direction, one along the normal direction. One along the tangential direction, one along the normal direction. Okay, ji. Okay, so the conditions that will exist here. Okay, the conditions that will exist here. Okay, similarly, there can be H2. Okay, it can also be decomposed into tangential part and the normal part. And what is the result given by? The first one by one. First, let us write down the result here with respect to normal components. Again, the normal components where flux density will come basically. And here, you will obtain after solving from Maxwell's equation that B1n will be equal to the B2n. The B1n will be equal to the B2n. The B1n will be equal to the B2n. Clear? That is the normal component. Okay. Now, tangent. अच्छा, देखो, यहाँ से again, if the question is commonly on H, so you can replace in terms of H. Now, B is mu H. So, mu1 H1n will be the mu2 H2n. Okay. Now, second condition. Tangential component, इसको separately लिखते हैं. This requires some calculation that I will show in the question. Tangential component result. In general, the result is given by vector H1 minus vector H2 cross AN12 is equal to vector K. Cross AN12 is equal to vector K. Okay, now what are these terms? Just allow me, I'll explain you. H1 minus H2 cross AN12 is vector K, where AN12, AN stands for normal to the boundary. So we have a unit vector. We have unit vector normal to the boundary. Okay, but to be specific, 1,2 specifies that from region 1 up to the region 2. From the region 1 up to the region 2. From the region 1 up to the region 2. Okay. Now what is K? K is known as the interface current density. If the interface carries some current, interface current density in ampere per meter. Okay, yeah. So basically now this is the general formula, but in case if there is no interface current, if the surface is current free, okay, if K equal to 0, then you will have H1T equal to H2T. Then directly you will come to the tangential component result if K equal to 0. Okay. Now, how to apply this to the problem? ये समझते हैं one by one. First, let's take the problem on electric boundary condition. ये आ जाते हैं. Here it is. Two extensive homogeneous isotropic dielectrics meet on the plane Z equal to 0. Okay, meet on the plane Z equal to 0. Achha, let me do one more thing here. Boundary, 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 boundary. So ये लीजिए आपका password. The password, okay, as you all know that my PDF will be password protected. It will be available in the Telegram with a password protection, and the password for today's class PDF will be boundary. B-O-U-N-D-A-R-Y. It's going to be boundary. B-O-U-N-D-A-R-Y. B-O-U-N-D-A-R-Y. Clear, everybody? Okay. Now, password you will get in the PDF you will get in the Telegram as always. The PDF you will get in the Telegram as always. I'll check the link of the Telegram. By the time, just go through the question also. Yes, guys. So I've shared you the link of the Telegram. Chalo. Okay, so two extensive homogeneous isotopic dielectrics meet on the plane Z equal to 0. Acha, if they meet on the plane Z equal to 0, that means Z equal to 0 is separating both. Boundary hai. So what is the A and cap? I'll anyways draw the picture also, but I already explained you. If the boundary is Z equal to 0, then the unit vector normal will also be Z direction. Okay. Now for Z greater than 0 and Z less than 0, there are two relative permittivities given to you. A uniform field E1 exists for Z greater than equal to 0. E1 is given to you. Okay, find E2 for Z less than 0. Okay, so say this is the z-axis and this is z equal to 0. So this is going to be my first region, okay, where z is greater than 0, and this will be correspondingly my second region, z less than 0. In the first, epsilon R1 4 hai, and the electric field E1 is also given to you. Okay, and that electric field is 5 minus 2 and 3 kilovolt per meter hai. 5 minus 2 and 3 kilovolt per meter. Okay, and find the E2. Epsilon R2 given hai. Epsilon R2 is 3. What is the electric field in the region number 2? Okay, already I explained you what is the normal to the boundary is AZ. अगर यहाँ पे specify करें, अगर यहाँ पे sketch करें. Okay, so this is what will be this is the boundary. So normal to the boundary. एक second. Z greater than 0. Perfect. So what is the normal to the boundary? That is known as AZ. Okay, that is known as the AZ. Clear? Acha. Now if this is the normal to the boundary, okay, what is the normal and tangential component? Electric field E1 given hai. The question is very straightforward now. Electric field E1 given hai, and that is 5AX minus 2AY plus 3AZ. Okay, kilovolt per meter. Achha. Where is the normal to the boundary? Normal to the boundary is Z. Okay, normal to the boundary is z. So this will be known as the E1n component. Okay, so remaining term will be the tangential component. Simple na baba. Normal component is the component which is normal to the boundary, and that is 3. Okay, so what is the term tangential to the boundary? That is the other one. Anything other than normal will be tangential. That is how you have to classify. Find the normal to the boundary. Okay, see the normal component, remaining one is tangential component. Okay, now यहाँ से हमने निकाला E2t. E2t is also E1t. देखो, I told you ना, the answer for electric field E2 is very simple. E2 is also given as E2t plus E2n. Okay, what is the E2t? That is E1t. That is same. 5ax minus 2ay. Okay, plus what is E2n? तो यहाँ से हम E2n निकालेंगे. What is the relation? See, I told you, remember the relation d1n equal to d2n. No surface charge is mentioned, matlab there is no surface charge, and that is why now I convert epsilon 1 E1n equal to epsilon 2 E2n. From here, what is the value of E2n will be epsilon 1 by epsilon 2 E1n. Okay, epsilon 1, okay, which is 4 epsilon naught. Epsilon 2 is 3 epsilon naught into E1n, and E1n is 3az. Okay, so epsilon not cancelled, 3 cancel, it's 4az. So यहाँ पे next part आ गया 4az, and everything is in kilovolt per meter. You have got your answer. Simple, a simple activity. 5ax minus 2ay remains same, plus 4az kilovolt per meter. 5ax minus 2ay, answer लिख दिया यहाँ पे, that is the answer. 5ax minus 2ay plus 4az kilovolt per meter. Kilovolt per meter. Done है? Done है. चलो, check it out. Plus 4az, Chirag, just check it out once. It's plus 4az. Okay, ji. So if this is understood, kindly take one similar question as homework. Kindly take one similar question as homework. इसको orally solve कर दें. इसको orally solve कर दें. देखो. Boundary क्या है? देखो. Boundary y equal to 0. So what is the normal to the boundary? Y direction. See, oral answer. Sometimes MCQ में oral answer. Otherwise you can solve it also. Boundary is y. Okay. That means this is the normal direction. Okay. So what is the E1t? Other than normal, you have tangential. 3ax plus 2az. Okay. So E2t, whatever is the answer, it should have 3ax plus 2az. Only option number A. No homework. Khatam. Not always, but sometimes. Answer 100% should contain 3ax plus 2az. 110% answer should contain 3ax plus 2az, right? 3ax plus 2az. 100%. होना ही चाहिए. Three ax plus 2az. Okay जी. चलो next. The xy plane serves as the interface between two different media. Okay, so plane here is xy plane. Okay, that is z equal to 0. XY plane means z equal to 0 plane. The medium one, z less than 0, is filled with a material whose mu r is 4. Medium 2 is filled with the material whose mu r is 4. If the interface carries the current, interface current is also given. Interface carries a current 1 upon mu naught ay. Okay, that is what I called it as k. 1 upon mu naught in the y direction. Units are given as milliampere per meter. And B2 is given to you. Find H1 and B1. First, let me present this picture. Okay, so XY plane. The boundary is z equal to 0. Let me draw the z axis. Let me start by the z axis straight away. This is the boundary, z equal to 0. This is the positive Z axis. Now what they have told is here the region 1 is Z less than 0. So the bottom one, negative Z, I'll call this as region 1 Z less than 0, which has the relative permeability how much? Mu R is 6. Okay, so mu R1 is 6. Okay, and this is the second one, okay, which is Z greater than 0, and in this you are given mu R2 and that is equal to 4, I think. Yeah, Z greater than 0 पे permeability 4 है. K is given. Now B2 is given to you. H1 B1 निकालना है. B2 is given to me. Sorry, ये ऊपर. B2 is given to me, and what is that B2? 5 and 8 X and Z के फॉर्म में 5AX 8AZ. 5AX 8AZ milli Weber per square meter. Milli Weber per square meter. Okay, find H1 and B1. अच्छा, what is the AN12? I told you, here we need normal vector. Okay, magnetic boundary condition में क्या बोला था? The normal vector, normal to the boundary, but from region 1 to region 2. Be very careful. So what I need is AN12, the normal from the boundary, normal to the boundary, but from 1 to 2, and that is clearly in the positive Z direction. Achha, if this is in the positive Z direction, this is known as the normal component. The Z component vector, the Z component term is the normal component, so this of course becomes the tangential component. Okay, what was the first boundary condition, dear? What was the first boundary condition? B1n is equal to B2n. Okay, so what is B1n? That is simply equal to B2n, and that is 8AZ. First was normal condition boundary, na? Normal component boundary condition. B1n is B2n and B2n is 8AZ. Unit भी copy करेंगे milli Weber per square meter. Clear? So B1n is obtained. Okay, now अच्छा B1n आ गया तो H1n भी निकाल सकते हैं. B is mu H, तो H1n is B1n. फर्स्ट रीजन की बात कर रहे हैं तो mu1. Okay, mu1. So what is going to be H1n? And H1n is going to be 8. mu1 is 6 mu naught. Mu r 6 तो relative permeability है. तो 6 upon mu naught AZ milliampere per meter. H है तो ampere per meter. Okay, we'll simplify later. So we have B1n and H1n both. ठीक है? अच्छा. Now what is the second condition? Second condition, whenever there is surface current density, then H1 minus H2 cross AN12 is given by K. अब इसको थोड़ा सा solve करना पड़ेगा. This is slightly 1 or 2 steps calculative. Okay, and for this, what is H1 is not known to me. Sorry, H2 is known to me. B2 पता है, मतलब H2 भी पता है. Okay, B2 means H2 also known. Okay, so what is the H2? H2 can be written as B2 by mu2, and B2 is 5AX 8AZ, 5AX 8AZ divided by mu2, and mu2 is 4 mu naught. Okay, H लिख रहा हूँ तो milli ampere per meter. This is known to me. But what about H1? H1 is what we are trying to find out now. Okay, H1 is what we are trying to find out. So let us say that H, in general, a vector can have 3 components, na? X, Y, Z. H1 X AX, H1 Y AY. Okay, and then H1 Z. First ही निकाल रहे हैं ना ये, हाँ. So let H1 is this particular vector. Out of which something I know. Something I know about H1, and I know the normal component, and normal here is Z. Okay, this is known to me. This is 8 upon 6 mu naught. This is already figured out. Okay, these two are not known to me. These two are not known to me. Now I will put this into this equation. What is the AN12 AZ? K का value given है. Okay, let us put everything inside this equation. Yeah, let us put it inside the equation. So H1 minus H2. H1x AX, H1 by AY plus H1Z, which is 8 upon 6 mu naught. Okay, AZ. Okay, minus H2. H2 is B2 by mu2. Okay, which becomes 5 by 4 mu naught AX plus 8 by 4 mu naught AZ. 8 by 4 mu naught AZ. Correct. Whole multiplied by Z direction. Whole multiplied by Z direction. This is equal to K, And what is the K given? एक बार check करेंगे. The K data is 1 upon mu naught y direction. And milliampere per meter. Here also everything was in milliampere per meter. देखो, even if you substitute the Z or not, it's not going to matter because now you start multiplying the cross product with Z. Okay, one by one. X cross Z. You will have X cross Z. Z cross X Y होता है तो X cross Z minus AY. Then next term will be Y cross Z. ये वाला Y outside with this Z. Okay. Y cross Z is X. Third will be automatically Z cross Z. Okay, that is 0. Okay, so even if you write this or not, ये पता है, but ठीक है. Let me put it as H1Z AZ only as of now. Even if I know it, forget it. Because when you take Z cross product with Z, that's not going to be required. That will be 0. Okay, so now let me start. H1X minus AY के साथ आएगा. H1X minus AY. Okay, plus H1Y. Okay, plus H1Y. इसको पूरा ही solve कर ले क्या X cross Z को? Okay. X cross Z here also, X cross Z here also. First one, okay, H1X minus 5 by 4 mu naught. इन दोनों को common ले लिया ना? H1X minus 5 by 4 mu naught. X cross Z will be minus AY. This is further minus AY. Then plus. Okay, now again I take common. H1Y minus the Y component from there. 8 by 4 mu naught. 8 by 4 mu naught. Then I have these two are Y. नहीं यहाँ पे there is no Y there. Sorry, ये Y है ही नहीं. So only H1Y. Only H1Y. Y cross Z. Y cross Z is X. And then plus. Right, Z cross Z will be 0. ये वाला Z भी 0. ये वाला Z cross Z भी 0. Okay, so nothing else is left. Let me go to the right side, which is 1 upon mu naught AY. Okay. Now, what does it mean, dear? What does it mean? You have to compare two vectors. So corresponding x to x and y to y component will be equal. Okay. So this is y component. Okay. This will be equal to. This will be equal to. ये minus के साथ है तो this will be minus 1 by mu naught. Okay. And this will be. There is no x component on the right side, so this will be 0. Okay. H1y is 0. Okay. Then H1x minus 5 by 4 mu naught multiplied by minus 1. तो minus यहाँ लिख दिया. That is minus 1 by mu naught. Okay, so what is the H1X? Okay, 5 by 4 minus 1 into 1 upon mu naught. 5 by 4 minus 1 is 1 by 4. So 1 upon 4 mu naught. ये आ गया H1X. Okay, so what is the complete vector H1 dear? What is the complete vector H1? X component आ गया 1 upon 4 mu naught. 1 upon 4 mu naught AX. Okay. Plus 0 into AY. And what was the Z component? 8 by 6 mu naught. 8 by 6 mu naught Z component. Everything was in milliampere per meter. Don't forget. Okay. So final answer H1. Okay. We can take the mu naught outside. 1 upon mu naught. Okay. 1 upon 4 AX and 8 by 6 को simplify कर दे 4 by 3 AZ milliampere per meter. That is the answer. Then what is the B1? Okay, one step में B1 भी लिख देते हैं. B1 is mu1 H1 and mu1 is 6 या 4. mu1 वाला है 6 या 4. mu1 है 6. Okay. Okay. 6 mu naught into H1, which is 1 by mu naught, so mu naught get cancelled. 1 by 4 AX, 4 by 3 AZ, unit milliweber per square meter. So final answer for B2. Final answer for B2, mu naught cancel. 6 by 4, 1.5 AX plus 6 into 4 by 3, that will become 8. 8 AZ milliweber per square meter. अच्छा ये तो separately 8 निकाल दिया था ना. The normal component was anyways 8 AZ. ये separately भी written है. Okay. So these are the answers in front of you. Answer for H1. Answer for B1. Sorry, this is not B2, this is B1. H1 and B1. Okay ji, done. So if this is clear, okay, take a problem for homework, practice. Okay, a current sheet J, देखो ये J है, J means that same K. This is same as the K I was telling. There is a current sheet, okay, which is lying on x equal to 0, which is the boundary. Current sheet lies on the boundary. That means boundary has some current. Okay, and then x less than 0 is region number 1. X greater than 0 is region number 2. Okay, there is region 1, there is region 2, and interface carries some current. Okay. The parameters of both the regions are given. Magnetic field in region 1 is given to you H1. Find the magnetic field in region 2 at x equal to 0 plus. Matlab, I told you the boundary condition, just below the binary and just above the boundary. Just below and just above the boundary. That is what you need to relate and give the answer here. Okay. All right. Done. So we are done for the day. It's almost 6 hours or little more than 6 hours of session. Okay. Retarded potential कल एंटीना में डिस्कस करेंगे. Retarded potential. Okay. Antenna में कल डिस्कस करेंगे. I'll give you the hint there. Anyways, we don't need a derivation in antenna. Okay, that when we are deriving the field of a Hertzian dipole, there we'll talk about the concept of retarded potential. But still, just remind me there, Jashwant. I'll tell you. Okay. Chalo guys. So the mathematics event on YouTube. Complete mathematics, big syllabus of maths. So 2 different days, Saturday and Sunday, both morning hours, 10 a.m. we are starting. Okay. And Friday 5 p.m. we will first have a general strategy discussion to ki bhaiya 13 out of 13 ka scope kitna hai, how to target the full. That discussion, a small discussion on Friday followed by Saturday Sunday events. Friday 5 p.m. Okay. And other than that, yes, as I told you, BYJU'S exam prep app download kar lijiye. There are lots of courses also available. Okay, password already told. So in case if you or your juniors willing to prepare for gate 25 or 26, okay, both the batches are now live on the app in English as well as Hindi formats. Okay, in the English as well as in the Hindi formats. Okay, so you can choose any of your batch as per your comfortability to get live classes, also with the facility of recorded lectures, study material, mock tests, practice quizzes, everything to get you exam ready by your favorite faculties. Telegram link मैंने आपको already share कर दिया. You will find the PDF there. A very important point now, let me tell you, is कि tomorrow, as I told you, the plan is slightly changed. Rather than the complete EMFT for EC, we are focusing tomorrow on the antenna. Tomorrow we are focusing on the antenna. Okay, on the antenna theory. Everybody clear? Okay. Not very important, Prabhanjan, controller compensator, but just basically go through it once, that is okay. General aptitude marathons, just now we taken Chirag. Sunday and Monday on the app, almost a lot of topics of general aptitude finished there. Important की बात करोगे तो सारे कर लिए थे. Okay. So whatever at least is required for the end hour, for the end study, that is completed on the aptitude marathon also. Okay guys, so as I told you, we saw a slight disappointing attendance today, and today is ECEE combined. I was doubting how much EC will be there, and with this attendance, continuous. So today also 6 hours, 7 hours complete, 6 hours complete, and EC complete part definitely 6 hours nahi lagta. That will definitely take 8 to 9 hours. Wave propagation, transmission line, antenna, wave guide. Okay, so you decide tomorrow. Okay, how the attendance will be. Tomorrow I'm first starting with the important. Let's not miss the important. I'm not saying no to take. I'm ready. I'm coming tomorrow to take it live. Antenna, starting, the only difference is starting with the very, very significant chapter jahan students normally they miss it at the end time. So I make sure that even if you have not studied antenna, you don't miss it up in the exam and you get the questions. Okay. And then tomorrow, by looking into attendance, I will decide, yes, if you're really interested, the other parts of EC also, like wave guide or wave propagation, whatever you say next, I will plan it. Okay. But antenna ko अच्छे से focus करेंगे. Take it tomorrow, antenna. Bye bye. Thank you. Stay safe and take care. See you tomorrow on the same channel. Okay, in case if you're not subscribed, be subscribed so that you get regular updates about all activities happening.